Hello and welcome to DevFest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for DevFest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local DevFest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes DevFest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Let me introduce you to my teammate, David, to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's DevFest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with DevFest since the very first year in 2010, when I was able to join a large percentage of them. Back then, they were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. I'm happy to be able to continue this celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture, but when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozzaako ddagala okulaba nti akako kulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obwo ssebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do. But then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetonya, tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for DevFest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the data set didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we will use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we are going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installed the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our train variables here using the dataset beans that we've just seen. And now we are going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data it didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all the metadata Android Studio needs to recognize it and automatically build classes for it.
To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies. Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback, here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we'd probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real-timey sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting, and I could start using that information to maybe refine my MLKit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app, but if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook.
And don't forget about the web. I've built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers.
This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too. We'd love to help you with this, and you can learn more about the process at opensource.guide/startingaproject.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter. Follow @GDG on Twitter for highlights from DevFest around the world, and try out the DevFest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #DevFest.
Hello everyone, I'm Louisa from the Google Developers team, and I'd like to welcome you today to the very first UK and Ireland DevFest. We're really sorry we can't be together in person, but I know you're going to have a brilliant time with us today, as it's a rare opportunity to get to hear from and interact with developers from across the UK and Ireland and beyond. I'll hand over to Jen now, one of the main organisers of today, to tell you more about what we've got lined up for you. Enjoy DevFest.
Thank you, Louisa. Hi everyone, I'm Jen Ashley, and I'm one of the many GDG leads who are delivering this event to you today. There are 16 Google developer groups who came together to plan and create a wonderful event for you. We are also joined by 2 developer student clubs who have been very active in spreading the word to the student community in the UK and Ireland. I feel very fortunate and happy to have worked with these 29 other individuals to deliver this to you today. Please meet the team. So thank you to this wonderful team, and to you, our attendees and speakers. Thank you for being here, and enjoy the rest of the conference.
Hello, everyone, and welcome to the Cloud Track for UK and Ireland DevFest 2020. My name's Tim. I'm an organizer with GDG Bristol, and I'm really pleased to welcome you all today. We've got some really exciting talks, some really interesting presenters and speakers. So just a couple of housekeeping slides to get through before we get right to it. We have a code of conduct for the entire event. If you haven't already read this on our website, please do so. This applies to the whole event, including our live chat. And we'd love you to tweet and post about everything we're doing today. Please use the hashtags DevFest and DevFestUKI in your social media posts because we will be giving away prizes if we pick some of those posts out. There'll be different hosts without you throughout the day, introducing different parts of the agenda. So I'm going to introduce our first host for this morning. Please welcome Goran. Hi, Goran.
Thanks, Tim. Hi, Tim. Thanks very much for the introduction. Hi, everyone. As Tim mentioned, I will be the host for this part of the morning before the coffee break later. So we have 3 talks, each roughly around 25 minutes, with 5 minutes a little chat between them. So the first one is Getting Started on Google Cloud Platform by Tiago, who is a custom engineer at Google Cloud. And next one we have at 10:45. It will be actually Tim, who is the track leader. So Tim has volunteered to step in last minute. So thanks for that, Tim. He will be talking about who's afraid of the big bad container orchestration system. Ooh, that sounds interesting. And last one before our coffee break, we'll be discussing about rapid prototyping, fail fast while building business first zero-cost solution with apps script, and it will be Sourabh. So without further ado, enough with the suspension. We can introduce our first speaker for today. So there will be Tiago, as mentioned before, who is the custom engineer at Google Cloud. Hi, Tiago.
Hi, Goran. Good morning, everybody. Thanks for having me.
Thanks for joining. Tiago is a custom engineer at Google Cloud in Portugal, right?
That's right, yes. I'm currently based in Portugal. I did live in the UK for just over 6 years before I decided to move back to my country. So I've been working here since.
Yep, that sounds great. Yeah. So before starting with your talk, I'm sort of going to the whole situation. Will you be able to tell us the furthest place that you traveled this month?
I think the furthest I traveled this month was actually the Azores, which is an island in Portugal. That's the furthest I could go given the situation.
Oh, that's actually sad. Sounds good. I can tell for myself, I don't know about Tim, but the furthest I traveled this month was my local park. So it's around 500 meters from my house.
Yeah, I think you beat me on that one, yeah.
Oh, is it? That's good. Okay, that sounds great. So Tiago, when you're ready to share your screen, and we can kick off with the first talk.
Thanks, Tiago.
Okay.
Thanks, Goran.
Perfect. Again, thanks, everybody. I hope you can see my screen. So as a customer engineer, I get to work with our customers and our partners, in this case in Portugal, helping them building solutions on Google Cloud. So for today, I've prepared about Google Cloud Platform. We'll have a look at how we can get started and then some of the key building blocks of the platform. But before we go there, I guess the first thing that comes to mind if I say the word Google is this, right? It's a search engine, which is now, by the way, 22 years old. And the reality is that over the years, we've actually deployed probably one of the largest IT infrastructure systems in the world in order to serve this massive application. We have regions across the globe. We have really powerful backbones connecting those regions. and then huge capillarity to be able to take all that traffic to you as the user on whatever device. But we didn't stop there, of course. So search was the first massive application. But actually, at the moment, we have 9 services with over 1 billion users each, right? We went into things like mobile OS, email, video, photos, and so on. I think the majority of the stuff we do is actually centered around data. So data is one of the cornerstones, one of the strategic pillars of our strategy. And we keep going after new needs and trying to solve new challenging problems. So Google's mission is to organize the world's information and to make it universally accessible and useful. That's our mission statement since the beginning, which is still quite important today. And fundamentally, what we do with Google Cloud is bringing all of that, bringing Google to you as a developer, as a customer, as a partner. So we bring the infrastructure, all the engineering, all the know-how that we've built over the past years to you as a business, as a developer. So many of the things that we do were actually created in-house in order to serve our own needs. But we are now making those services available to you as well in a very simple way. We'll be talking about cloud today. This is the cloud track. So fundamentally, and this is a very, very simple definition, cloud is all about getting things done using someone else's computers or infrastructure, right? Ideally, you wouldn't need to worry about maintaining servers, provisioning hardware, handling security and networking. All of that should be abstracted from you. So at least that's how we see cloud. That's the potential that we see in Google Cloud. So tasks like provisioning hardware, security patching, scaling infrastructure up and down, managing clusters. Of course, that is available, and we'll talk about some of those services. But particularly for you as a developer, I guess all you want to care about is solving your problems, right? Developing your applications or analyzing your data. And we are really focused on making that experience really simple. Now, Google Cloud Platform actually launched its first product back in 2008, and that was App Engine, a platform as a service solution for app development, which we still provide in our platform. But back in 2012, for example, our platform was really, really simple with a handful of services. The reality today is a lot different. And again, as a customer engineer, my job is to help our partners and customers picking the right building blocks in order to build solutions to address their needs. You can follow this link. This is actually really cool. It's a really short forward definition of every single service on Google Cloud. Now, this is how we structure our approach, right? We have infrastructure as a service at the bottom, as you can see. So you can obviously run your virtual machines. You can set up your networks. You can build your firewall rules and so on. But we tend to focus on the middle part, right? Smart Analytics as a service. And today we'll be looking at BigQuery, one of our most popular services, which allows you to analyze large volumes of data by using simple SQL queries. We then have data management. So we have a broad range of databases, managed services for you to store your data. And then we have the application platform as a service. And we'll talk about some of these services as well. Basically, the platform that allows you to build your applications in a very simple way. And then at the top, we see Google Workspace, which is the rebranding of G Suite. So think about Gmail, Google Calendar, Google Drive for your business, for work. So that's our solution, our SaaS offering as well, all part of the stack. So that's my quick overview of Google Cloud Platform. We'll now start looking into some of those services. Obviously, we couldn't cover them all today in such a short session. So we'll focus on how to access, how to run compute, store data, and we'll also take a look at some of the machine learning solutions that we have in the portfolio. And then I'll wrap up by providing some resources that you can use in order to continue learning and to start using Google Cloud Platform. So first of all, accessing GCP, console.cloud.google.com. That's how you access the console, as we will see in a couple of seconds. We have different ways for you to interact with Google Cloud Platform. Probably the simplest and the first you will use is the Cloud Console, our graphical user interface. But we also provide a command line interface. So using the gcloud command, you can do everything that you can do on the UI using commands. And then we also have APIs and libraries in several different languages that you can use to build your code and to build your applications and to interact with Google Cloud Platform as well. So let's have a quick look at the console. This is the graphical user interface. I can see an overview of my sandbox environment. On the left-hand side, I have a bunch of products and services ranging from compute to storage to databases, networking, and so on. And I really like this tool. It's the Cloud Shell, which is basically a kind of an ephemeral virtual machine preloaded with gcloud and many other libraries and packages that you can use in order to interact with Google Cloud as well. So we will have a look at that later on today. And then I mentioned the APIs, right? Everything that I'm talking about is exposed as an API. So if I look at the Compute Engine API, which is our infrastructure as a service offering, I can go through the documentation or download the libraries that I need in order to start exploring or interacting with the service as well. Okay, so again, graphical user interface, command line, and APIs that you can use. Now, let's start looking at the first category of services, which is the compute. Or in other words, where should I run my stuff, right? There are many different offerings and options, and it really depends on your needs, on your skills, on the way how your team is structured. So if we start from the bottom, we have Compute Engine, which is our infrastructure as a service where you can run your virtual machines. So if you have an existing system with specific operating system needs, for example, and then moving up the stack, we have Cloud Run and Kubernetes Engine. Kubernetes Engine is our managed Kubernetes offering. You can launch a Kubernetes cluster in a couple of clicks, and you can run your containers on Google Cloud. So it's really meant for containerized applications. But again, if you don't want to be managing Kubernetes clusters, you can move one step further and go into Cloud Run. We will see in a second, but Cloud Run is really great for running your Docker containers without having to worry about the infrastructure that is handling those containers. And then moving up the stack again, we have App Engine and Cloud Functions, right? In this case, you really just need to worry about writing your code, right? With App Engine, you write your code in your preferred language, for example, and you simply enter the command gcloud app deploy, and we will take care of packaging your application, compiling the code, and storing and serving that application, and scaling, securing, and so on. And then we also have Firebase. You'll hear about Firebase throughout the day for sure. which is really meant for web and mobile backends, again, hosted on Google Cloud. So I would say, if you can, try to move up the stack, but you should really move up and down according to your needs, or maybe combine different solutions or different services as well. So out of those compute services, I've picked Cloud Run, which was the latest one we launched. It's really serverless. Again, you don't need to manage any Kubernetes cluster, and it brings you agility for containerized applications, right? So why do people use containers? It really is a different way of managing applications, right? It's packaged in a lightweight format. It's portable. You can run your containers anywhere you want. And it maps really well to microservice architectures, right? You can have your microservices running as pods or containers, and then architect your application in that way. So with Cloud Run, the input is the container image, listening on a port for HTTP. And Cloud Run will forward the requests to those containers, to those pods, and manage the auto-scaling of the infrastructure that can go from 0 to thousands of instances, serving really large volumes of or really high load for your application. So again, you write your code, you package it or build the image, the container image, and then just deploy it on Cloud Run, right? So it's great for stateful applications, for HTTP workloads, for bursty applications, because it can scale up and down as needed. And it really supports multiple different runtimes, languages, and dependencies. One cool thing about container or Cloud Run is that you can deploy your container either on GCP, or actually you can deploy Cloud Run on an existing Kubernetes engine cluster, right? So if you need to run it in a specific region or even outside Google Cloud Platform, and you have a cluster where you can deploy, you can do Cloud Run as well. So let me show you a quick demo. This is actually one of the quick starts for Cloud Run. So in this demo, I will use, so let me switch to Cloud Run here. I will use the Cloud Shell that I mentioned earlier. I'll move into my folder. This is a very simple hello world. I'm going to show you the application in Python. In this case, I'm just importing Flask and routing my requests to the hello world function. As you can see, it will basically display hello world. I have my Docker file. In this case, I'm installing Flask, which is the framework I'm using, ng Unicorn, which is the web server. And then I simply need to run two commands, right? The first part of the command is how to build the container, right? It basically takes the Docker file and the Python code and builds the container using Cloud Build, and stores that container in GCR, Google Container Registry. And then on the second part, I'm simply deploying that same container, specifying where the image is available, picking the region where I want to run it, and then in this case, I'm allowing non-authenticated requests. And that's it, right? In a couple of, in a few seconds. So right now it's packaging the container. It will then upload into cloud storage or compute container registry. And then in a few seconds, I will have a URL that I can access, that I can use in order to access the application. We will come back here in a second. I can obviously monitor. Actually, I have previously deployed, I was just testing Hello World, this application. So I had previously deployed it. You can monitor, you can see different revisions, you can see logs. you can see a bunch of information about your running application. As you can see, my container is now running. This is the URL, and I can access my Hello World application again by issuing a couple of commands. All right, so that's Cloud Run, really simple. I was using the CLI and doing it step by step, but obviously you can build a development pipeline to automate the whole process, right? We have Cloud Code, which is a really cool extension for an IDE, such as Visual Studio or IntelliJ. It really helps integrating your IDE with Google Cloud Platform. Cloud Build, which we just saw, to build the package. In this case, we didn't use Artifact Registry. We actually used the container registry. And then you run your application by picking the right compute environment. And you also get the operational part of it. So you can monitor, you can handle logging. This is just one example using GCP native tools, but obviously you can pick, if you have another CI/CD pipeline or any other open source tool, you could build your own pipeline according to your needs. Then the other question is, where do I store my stuff, right? Again, many different options, ranging from an in-memory data store, which is basically memory store, a managed Redis and Memcache. We then have relational and NoSQL databases. We have an object storage, persistent disk, which is block storage, and file store, which is a file storage. Again, you'll need to pick the right tool according to the type of data that you want to store. I wanted to show you BigQuery, which is an analytical tool, which is it's actually our data warehouse. BigQuery allows you to store and analyze really large volumes of data in a very simple manner by simply issuing or writing your SQL queries. We'll take care of managing the duplication of the data, the high availability, encrypting the data, and so on. And BigQuery really is a great example of what we mean by serverless, right? As you will see in a second, I'll show you a quick demo. In BigQuery, I simply load the data that I want to analyze, and then I issue my queries in Cloud SQL, in SQL. And when I issue the query, BigQuery will allocate the optimal number of resources, or slots, as we call them, in order to run your query as quickly as possible, right? So you simply load your data either in batch or in streaming mode, and you write your SQL or even use an API or a CLI or your favorite client library in order to run your queries. So let me show that in a couple of minutes. So we don't need the Cloud Shell anymore. I have a data set here, which is basically provides, I'll take the 1 billion entry data set. This is a schema of my table with year, month, number of views per Wikimedia project or entry. This data set has about 84 gigabytes in size, and this is the format of that table, or a preview of that table, actually. So I had previously saved a sample query. In this case, this query is basically calculating the top languages in this Wikipedia benchmark data set. As you can see, I can actually, let me change the settings. I want to make sure that I'm not caching any results. Let me run the query again. In this case, I'm querying a 84 gigabyte table. And as you will see, I'll get the results in a few seconds, right? this could work for much larger data sets in a very similar way, right? And that's it. These are my results. Again, this is just a graphical user interface. You can interact with BigQuery in different ways. So again, I didn't need to worry about storage, about cluster sizes. Everything is managed transparently for you. And then last but not least, we have the machine learning stuff, right? So Google has been using AI and machine learning for several years now in many of the products that we provide. We have actually even developed our own TensorFlow processing units, which are really specialized hardware chipsets for running TensorFlow models and serving those models. TensorFlow, as you'll hear throughout the day, was developed at Google. It's now probably one of the most popular machine learning frameworks. And then we take that compute capacity, we take TensorFlow, this open source framework, or any other machine learning framework, and we provide a bunch of services, right? On the right-hand side, you can see pre-packaged AI solutions that any developer can use. And I'll show you some examples. If you're a data scientist and you actually want to build your advanced machine learning models and you have to address a very specific use case, you can do so using our AI platform. And then in the middle, we've developed something that we call AutoML, which kind of bridges the gap between the two worlds, between a prepackaged AI solution and a custom machine learning model. So how does AutoML work? So AutoML allows you to, it's machine learning creating machine learning. So as a developer, as a user, you simply load your data sets. We will train the model, deploy the model, and serve the model for you. Okay, so you don't need to write any code. You simply provide the data sets, and you will get a machine learning model that is very specific to your data set, to your use case, to your needs. Okay, so we have APIs and AutoML in several different areas. Sites, for example, with Cloud Vision that allows you to tag, to scan, and analyze images. We have something similar for video. We have language with translation, natural language, conversation with Dialogflow, which is a really cool and advanced framework for building chatbots. You can transcribe speech to text, text to speech. And then we also have AutoML tables. As the name implies, it's used for structured data. And I will show you an example in just a second. AutoML basically allows you to build state-of-the-art models with a couple of clicks. Again, you load the data, you specify the features and what you want to predict, and we will train and serve the model for you. So let me show you that really quickly. I have tables right here. Okay. So basically, I loaded a data set for banking, which provides information about the users or the clients of a bank, with columns such as age, duration, the education, and I want to predict whether a client is likely to make a deposit. So that's my target column in this case. I had previously loaded the model, and I had previously trained the model as well. Sorry, loaded the data set and trained the model. As you can see here, I've got a bunch of metrics regarding accuracy and many other parameters. And then I can test and use my model right away, again, using AutoML tables. So if I were to do an online prediction, and by specifying the parameters of a specific client, I could just predict it right away, or do it in batch mode and load it into a table, for example. And then finally, I would like to share some additional resources just as a way to wrap up. So first of all, you can use Quick Labs on google.quicklabs.com, which is our lab environment. We have a huge catalog of labs with step-by-step guides that also provide a sandbox environment for you to use GCP. We then have a lot of on-demand learning available on Coursera. Again, from the basics to really advanced machine learning stuff, for example. If you want to get certified, if you want to prove that you are proficient with Google Cloud, we have several certifications like you can achieve. And then we also run many cloud study jams. So if you go to events with google.com/cloud study jam, you can find out if we're running any study jams in your country or globally. That's a great way to get started as well. We have credits and grants for education, if that's something that interests you. We have a startup program that will provide support for you as a startup and even credits to use GCP. And fundamentally, if you just want to get started, you can go into cloud.google.com/free, and we will provide $300 worth of free credits, as well as a free tier for over 20 different products that you can use as well. And that's all. I'm really on top of it's the end of the session. I wanted to thank you for connecting and for following the session. If you need any help, please contact any of us. You can find me on LinkedIn. And thanks again, and enjoy the rest of the day.
Thanks very much, Tiago.
Thanks, Tiago. That was great.
Yeah, that was quite, yeah. Okay, yep, that's great. Yeah, I can personally recommend.
I've lost your audio, Goran.
Oh, am I back now?
I can hear you, Goran.
Yeah, I can hear.
Oh, yeah, that's great. Yeah, yeah, I can personally recommend the free tier on the Google Cloud Platform. With that one, can actually bring you quite far with that one, and also Quick Labs with a little to no cost. So yeah, thanks very much for joining with us today, Tiago. And I hope to catch up with you at some other event that we'll be hosting in the future.
Thank you. Thank you, Goran. Thanks, team.
Thanks, Tiago.
Thanks, Tiago. Bye.
Bye. All right. So we are almost at the time for our next speaker. That will be Tim. He's already on the screen with me. Hey, Tim. How are you?
Hey, I'm good. Thanks. How are you?
Yeah, I'm very well, actually. So you will be talking today about the Google Kubernetes engine.
That's right. Yes.
Yep.
I'll jump straight into it. Shall I?
Yeah. Oh, yeah. If you're ready, easier for me. Go for it.
Okay. Thanks, Goran. So, hi everyone. If you weren't here at the beginning of the track, my name's Tim Berry. I am the Cloud Track lead for today. I'm an organizer with GDG Bristol. And in my day job, I'm a training architect at A Cloud Guru, where I teach all about GCP, including courses on Kubernetes, serverless, and big data. So my talk today is called Who's Afraid of the Big Bad Container Orchestration System? I like titles that just roll off the tongue like that. And this is going to be like an introduction to Kubernetes talk, but really aimed at people who may have been put off by what they've heard about Kubernetes in the sysadmin subreddit. So you may have heard things like this. Kubernetes is too hard. Kubernetes is too complex. But I'm here to tell you it's actually as hard and complex as it should be, and that's fine. But before I start giving you the pitch, I want to talk about what problem it is that we're trying to solve. I believe that, we shouldn't use any technology or product just because it's cool or just because it appears in a bunch of job ads. It should really be a solution to a problem. So Obviously, the thing we're talking about here is containers. And strictly speaking, containers are not a problem on their own. In fact, they're a solution in themselves, making the problem of packaging and deploying applications a lot easier and more efficient than with VM-based configuration management or other methods, in my humble opinion. But once you've got your app wrapped up in a container, running it in production can sometimes be tricky. So you have to think about, how are you going to deploy it and where are you going to deploy it? Two of the most important principles you have to think about for any production deployment are scalability and reliability. And with a single container on its own, it can't scale. And if it crashes, then it's not very reliable either. So Google have been using containers since before it was cool. And so they've had to tackle these problems at the sort of scale that only Google normally need to worry about. So they created this massive internal container orchestration system called Borg. And they've used it to deploy up to around 4 billion containers a week. And out of Borg, and adopting many of its principles, came the open source Kubernetes in 2014. So Kubernetes automates the deployment, scaling, and management of containers. And it does this by abstracting everything you need to create a scalable and reliable environment into various objects that represent your application, its storage, networking, and so on. So let's talk a little bit about what Kubernetes is made of. Kubernetes clusters start with a control plane, which runs things like a scheduler, the component that decides where to run your workloads, and also runs various controllers, which make other decisions, and it runs an API server, which is how it talks to its worker nodes. So you then have a number of these worker nodes, which are where your containers and other resources actually run. And finally, you have the actual resources that you define that you want to run on your cluster, your applications and storage and so forth. So to learn to run Kubernetes, you have to learn how to build and configure all of these things in the first two rows. And then you have to learn how to actually define the resources you want to run on those things. So it can be a steep learning curve, but there is an easier way to get into using Kubernetes, which is just to let Google do a lot of the hard work for us with Google Kubernetes Engine, or GKE. GKE completely abstracts away the control plane. We can't even see it. And it manages worker nodes in Compute Engine. So let's see how easy it is to get up and running with GKE in a demo. So here in the Google Cloud Console, I'm in the Kubernetes Engine section, and I'm going to click Create Cluster. So here I can choose from zonal or regional clusters. Regional clusters have their control plane distributed across multiple zones for extra resilience. Nodes in a Kubernetes cluster are grouped into pools, as we can see here, and pools contain nodes that are all of the same type, so they can be used for specific workload profiles. Here's our default node pool, and you can see we've got 3 nodes, but with the tick of a box, I could enable auto-scaling. So that means that extra nodes could be added on demand if I need the extra capacity, and then taken away again if I no longer need them. This is basically just magic that GKE does for you. I'm going to untick that for now. You can also see that GKE gives us auto upgrading and auto repair. It's basically managing our nodes completely for us, it's just a huge saving in terms of administrative burden. Now, there are all sorts of other bells and whistles here, but I want to start out slow and not overcomplicate things. So if I go back to the cluster basics page, and I'm going to select this option over here, My First Cluster. This sets up a development cluster for me with smaller worker nodes. So I'll just click Create Now. So now GKE is going to provision the control plane behind the scenes, which normally only takes a few minutes, but this is a pre-recorded demo. so I'm going to speed it up. But like I said before, the control plane handles things like schedulers and controllers, but they're completely managed for you by lovely Google SREs. So now my cluster is up and running, and I can deploy an application with just a few clicks. So I'm going to start by clicking deploy. And it's going to prompt me to enter the details of a container that I want to run. This could be any container I've created, something I've uploaded to container registry maybe, or a public image from Docker Hub. For now, I'll just leave it at the default, which is the latest image for the Nginx web server. I can optionally add environment variables here, but for now, I'll just click continue. And here I can give my deployment a name and some key value metadata if I want to. Before I actually create this deployment, I'm just going to scroll down and look at this configuration YAML section. Now, like I said before, with Kubernetes, you declare everything you want to run as an object, usually written in this YAML markup. So it's Kubernetes' job to make sure that the state defined in these objects remains true. So here I can see that GKE wants to create two objects for me. The first is a deployment. This is a configuration object that lets us manage revisions of deployed applications. It defines a template for the containers, including the container image and version, and states that we'd like 3 copies of this container, or 3 replicas. The other object is a horizontal pod autoscaler. It's a bit of a mouthful, but it's a clever little object that scales the number of replicas running based on demand. So it will run with a minimum of 1 replica and a maximum of 5. So I'll click deploy, and I'll wait a few moments for GKE to do its work. And now I can see the details of my Nginx deployment. So if I scroll down, I can see that I've got 3 replicas running as defined in the deployment. Each replica is a pod, which is the smallest deployable unit in Kubernetes. So a pod can contain a single container or multiple containers if we want to do clever things like share IP addresses or other resources. And I'll talk more about pods in a moment. But right now, these Nginx pods are running, but we can't access them. But thankfully, GK is prompting us to create a new object, a service, by clicking expose at the top of this page. Service objects route traffic into the cluster to groups of pods. It's basically built-in traffic direction and load balancing. So now I'll just click expose again and let GK work its magic. And now the service is exposed. And I can click on this external endpoints link and follow the redirect. And here we go. This is a production-ready, auto-scaling Nginx web server in Kubernetes exposed to the internet with a global load balancer. And all in all, that only took about 8 or 9 clicks, which is pretty neat. So let's talk a little bit more about some of the objects we just saw GKE create. I'm going to get the laser pointer up here. So as I mentioned, the smallest deployable object in Kubernetes is a pod. You can think of a pod as a container for containers. Pods can contain multiple containers, but often, like in our demo, they just have one. So why wouldn't you just deploy a container on its own? Well, pods are useful because they let you couple services that need to share things like maybe a network address or a storage volume. A common pattern is to sidecar a utility container inside a pod, sometimes to proxy connections to the main container or perform some other utility service. So in our demo, our pods were created inside a deployment. Remember, we asked for 3 copies or replicas, all with the same templated pod. This set of replicas is called a replica set. This may seem like added complexity, but really it's just a logical abstraction of what it is that we want to run in production, defined using these handy objects with neat little icons. So why do we need a replica set? Well, think about how tricky it can be to update apps in production. Deployments and replica sets make this really easy in Kubernetes. So when we want to make a change, we update our deployment and change the template for our pods. Kubernetes will then create a brand new replica set to reflect our changes. It will then start spinning up new pods, the new replicas in the new replica set. And as each new pod comes up successfully, pods in the old replica set will be terminated. And there are built-in fail-safes. If new pods don't come up successfully, the old ones will be left in place. And you can tune this feature to maintain minimum availability. It's traditionally quite difficult to perform rolling updates to applications like this, but Kubernetes makes it really easy. And the deployment object also enables some other great patterns, like blue-green. So here we can maintain two separate versions of our deployed app, but use a service object to point traffic to only one version at a time. So for example, here we're pointing all live traffic to the blue deployment, leaving us free to work on the green deployment in isolation. When we've got the new version updated in the green environment, we switch the traffic to point there. Then we can work on our next update in the blue version, and again switch the traffic over whenever we want to. And if there's a problem with one of our new updates, we simply switch the traffic back to our last known good version. Now, of course, all of these deployment patterns are expecting your pods and containers to be stateless. This is also how you achieve horizontal scaling. Your pods should be able to come and go, get spun up and terminated at will, while your application state is stored elsewhere, such as a managed database. Now, in most cases, this shouldn't be too hard, because if you're using containers, you'll know that storing state inside a container is an anti-pattern. So as you can see, Kubernetes and GKE in particular are totally awesome, and we should absolutely use them for everything, right? Well, no, that's just simply not true of any technology. None of these things are the Holy Grail. You need to do what's right for you and your team. Now, in my opinion, I think Kubernetes is the best choice if you have to orchestrate containers in production, especially in complex deployments. But there are other options. If you simply want to press a button and go, but still have scaling and resilience, check out Cloud Run, which this is a fully managed hosting option for containers that's completely serverless. If that sounds like your thing, stay tuned for the Cloud Run talk coming up later. And that is my brief talk. And I hope that if you had any fear of Kubernetes at the start, I've managed to dispel that for you. So thanks for watching. So Goran, have I convinced you to use Kubernetes?
You did at the beginning, but then at the end, not that much, to be honest.
Really?
Yeah.
You're going to use Cloud Run instead?
Yes, I think so. I will use Cloud Run instead. Well, I will wait first to watch the talk later by Matt for Cloud Run, and then I will decide at the end. Probably I'll let you know at the DevFest, if the DevFest after party, that's okay with you?
Yeah, that sounds good. Yeah.
Yeah, that sounds good. So just a couple, because we have a little time for a little chat, if that's okay, yeah?
Yeah, absolutely.
Yeah, sounds good. So which one is your preferred way of deploying Kubernetes? Is it the console or using Cloud Shell?
Well, I'm a big fan of infrastructure as code. So I think, using the console, the Google Cloud Console is a great user interface. If you compare it to other clouds, it's one of the best. And that's great for prototyping and sort of rapid development. I think once you get to the point where you want to start doing stuff in production, or even in multiple environments where you want some sort of parity between those environments as you promote things up to production, you really need to think about infrastructure as code. So things like Terraform or even Deployment Manager, you want to be basically declaring what you want your infrastructure to look like, how you want your clusters and your nodes configured in code, and then deploy it through a build pipeline.
All right. Yeah, that sounds good. I was thinking about, because you have mentioned when deploying that you can decide for auto scaling, right? So it decides, actually it auto scales based on performance needed, so-called?
Yeah. Yeah, so there's a couple of built-in metrics you can use for performance auto-scaling, and there's more than one thing you can scale. Now, in the demo, obviously, we saw that a basic deployment in GKE will add a horizontal pod autoscaler. So that's going to scale up the number of replicas in your deployment based on the demand for those pods. And it uses the built-in metrics server to basically tell, well, how much demand are these pods under, what's their current load, what's their current CPU load, that sort of thing. It determines then when it needs to scale up and add new pods. You can also use custom metrics. You can use metrics that you've defined in Operations Suite, for example, formerly Stackdriver, as you know. And then in addition to that, you'll get to the point where if your app is really popular and has lots of high demand and needs to scale up and run lots and lots of pods, obviously at some point you're going to consume all of the available compute in your nodes. And this is where node pools come in really handy, because you can configure auto scaling on node pools so that GKE can automatically add extra nodes to that node pool. And then when the demand has gone down again, it can remove those nodes again. So you're not paying for just having redundant nodes sat there not actually serving anything. The other really nice feature with node pools is that you can have different types of node pools. So say you're running different workloads, and maybe one workload is a very CPU intensive application and another workload is a very memory intensive application. So you can configure node pools using different machine types because they all just run in, these nodes are just running in Compute Engine. So you can have your high CPU node pool and your high memory node pool, and you can configure when you run your deployment which node pool you want that to run on. And then you can set different auto scaling rules for different node pools. And maybe you've got, in most clusters, you'll have some utility deployments like a build pipeline or a logging system or something like that. You could put those on a utility node pool that doesn't auto scale. So it gives you all these different options for flexibility, but remaining scalable.
Yeah, that's actually sounds good. So if you deploy it, let's say when you're deploying a Kubernetes engine, and for a node pool, you decide to have scaling up to a maximum of 5 nodes.
Yeah.
So this comes handy where if it picks up a lot of traffic, that can go even further, or is it 5 as a limit? In this case,
you define the limit when you configure that auto scaling. You define the limit basically.
Yeah.
So
Sorry, go ahead. Yep. So
you go.
Okay. So when you decide the limit, would that mean that if it has a performance issue, if your let's say your traffic has a lot of popularity on the app, will you need to go in and do that change manually to increase?
Yeah, so this is where, as with any production environment, things like observability are really important. What would happen if you consumed all of the available compute power or memory in your node pools, and say you have a horizontal pod autoscaler that's trying to scale up to more replicas, that they will basically fail to schedule, and you'll start seeing errors in the scheduler, which you should be able to observe using your monitoring tools, whatever you're using. At that point, you'll need to manually change the auto scaling limits on that node pool. Now, I can't remember off the top of my head if you can dynamically change that in a node pool or if a node pool needs to be recreated. But one of the other nice things about Kubernetes or GKE, but Kubernetes in general, is as long as your stuff is stateless, and stateful apps are a whole other discussion, which we can get into in the next 7 minutes if you want. But as long as your stuff is stateless, you can basically, if you look at your node pool and say, okay, this is running out of capacity, or maybe I've not configured this properly, you can spin up a brand new node pool with different parameters, and you can drain the nodes that are currently hosting your pods. The Kubernetes scheduler will basically start moving those workloads onto the new node pool. And again, because these things are stateless, they're just a bunch of ephemeral pods, you can do that pretty seamlessly. The traffic will only come in and hit an available pod in a pool of available pods. So you can spin up pods on your new node pool while you're draining your old node pool that you're going to retire. So that's a way that you can basically migrate your workload to a differently configured node pool, perhaps with higher levels of auto scaling or a different machine type. And this feature is actually really useful as well for upgrades. You know, if you wanted to upgrade the version of Kubernetes you're running on your nodes, you can quite easily drain nodes and just automatically migrate workloads to other nodes to do this.
Okay, yeah, that sounds good. So you have also mentioned that Kubernetes uses a compute engine in the back. So this would mean that, for example, if you have 3 nodes, one master, so there will be 4 VMs running.
So the master node, that's basically your control plane. So you don't see that. You don't see that compute engine instance.
Yeah.
If it even is what you would call a typical compute engine instance, but you don't see that. You only see the nodes in your cluster in your compute engine section in your console.
Yeah. So those let's say you have 5 nodes or 3 nodes. Let's start with 3 nodes. So we have 3 nodes into your cluster. So there will be 3 separate VMs created in compute engine. Yeah. So when you need only one, would that mean that the other 2 are powered off or shut down?
If you configure the auto scaling in the node pool, and it can scale them down, if it doesn't need that extra power, then it should, in theory, scale that down to 1 node.
Yeah. So okay. So that will be only 1 VM that's going to be on, and the other 2 will be off, or they will be just not there at all.
They won't be there with the autoscaler. It will delete the instances. It won't just switch them off. It will delete them because obviously it'll free up that boot disk. You know that it's provisioned as well. Then
yeah.
And generally you probably wouldn't want to autoscale down to 1 node. You know, if you're using a node autoscaler, it's probably going to be in a production environment. You're taking a risk coming down to 1 node. You want to have some breathing room there, basically.
Yeah. That sounds good.
But you can run a development cluster with a single node.
Yeah, with a single node, that's fine. And will you? Are you able to go into, for example, to SSH into those nodes on the compute agent side and maybe do anything custom there?
You can do. It's probably not recommended.
That's
most of the configuration that you need to do, you can do through the Kubernetes API. And obviously you've got full access to the API server and the kubelet running on every node. Because they're managed nodes, you know, they've got things built into them like auto upgrade and auto repair. You probably shouldn't SSH in and start tinkering with them. GKE might think that something's wrong, and the auto repair might kick in, and it will just delete that instance and create a new one.
Oh yeah. So GK will think that someone is tampering or anything. So yeah, I should have rephrased my question. It was actually wanted to ask, but you already answered it. If it's advisable, so definitely not recommended to do that. I think I have no more questions or anything with that. Thanks for the little chat between the talks. We are slowly approaching to the time for our 3rd talk before our coffee break. So we have already the speaker in the background. There will be Sourabh, who is a G Suite, or I would say, shall I say now, Google Workspace GDE now. Let's bring Sourabh and have a little chat in the. Hey, Sourabh.
Hey, all right. Thanks for having me. Hey, Goran.
Hey, thanks for joining us. Did I introduce that well? Is it now Google Workspace GDE, or?
It is. We are going through the transition right now. I believe it'll soon be Google Workspace GDE, but I think for now, I think even G Suite GDE should do. No problem.
Yeah, I think everyone's familiar with that. That's completely fine. So Sourabh will lead us to rapid prototyping. So he's he's joining us all over from India. Is that correct?
Yeah. Yes, that's correct. I'm from Bangalore. I'm currently joining in from Bangalore, India at the moment.
Yeah, all right. That sounds good. So without further ado, would you like to start sharing your screen and maybe start with the talk?
Sure, absolutely. I think that sounds like a plan. I have just started sharing my screen. Let me know once it's up. All right. Looks like
that's all right.
All right. Cool. Let me just dive in then. Well, I think thanks for the introduction, Goran. Well, by the way, and I think from the looks of it, I would be quickly taking us through, a little something that I put up, which is to, being able to fail fast while building a business first, zero cost solutions with AppScript. The reason why it's titled that way, I think you would get to know in a minute. But even before we could, jump in directly to the topic, you might be wondering as to who am I? So this is the first time I am talking at a DevFest, thanks to GDG London and UKI, basically. So for the opportunity. So a little about me. I am not actually a developer, so I dabble a little bit in code. I typically try and work on automation problems. I also try and see wherever problems arise, if we are able to solve it using, of course, some of the tools that are available. Definitely a spreadsheet nerd. I come from more of an operations background, which is to say we use a lot of spreadsheets, which is why I sort of dabble a lot when it comes to spreadsheets there. I, of course, love automation, or you can even assume me to be a little lazy. So if there are more copy-paste activities, I would try and figure out a way to automate it. And of course, if anybody needs any assistance in the community with regards to whatever I can offer, either in app scripts or spreadsheets or any other matter as a course, I typically jump in and see whatever I can. So that's a little about me. And in terms of today's agenda, right? So things that we'll try and cover is, of course, what are the challenges that I think that actually occur in a business environment, and of course, some of the things that we can do using app scripts. If you don't already know it, of course, I cover a little bit of it even in this talk as well, so you can know what app scripts does. We'll also see some of the use cases that we can do, and of course, thanks to Tim from previous conversation, even as he mentioned, no technology is perfect. So of course, what after app scripts, once you reach the limit, once the prototype is sort of successful, you might want to scale that up. You might want to sort of put it out there in a much bigger scale. So what after app scripts, right? So we can sort of explore those as well. And again, before we could jump all the way into the actual topic, also as to who this is for, right? So basically, anybody who wants to automate something, they just want to quickly get it done without having to, let's say, spin up a server, be able to sort of sign up for a new account or something like that. And anybody who's thinking about, enabling efficiency, which is mostly to say, the amount of work that actually needs to be done in order to get something, out of it. So if you think you are in that business, or if you think if that's something that falls in your domain, we can actually this talk might just help. And of course, there's something that doesn't get spoken the most about in the developer community is if you want to reach more users, right? Let's say you have an idea, you have a problem statement that you have solved, but now you need more users to sort of try, experiment, give you feedback, and sort of so on and so forth. How do you make that happen? Well, there's actually a very nice way to make that work as well. And of course, you have an idea or just a simple problem statement that you'd like to test out and see. What of course it doesn't matter is if you know how to code, because truly AppScript is one of those spaces where even if you don't really know how to code, if you don't know what JavaScript is, it's okay, because I think we will cover this in the talk that the application itself allows you to sort of build on top of your actions and then allow you to see as to what code it's actually being written, right? So you don't technically have to know how to code as well. You don't need to have a credit card to set up an account. Like most platforms, typically require you to have a credit card or a billing account. And of course, you don't have to be from the engineering department itself. You can be anybody, especially if you're a business user, perhaps just a developer advocate even who might not really be in the dev game as much. I think this might just help. So jumping in now to the core parts of the conversation, right? What are the challenges, for instance? Postman actually recently released, I think about less than 2 months ago, they actually released the 2020 State of the API report. One of the topmost things it says that, the difficulty or the challenge that most developers, most companies rather, face is the lack of time, right? Which is why, as per the talk, when it says that the first thing we have to have is rapid prototyping, right? That's one of the more bigger challenges. I think it holds true both in the developer zone as well as the business zone, right? Like in all scenarios, like, of course, lack of time is the topmost concerns. Then, of course, it's the money, right? Sastra, that's a very nice little, well, not a little, but a nice blog and a workspace, which actually talks about a lot in terms of what's happening in SaaS. And it says, roughly 5% or close to about 10% of the revenues are spent on cloud computing or cloud costs altogether, right? Which also now begs the question that how can we actually think of a way, if we have to experiment with something, if we have to build quick prototypes, what are the better, easier, maybe cost-efficient ways to make that happen? So time and cost, in a way, are some of the bigger challenges. And the idea that I want to share with you guys, and of course, most of you may already know this, is Google Apps Scripts, is the use of Google Apps Scripts, rather, right? And in case you don't already know this, you can just access it using script.new. Just go to your browser, just type in script.new, and a new app script window will editor will sort of open up if you have logged into Google account. Otherwise, it will prompt you to. Now, of course, like the big question is like, why would developers, especially, or rather even, people from the business side, would ever want to really jump into Google Apps Scripts? Like, what does it really help us with, right? Couple reasons which I think definitely make sense. Like, it is serverless and it's zero cost to set up. Basically, it doesn't ask you to like enter a credit card. It doesn't ask you to, let's say, pay for any kind of their usage. Let's say you're using compute power, you're using, let's say, the ability to send emails, etc. It doesn't ask you anything to pay up out there, and it's serverless, which is managed by Google, so that's good. It of course is in the JavaScript language, right? Like JavaScript-like. It has its own classes and libraries as well, but you can pretty much do everything that you do in JavaScript inside AppScript as well. So that's a benefit. The reason I've added low code and it's highlighted is because typically when you want to interact with, let's say, you're on Firebase or some other platform, if you want to interact with Google services, you need to configure the OAuth configurations. You need to be able to handle different scopes. You need to manage authentication. So all of that is something that goes in if in case you'd like to interact with, let's say, different APIs, right? Especially if it has to do with Google site services. Now, that is something that AppScripts totally handles it on its own. Basically, let's say if you want to access the spreadsheets, all you have to do is just type spreadsheet app and boom, you are good. The moment you execute the code, it automatically handles authentication, the scopes, and so on and so forth. So it's very much a low-code platform. It helps you allows you to sort of build prototypes in a lot faster way. And yeah, of course, the reason why, one of the other reasons why it's zero cost setup is all you need is a Gmail account and nothing more. Literally. So yeah, some of the examples, right? Let's say if you're thinking about being able to store data, if you're building a prototype, if you're building a simple web app, if you're building an add-on or something for internal team members and want to be able to store data and access data at any point in time, you have Google Sheets. So this is an example. For instance, you can see on the left side, let me see if I can get the pointer out. Yeah. So basically on the left side, you have data on a spreadsheet, and on the right side, the URL is of a web app that has been deployed using Google Apps Scripts. And if at all you just need data where the email is code at script.js, you can then display that data, which is stored inside a spreadsheet. So that's definitely possible, right? The other thing is, of course, let's say an email provider, right? If in case you want to be able to send emails using your application that you're building, you can just connect Gmail directly. So one of the amazing examples by another community member and a GDE is Martin Hoxkey. So he has put it up in the Google Workspace Developer Solutions Gallery repository. A very nice, very prominent examples to be able to use your mail merge services with Gmail, and if the data perhaps is in Google Sheets, right? Let's say if you want to deploy chatbots, like that's a little advanced, right? Not all or every business user thinks about chatbots directly, but if let's say you're in the developer ecosystem and you'd like to, or you have interest in being able to build chatbots, you can do that using Google Chat. There's again very nice documentation that's already available in the Google Chat API developer portal at this point in time that you can just quickly access, right? So all of this is possible, right? And some of the other things, let's say if you want to The massive user base, that's what I was hinting on earlier, right? Not everybody knows this, not everybody rather speaks of it as much, but let's say you have you work for a company that provides some SaaS solution, and you'd like, let's say, it to reach to a huge number of users. If there is a user base for it, you can actually build an add-on and then just put it out there in the G Suite marketplace. That is what it was known as previously, but as of now it's known as Google Workspace Marketplace. It's a little hard to go by, but you can actually put something out there and see how many users use it. A quick example is I actually published an add-on. I had no intent to monetize on it, but then when I published it, I mean, as of today, I did not envision it would have like thousands of users. Today it has like 15,000 users who have downloaded it in a period of, I think, about 8 months. Not to brag, but just to say, like, if in case you'd like to have more users, if there's a problem that many people actually experience, there is a place where you can actually check that out as well. The other thing is, of course, visualization, right? Like this is one of the more core or unique things to app scripts, because at this point in time, you don't have any other technologies that you can use to build either of these. Let's say an add-on, you have to use the app script ecosystem. Similar to that, even for Data Studio, right? If you have, again, a SaaS company that you work for, it has an API that gives you stats. One of the things you can do to make life easier for your business users is perhaps build a Data Studio community connector. Now, it sounds a little fancy, but all it does in a way is essentially using AppScript, it talks to your business API, gets the data and displays it in Data Studio. Basically, that's all it does. And in terms of community connector, you can choose to either open source that connector, or even perhaps sell it yourself if you want to monetize on top of it. Well, one of the core things, which is again very less spoken about, mostly in the dev ecosystem, of course, like the ability to build web apps is common. You can also create webhooks using app scripts. If in case you're wondering, like, how do you get data inside of the Google ecosystem, you can create webhooks using AppScript. Again, zero cost, totally serverless, and then you can make that happen. One of the cooler things that was recently developed, when I say recently, about I think less than 5 years ago, is the ability to develop locally using command line AppScript projects. So you can actually, let's say, you want to work on your terminal, you want to work on your VS Code. That's something which is possible with the AppScript ecosystem as well. Now, well, those were some of the reasons which I thought made sense as to why and what you can do using app scripts. Some of the cooler use cases, right, that I would love to discuss is, this was actually out of a hack, but I still think it sort of has some relevance in terms of being able to rapidly build a prototype. Of course, it is not scalable as much, but it was a good prototype that we built. But let's say, for instance, if you wanted the ability to talk to your data, right? So we built a conversational stats, and this is how the architecture essentially looked like. Like, of course, like if you're going to, like, say, talk. Oops. I guess my presentation just got bombed. Let me just reshare once again. Okay, I hope it's back up, right? Cool. So like I was saying, right, like in case if you want to be able to check this use case out, one of the core things is being able to use Dialogflow, right? With Dialogflow, let's say, you could just ask, or let's say Dialogflow saying, what were the number of calls that our team received yesterday, and then suddenly, with the help of some magic in the backend, it could just process the data, crunch it, and then basically be able to answer you in whichever platform you're asking this information in, right? So we use Dialogflow. That was connected or hooked up to Google App Scripts. App Scripts was talking to the data which was stored in Sheets. Then basically, with the help of App Scripts, Sheets was able to return the data to it. App Script was able to communicate that back to Dialogflow, and Dialogflow all the way through was able to then be able to answer it in the different platforms that it actually allows you to embed their entire chatbot in, right? So this was one of the cooler use cases because this was built again by somebody like me who is not a developer in the business zone. There was a business problem to be solved. solved, and we needed to quickly be able to sort of do something in a way where this was actually conceivable. Right? If people wanted to scale, they could use this baseline in a way to actually understand as to what was needed and what perhaps could be a way to make that happen and achieve it. Right? So this was one of the use cases. The other use case you could think about mostly in the business ecosystem is, let's say, your business users have bigger sets of data they need to crunch, analyze, or even update, right? Like it could be both ways, either read or even write. How can we, or let's say, how can developers especially enable those business users to make that happen? And one of the very cooler videos and one of my personal favorites, Tech and Eco, I know her by that name, Google, and this is somebody from the Google team who makes a lot of videos, writes a lot of blogs. So there's a very nice video that talks about how you can actually connect to BigQuery where the data is lying inside Google Sheets, and if you have to push that data into BigQuery or even perhaps even read from it, how you can make that happen using app scripts, right? And this is, again, in a lot of way a zero cost setup, because BigQuery gives you a free tier, a fairly big 10 GB storage, if at all it's a business data, something easily conceivable. It makes use of Google Sheets, again, a place where a lot of business users live, and the AppScript ecosystem altogether, right? So this was a very nice use case as well. Now, I think the other bigger questions, right? Like, okay, everything works. There is AppScript, it is cool. It allows you to go so far, but what after that, right? Because it's not perfect. No ecosystem is, right? One of the more frequent challenges I've seen happening is, let's say, of course, you don't have server access when it comes to AppScript, right? And one of the problems that I can actually share in terms of what happened in real life is I was wanting to access account activity API, which is basically a webhook from Twitter, and push my Twitter data inside a Google Sheet. But instead of polling the API, I wanted to be able to have Twitter ping me the data at any time whenever there was more activity, right? So basically, I wanted to have a webhook that was I wanted to have an AppScript project that was acting as a webhook where Twitter can send the data to that webhook, and that it could basically push that information inside spreadsheets. Turns out it wasn't possible, because one of the requirements that Twitter has, that the response that it needs to receive from the webhook is a 200 HTTP success. Unfortunately, AppScript doesn't give you that. It gives you a 302, among other things. So this wasn't directly possible. And this is just a challenge, right? Don't worry, there is a solution to it. I will share that in the way that we go about it. The other barriers to scale when it comes to AppScript is, of course, you can't build a Netflix or Spotify on top of it, right? It cannot go so far. You will sort of have issues with concurrent hits. You will have issues with scalability. Can you go 20 million requests, 50 million requests? You can't, right? With AppScripts. I think there are very few technologies that can, but that's also part of the AppScript challenges, right? One of the other challenges that comes up mostly in the business ecosystem is what if you have internalized data or internal data which is only accessible via a VPN, right? What happens? How can AppScript allow you to access that? So there is a JDBC connection that's available. I have personally never used it. So in terms of technology, I'm not so solid there, but I know that not all internal data can be accessible by JDBC connections, because not everybody feels that's secure enough. There are a whole bunch of other barriers. There's compliance-related constructs that come in, and AppScript cannot really help you there in those matters, right? But no problem. That's one of the reasons why what we should be doing is having a need-based evaluation, right? For prototyping, AppScript, I would say, is an amazing ecosystem. It's a good enough platform where most business users can build prototypes. Even developers, if at all you would not want to go through the hassle of, let's say, managing another instance or be able to spawn another Docker, for instance, right? If you'd not want to be able to manage all that, you can simply make use of AppScript to sort of run whatever it is that you'd like to sort of test and see if it works, right? The other, this is my opinion, in my experience, what I've seen happening is, and this is mostly from me, a whole bunch of other colleagues that I've seen in the community who have actually transitioned is once they're done, or rather met some of the restrictions of AppScript, then they look at Firebase, right? And let me just say, as much as Firebase says that it is just for, or rather mostly for, mobile development, I have found that it's not the case. You can actually build a whole bunch of, let's say, back-end related activities or server-side related actions you can do using Firebase, right? So the problem that I was pointing to earlier with Twitter account activity API, the way I handled it was, I first built a webhook using the cloud functions in Firebase, because then I could get access to the server responses and so on and so forth. And then I pushed that data again to my AppScript web app, which was then able to handle it from there on forward in its natural, normal flow, right? So that's actually a very, I would say, a decent example of what could be a need-based evaluation, right? And once you're done through Firebase, then of course, you can even explore the Google Cloud platform in its entirety. However, of course, in the interest of understanding this well, it is all in a way the same thing. Google Cloud is actually very much on the top, and then comes Firebase, and then perhaps a small part of that is AppScript, right? I think the most major differences that is being sort of marketed between Firebase and Google is that Firebase is mostly for front end or other web app kind of related activities, mobile development being one of the more core focuses, and Google Cloud is mostly for server-side development, where you need to be able to access more computing power and a whole bunch of other scenarios along those lines. But I would say that's how I think you can start building prototypes using app scripts, then move based on whatever you think is the need of the hour. Firebase, in my opinion, is a very good technology, and the platform easy to use as well. And after that, of course, go with the Google Cloud. But I think in a way, I hope this is sort of helped shed some light in terms of what app scripts can do. What are the other activities that business users like myself typically look for? What kind of challenges we end up trying to solve? But looks like I've come at the end of my talk on this small matter. Let's just wait for Goran to jump in. I hope I did not put him to sleep from my talk, but
so Goran's had to drop off. But yeah, that was a brilliant talk. Thank you very much for that.
Sure, thanks. I mean, if any of the community, or let's say you guys have more questions, I'd be happy to answer if it's to do with app scripts.
Yeah, I think I haven't seen any questions come in, but I mean, personally, I think it's just great when there are lots more serverless options. If you have an idea, you want to start developing something, you want to do this sort of rapid prototyping, the last thing you want to do is think, okay, now I need to build a server, because that's rubbish. No one likes doing that.
I hear you. I hear you, absolutely. No, so I think this is one of the core things I have seen, or rather I have been trying to sort of share with whomever I come across, that and surprisingly, not more of developers know that there's an AppScript ecosystem that can, to an extent, handle the complexities that require you to, let's say, be able to build something, right? And yeah, I mean, but of course, like I said, you can't build a Netflix or Spotify, so please don't use AppScript for that. But besides that, I think it's still a good enough platform to go after.
So AppScript is really just about extending what you can do with Google Workspace, isn't it? Formerly G Suite.
In fact, it still is. It's basically just that, being able to interact with your Google services. However, let's say, for instance, right, you wanted to be able to send an SMS using Twilio, just as an example, right? You can still do that, because ultimately you'd be making an API request, and that's something AppScript can actually do. So that's another conception that it is not just the Google ecosystem, but practically any other application that provides an API. Essentially, you can actually connect to those as well.
So you could almost sort of build a workflow of different API calls from within a Google Sheet.
Of course, and a lot of companies do that as well. So to speak, they, if at all not just directly inside, Google Sheet, we end up building add-ons that allow you a little more moderation as to how you can control what's happening inside your Google ecosystem, and based on that, of course, interact with third-party APIs as well. But sure, that's possible.
Does it support all of the products in Google Workspace, or just the sort of core document ones?
Almost all. I can't actually think of any that. So, for instance, you still don't have a Keep API. A lot of people I know have been asking if it would have been cool if you have a Google Keep API, for instance. But I would say all the major ones. Well, in terms of whenever there are challenges, for instance, recently there were amazing developments with the Classroom API. A whole bunch of users wanted to be able to do like a whole bunch of automations when it comes to Google Classrooms, and there are libraries, or rather there are advanced connectors inside app scripts that you can use to actually connect to Classroom without having to let's say host an API link and then manage the authentication, manage scopes. You wouldn't have to do that. You just say Classroom and basically you can access all of its resources.
Fantastic.
Yeah.
Cool. So any words of wisdom you want to leave us with before I let you go?
Sure. I mean, like I said, so one of the core things is I am not a real developer. Like I don't actually build tools using technologies as much. But the only advice is right. Like one of the things what developers can try and do is also interact a little more with perhaps the business teams that are available. I'm sure like already business teams come up with saying, okay, no, we need this, we need that, we need this person to be able to give us this information. I think if more developers sort of tried engaging those inquiries, even with minimal technology use, they can just quickly spin this up. Like I think a trained developer can just write a JavaScript code in under 30 minutes for, let's say, the basic of activities. A business user might just take like ages to be able to like make that happen either manually or, let's say, if they were trying to code it themselves, right? So that's actually what I would rather recommend. But in terms of technology, I think people are already savvy to know what to go and which platform to go with.
Fantastic. Well, that was excellent. Thank you very much for that.
Sure.
I'll let you jump off, and I'm just going to share some information about what's coming up next.
All right.
Thanks very much.
All right. Thank you. Bye.
Okay, so that wraps it up for the first slot of talks for this morning. We're going to take a short coffee break now. I definitely need some more coffee, and we're going to come back at 12:15. And this afternoon, we've got, carrying on before lunch, we've got 3 more talks. Security and serverless compute on Google Cloud, event-driven serverless architectures using Knative and Cloud Run. That's the talk that I alluded to earlier. Really excited to see that one. And also really excited to find out about Istio Service Mesh in Kubernetes. Then we'll have a lunch break, and we've got 6 more talks after that this afternoon. But for now, we'll take a break, and we'll be back at 12:15. Thanks very much. See you later, guys. Hello, everyone, and welcome back to our Cloud Track. We've got another 3 great talks lined up. And for this next section, I'm pleased to introduce our next hosts, Ashnita and Shadab. Hello.
Hello, guys. I hope you all had a nice coffee break. So Ashnita and I are the hosts for this slot before the lunch break. And my name is Shadab. I am from GDG Galway. I work with IBM as a software developer. And Ashnita, would you like to introduce yourself?
Hi, my name is Ashnita Bali, and I am a front-end web developer, and I work with Angular.
Thanks, Ashnita. So we have 3 exciting talks back to back, amazing speakers, I promise. So we can see the list of 3 talks, and I'll not take much of your time. Let's start with the first talk of this slot, and this talk is all about security. So security has always been a big challenge. With the emergence of cloud and serverless architecture, this challenge has grown bigger and bigger. So this talk is titled Security in Serverless Compute on Google Cloud, and this is given by Guillaume Blaquiere. Guillaume, please excuse me if not pronouncing your name right. You're French, Guillaume, right? So let me bring Guillaume to the stage.
Yeah. Guillaume, it's not very easy to say in English. I'm sorry.
Yeah, thanks, Guillaume. So he's a Scrum Master and lead developer at Veolia, and he's also a Google developer expert on cloud platform. And he has been a Java developer since the last 15 years. So he's a very experienced guy, I must say. So Guillaume, the stage is yours now.
Okay, thank you. Thank you very, very much. So today we'll talk about security, especially in serverless compute domain on Google Cloud. First, before going forward in these topics, I would like to focus on what's serverless and to be sure that everyone has the same definition of serverless. In fact, you can see the serverless in 2 different manners. You can have an operational model, and it's most important today for this talk, where you can say serverless is I don't care about what's the server that runs my application. I have no server to manage. I have no network to manage. I don't have to care about the patching of the server. I have to take care of the high availability, to the snapshots, the backups, and so on. All these parts are managed by the cloud provider. And ultimately, the best way to serverless is I pay when I use the service. For example, when you use Cloud Function, when your function run, you pay for this computing duration. And when the function doesn't work, when you have no traffic, you pay nothing. It's the ideal solution for serverless. Some products are not really serverless. We name this as managed services, like, for example, Cloud SQL, where you run a MySQL database in the cloud. Is not you pay when your server is up, when your database is up, and even if you don't have any requests on your database, you continue to pay it because you have a database instance up and running, ready to accept any request at any time. So, but at the end, with Cloud SQL, you don't have server to manage, you don't have upgrade to manage, patching to manage. All this stuff are managed by the cloud provider, and you only focus on what's matter, your code and your application. That was for the operational point of view. You also have another point of view, that is the developer point of view, slightly different. In fact, a developer is focused on developing a service, a microservice, because it's trendy today to develop a lot of microservices, and these services react to events. That can be cloud events or external events, like, for example, HTTP request. And the concern of the developer is to develop a service, a microservice, to bring value to the application, to the customer. And like this, by this way, in fact, the developer don't care where the service is running. Is running on premises, on GCP, on Azure. is not its concern. It wants something portable and to bring value to the customer, and the rest is not its concern. It's another way to see the serverless. But for this talk, the most important way today is the operational model. And we talk about security in serverless compute. So first, what's serverless compute on GCP? Serverless compute, it's a platform where you can bring your code and Google package and run your code for you. We have 3 services for this. You have Cloud Function. You package a simple function and you ship it in the cloud and Google run it for you. You have Cloud Run. It's not a function. It's a web server package in a container. And then you ship your container and Google run it for you. And App Engine is an hybrid solution between both. In fact, you have a web server, not packaged in a container. You have a web server with several endpoints, and you ship it to the cloud, and Google deploy it for you and configure what you need on this. So that is serverless compute. Now, when you deploy an application with this product, you can have some security manager, security team members that come to you and ask you some question about security in your application. And if you answer easily, because serverless is magic, you have nothing to manage on your side, you only ship your code and that's all. When you have a question like, how do you manage the patching? The patching, you can answer, it's not my concern, because the patching is managed by Google, and me, I only have to do my code. That's all. No server to patch. But what about the network and the static IPs when you perform an outgoing call to a platform, to external platform or API? Here again, the servers and the network is managed by Google. I don't care. It's not my concern to manage the network and the IPs. It's a Google concern, and I can't manage this. And how to ensure the high availability? This question is very easy, because when you deploy on serverless with Cloud Function, Cloud Run, or App Engine, you have a regional high availability. I mean, you have on a region on GCP, it's 3 zones. One zone, in fact, is a data center. And when you deploy, for example, in Belgium or in UK, you have 3 data centers. And if one data center is down, you have 2 other data centers that can serve your application. So you have high available at regional scale. And like, again, you have nothing to manage and to do for this. For the DDoS and for the access control, here again, the easiest answer is to say, my solution, my services are behind a layer, a Google managed layer named Google Frontend, and Google Frontend manage all the stuff for me, discard the DDoS attacks, control the access with OAuth token in the header of the request, and so on. I have nothing to do on my application. Serverless is magic. And in fact, not. In fact, not all these answers are wrong or not complete. And I would like to demonstrate to you that it's not true. You have stuff to do in security in serverless, even if serverless is magic. It's not because it's magic that you don't care and don't think about the security in this domain. So you can take over the control of the security and your infrastructure, because most of the time your security is linked to the infrastructure. First, the server patching management. Yes, of course, as described initially, I don't have servers to manage because it's serverless. Google manages the servers, I manage the code. But for Cloud Function and App Engine, you have to deploy your code, and the code rely on dependencies. And maybe you have issues in your code, of course, but also issues in dependencies. If you have all dependencies and deprecated dependencies, sometimes you have known issues on your dependencies, and you have to patch not the servers, but your code to be sure that your application continue to run safely on Google Cloud. And when you run on Cloud Run, you don't ship your code and dependencies, but also the containers. The container, in fact, it's a packaging where you can set in it the base image. The base image is, in fact, an operating system for the container. You can add on this base image some system dependencies and libraries that you can install with Linux command, for example. And on top of this, you add your code and your dependencies. And here again, you can have issues and security issues in your code and in your code dependencies, but also on the operating system and the libraries on the operating systems. So you have to build and rebuild regularly your code with the latest version of the base image and of the dependencies to be sure to package and repackage and redeploy your code regularly. I mean, every week, every month, your application to be sure to fix any issues that can be packaged in your application when you deploy it. So first, you have no server to patch, but you have your code and your dependencies to patch. The second topic is about the network. For example, you have application deployed on Cloud Function, App Engine, or Cloud Run, and you have also other parts of your system deployed on Compute Engine, Google Kubernetes Engine, or also you would like to use, for example, Cloud Memory Store, which is a Redis solution package and hosted on Google Cloud. Why? Because you have some legacy applications that you bring from your on-premise environment and you deploy them on Compute Engine or on Kubernetes, and you want to use this legacy application with your serverless app. And thus, you have to reach this application either in public IP, but it's not a good practice to have a public IP for your Compute Engine open on internet. But the best way is to use the private IPs. But how to do this? In a similar way, in fact, if you have an external platform, it could be your on-premise environments or AWS environment and so on. You would like to use a private IP to access to these environments securely through a VPN or an interconnect, partner interconnect or cloud interconnect. So here, you have to access to your private IP, to your VPC, to your virtual private cloud network to access to this kind of IPs. For solving this challenge here, because you have two worlds, your world with infrastructure managed with IPs and so on, and the serverless world where you manage nothing in the servers as a network, you have a connector. It's named Serverless VPC Connector. It's an entry point between the two worlds, the serverless world and the VPC world. It's a bridge between the two worlds, and you can access your VPC thanks to this connector. And because you enter in the VPC, all your features that you can apply on your VPC are enforced, like firewall rules or routing. You can route your request either to a compute instance deployed on your project or through a VPN to access to the external platform. And thanks to this connector, you can shift from I manage nothing from the network to I route all the traffic to the network and I manage the network and do what I want in my network. Similarly, in another use case, you can have your serverless world that's call an external services, an external platform that trust only non-IPs. Which use case in my previous company, in fact, we had a FTP servers with login and password and an IPs, and we have to trust the three information to allow users to interact with our FTP server. And with serverless, you don't manage the the network, and you can't know which IP will be used to interact with external APIs and services. And it can be a problem. Here again, the solution is to use the serverless VPC connector. You can route the traffic from your serverless world to the VPC. And when you are in the VPC, you can do what you want. And here you can use a router to route your traffic to Cloud NAT. Cloud NAT allow you to reserve one or several IPs to use these IPs and to go outside with one of these IPs, and then you can trust these IPs because you know which IPs you will use to go outside when you perform admin calls. This feature is available on Cloud Function and Cloud Run. On Cloud Run, it's very, very recent because it has been released Tuesdays this week. It's very recent, but on App Engine, for now, it's not possible to route all the traffic from App Engine to VPC connector. Only the private traffic is routed. You can route to serverless VPC connector only the private IPs range from App Engine to your VPC, but the public IP range is not routable to serverless VPC connector with App Engine. Now, we'll talk about high availability. Okay, you are regional high available because with serverless, you can deploy on a region and not in one data center, in one zone. But sometimes you have a global service and you need to be globally available. For this, you have a solution named Google Cloud Global HTTP Load Balancer. And this load balancer, you have only one, in fact. It has no three load balancer, but the same IP is dispatched on all endpoints, all point of presence of Google, and then the same IP can be reached on any zone in the world. You can deploy backends. Now you have serverless backends that can deploy behind a global HTTP load balancer. And for example, you can deploy the same Cloud Run service on each region if you want. You can also deploy only two functions in America, in Europe, and only App Engine in Asia, in Australia, if you want. But yeah, you can do this. Why HTTP load balancer is important and interesting? These two features for the high availability and for the latency. First of all, the HTTP global load balancer routes the traffic to the closest location. For example, if you are in the USA and you request your Cloud Run instance, the Cloud Run service deployed in the US will be reached by the global load balancer. But if you have a zonal, regional issue with the US, the global load balancer can route the traffic to the closest location. It could be in Europe or in Australia. I don't know what's the lowest latencies between both, but automatically, if you have an outage or a service unavailable, your traffic is routed to the closest and available location. Of course, if you have also on the US and you asked for App Engine, the only zone where App Engine is deployed is in Australia, and your traffic is routed to Australia and not to another location. So that's powerful. You can be high available at regional scale with nothing to do, but if you would like to be globally high available and multi-regional high available, HTTP load balancer can help you in this task. For DDoS mitigation, as I explained just before and as introduction, when you deploy your application on Google Cloud and any application, any services, you are behind Google front end. Google front end is a proxy, a global proxy at Google. It's not only for Google Cloud, it's at Google, for YouTube, for Gmail, for Google Play, and so on. You have a front end that's Discord, all DDoS attacks for network layer 3. It's great, but it's not perfect because sometimes you would like to add some smarter and more advanced protection on top of this basics filtering. For this, you can use and reuse your global HTTP load balancer and activate one feature named Cloud Armor. Cloud Armor is a customizable WAF. It's a web application firewall. And with this WAF, you can be protected against the top 10 OWASP protection. And you have also managed protection premium solution to interact and to guess which attack is performed on your service, because sometimes it's not one request, it's a sequence of requests performed on your application that which are an attack, and you can with this premium solution, this sequence is understood by the load balancer and Cloud Armor, and you are protected, and you can deny some intruder and some attack, yes, on your service. The last part of this is user access management. Again, with Google Frontend, Google Frontend has several assignments, and he has to filter the network traffic. He has to route the request to the correct endpoints. He can also filter the request that you send to Google Frontend, and if the request don't have a security header and valid security header, the request is discarded and the request don't go to your service. Like this, for example, with Cloud Run or Cloud Function, if you deploy Cloud Run and Cloud Function in private mode, I mean you require a security header valid, and you require that the user that performs the request has the authorization to access to your Cloud Function or Cloud Run. If these conditions are not valid, Google Frontend discard the request. And like this, if you have an attack with invalid headers or not authenticated requests and so on, all this traffic is discarded by Google Frontend, and you only manage and only pay for the valid requests that come to your service. This header and the security header, you have to add an OAuth2 token in the header. It could be an access token if you want to access to Google Cloud APIs, and it must be an identity token if you like to access to App Engine behind AIP, Identity Aware Proxy, or Cloud Function or Cloud Run. It's two types of token, and it's token that you have to generate on the fly, because a token is valid for only 1 hour. And sometimes it's a problem. Why it's a problem? Because some applications, some legacy applications, can't generate this kind of token because they are too old and they don't know how to generate an OAuth2 token dynamically before performing a request. Sometimes you have IoT devices on the field, and IoT devices are small and not really configurable or smart to be able to generate a first request to a Google Cloud service to get a token, and then to add this token in the header of the request and then pursue the data, because the device is too small, because the device works on a battery, and you have to save your energy in the battery to increase the life your device or your IoT devices. So you have some cases, or you can't generate an O2 token in your request. The solution for this is to add an additional layer between your serverless application and the external world and the internet. It's an API gateway, a fresh new product fully managed by Google Cloud based on cloud endpoints. It's for now exactly the same thing and the same behavior between the both. And in fact, this gateway, it's a proxy, can accept API keys or Firebase authentication token or cookies from outside, validate the API keys or the authentication, and if it's valid, a new request is performed from your gateway to your serverless application with an O2 token, because this API gateway is hosted on Google Cloud, and this gateway is O2 compliant and capable and can generate a token, add the token in the header of the request, and then perform the request to your backend. And like this, okay, you decrease your level of security, because having a O2 token with a short period of time of life duration is better than to have an API keys that API keys can live 1, 2, 3, 10 years without any change and updates. So it's weaker to use API gateway in terms of security, but it's better than nothing. And you have to be aware of these capabilities to enlarge the use case that you can address with serverless products. In addition, and in bonus, with API keys, you can set some quotas and rate limits on your API, and then to limit some abuse or misuse of your APIs, and then to save money and to be a fair usage of your APIs. So that's all for me. I hope you have learned a lot of things. I will be happy to be here with you. If you want to reach me, or if you have some question, don't hesitate to contact me on Twitter. I will also share my slides on Twitter if you want to get them. If you like to go deeper in the security feature, or on the other side of Google Cloud, I wrote some articles on Medium. Don't hesitate to have a look on them. I will be happy to discuss with you about this topic. It's always very interesting. And absolutely keep in mind that even if serverless is magic, you still have things to do in security to increase it, to improve your product, because it's very, very important for your public reputation. Thank you very, very much.
Thanks a lot, Guy. It was wonderful insight into the security aspect of the serverless computing, and very wonderful talk. Thank you very much.
Thank you.
Okay, guys, so since we're talking about the serverless architecture and we had some insight about the security aspects of things, so why not let's deep dive into this architecture and learn something about event-driven serverless architecture. So this talk is given by Mete Atamel, and Mete, I'm going to bring you on screen. Okay, so Mete is a developer advocate at Google. Prior to Google, he has worked at various places: Microsoft, Skype, Adobe, EMC, and Nokia. Looks like Adobe is common between both of us.
Good. Cool.
Okay, Mete, so stage is yours now.
Okay, thanks very much for the introduction. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google in the London office, even though, as you all know, we haven't been to the office since March. I'm going to be talking to you about event-driven serverless architectures, containers with Knative and Cloud Run. But before I start my talk, feel free to follow me on Twitter and my blog if you're interested in these kind of topics. And also, the presentation is already on speaker deck, so if you want to get the presentation, feel free. I will try to show some demos as well, even though the time is a little bit limited. And all the demos, they're already on GitHub. I will share the link at the end of my presentation. All right, I already told you about a couple of buzzwords, serverless and containers. And unfortunately, when you start a new project, up until recently, you had to make a choice between serverless and containers. If you could choose a serverless platform like Google Cloud Functions or AWS Lambda or Azure Functions or something like that, it's great because a lot of things are done for you, right? I think the previous speaker, he talked about the many aspects that the serverless platforms, they handle for you, so you don't have to do it yourself. And with that, you can focus on the code, and with that, you get a lot of velocity so that you can iterate fast. But then there are certain use cases where the serverless platform that you're trying to use does not work. For example, if you're on Google Cloud Functions and you want to run C#, C# is in alpha now. It's not fully supported yet. So at that point, what do? And the answer is usually you fall back to containers. And the reason why you fall back to containers is that containers, it's a way to package your application and package your application's dependencies and package your application's environment requirements into this context, what we call containers. And this context, the great thing about the context is that you can replicate it exactly the way it is on your laptop or on-prem or in the cloud. So you had this dilemma, basically. You go with serverless, go fast, but then if that's not available to you, go with containers, get the flexibility, but then you lose the benefits of serverless, right? Thankfully, projects like Knative and Cloud Run, they try to remove this limitation so that you don't have to make this choice for your projects. Knative, it's an open source project. It was started by Google a couple of years ago, but now a number of companies like Red Hat and IBM and VMware, they're contributing. It's open source. It runs everywhere you have Kubernetes, so you can run it anywhere you have your Kubernetes. Then there's two versions of Knative called Cloud Run and Cloud Run on Anthos. These are the managed versions of Knative on Google Cloud. So if you're on Google Cloud, you probably want to use the Cloud Run versions because it's easier to use. In today's talk, I'm going to be talking mostly about Knative open source, but everything I talk about applies on Cloud Run as well, and in an easier way, actually. The Knative stack looks like this. At the bottom, you have Kubernetes as a platform. Then on top, you need to install a gateway, because Knative, it doesn't try to solve networking problems. It doesn't try to figure out how to get traffic from the outside world to your containers. Instead, it relies on a gateway that you install. Typically, this is Istio, but there's choice as well. So if you want to use some other gateway, you can. Then once you have the Kubernetes and the gateway, you install Knative components. There's two separate parts of Knative serving and Knative eventing. You can use serving only if you want. If you don't need eventing, you can just use Knative serving. But if you need to use Knative eventing, it relies on Knative serving. I will mention Knative serving in today's talk because we have to understand that first before we can talk about Knative eventing. And then we'll get into Knative eventing and event-driven architectures. To me, that's the more interesting part of Knative. And then, as I mentioned, there are products that are being built on top of Knative, both on Google Cloud and other cloud providers as well. So you probably want to check out what implementation of Knative there is on the platform that you're running. All right, so let's get into Knative serving quickly. What is Knative serving? In a nutshell, it allows you to deploy containers in a serverless way. So in Knative serving, you define a Knative service, you point to your container, and you tell Knative, just deploy this container with this configuration, and Knative figures out the rest. So what it does is that it creates a pod for your container, then it configures Istio so that the traffic gets to your pods from the outside world. Now, once the container is up and running and it's publicly accessible, then it sets up automatic scaling, so your container scales up and down with the traffic. Then, as you make changes to your container, like code changes or configuration changes, when you deploy your container, you get new revisions of your service. So you will have multiple revisions of your service. And then once you have multiple revisions, you can split traffic between those revisions, right? So this is what Knative serving does. It's basically an easy way to deploy containers, get traffic to your containers, and then manage the different revisions of your container. Now, in terms of terminology, Knative service is the thing that's at the top that you create. That service has a configuration that points to the container and things like environment variables. Then when you deploy your service and the configuration, you get a new revision of your service, and then Knative points the traffic to that revision using the route. Every time you make a change with your service or the configuration, that creates a new revision, and the route gets updated. Of course, once you have multiple revisions, you can change the route yourself so that you can do more complicated things like, traffic splitting or A/B testing, things like that. Let me actually quickly show you this, how this works. First of all, this is my GitHub tutorial on Knative. I'll share the link at the end of the presentation where I show you how to install Knative on Google Cloud. I actually have a setup script that I maintain. And then I have a lot of examples on Knative serving, Knative eventing, and other things. So feel free to check it out. I already installed Knative. So here I'm in Google Cloud Platform. I have a Kubernetes cluster. I installed Istio on top. Then I installed Knative eventing and serving on top. And I'm using the latest version of Knative, which is 0.18 as of today. So let's just first make sure that our Knative components are running. So if I do get pods Knative serving, then I should see the serving pods running on Kubernetes. So you can see that they're running. And then let's actually look at the Knative eventing as well. So you can see that Knative is up and running. It's just another application on top of Kubernetes. Now, if I want to deploy a service on Knative, first what we need to do is let's just deploy a Hello World service. I create my code. The code is not that interesting, but just to show you what it does, this is C#, by the way. When the code receives a GET request, it will look at an environment variable called target, right? And then it will just say hello target. So if the target is v1, for example, it will just say hello v1. So it receives a request, it replies back with hello, the version number, the target number. Now to deploy this container, well, first of all, we built this, then we create a Docker file. So we containerize it, then we push it to a registry like Docker Hub registry or Google Container Registry. Then we want to deploy this container, and to do that, we will create a service.yaml file. In this service.yaml file, you can see that we are creating a service. So this is a Knative service. It's using the Knative API. We give it a name. Name of the service is Hello World. The namespace that it gets installed is default namespace in Kubernetes. Now this is the image that I already pushed to Docker Hub. And then this is the environment variable I'm passing in, target v1. Now, let's deploy this, but before we deploy, let's watch something. So here, I'm watching Kubernetes pods, Knative service, configuration, revision, and route. Now, of course, as of now, there's nothing. But if we deploy the first service, let's see what happens. Now, we are deploying the first service. Knative immediately realizes that there's a new service that's been deployed. So it created a service for us. It created the configuration of the service. It created the first revision of the service because this is the first time we're deploying the service. And it set up a route as well that points to the service's URL. And this URL, you can see that I'm using zip.io, which is a dummy domain service that I use so that I don't have to set up a proper domain. And the pod is also created. So the Kubernetes pod is also created and it's running, right? So all the things that needs to happen behind the scenes, they already happened. And if you do curl to that URL, you see that hello v1 is there, right? So we have a container up and running, and it's getting traffic. Now, if you ever use Kubernetes and Istio yourself directly, you will realize that this is much easier, right? Because if you had to do this yourself, you had to create the pod yourself, you had to configure Istio yourself, you had to create Istio gateways, Istio virtual services, and you had to combine that with the Kubernetes service. So there's a lot of work that you have to do to set things up. Whereas with Knative service, it's just deploy the service and everything happens. Now let's imagine we want to update this service. So in the second version of the service, I'm updating this environment variable from version 1 to version 2. So I'm doing a configuration change. In version 3, I'm updating the image. So I'm updating the Docker image from version 1 to version 3. And in this version 3, I am changing my message from hello to bye. So I'm doing a code change. So if we do these changes, let's apply the second version first, service v2. You will see that immediately Knative realizes that, okay, this is a second revision. So it creates a revision 2 for our service. It creates a pod for the new service. And you will also realize that the first pod is scaling down because we haven't used it for 60 seconds. And because of that, and because of auto-scaling that's already set up for us, it's scaling down. And now we have the second service running. And if we do a curl, we'll see that it says hello v2, right? And to do a code change is, again, the same. Service v2, we will change it to v3. Now we are using a new container image. And this will create the third version of the service. And then it will create the pod for it. And then if we do a curl again, now we are doing a code change by v3. So you can see how easy it is to deploy containers, to make changes to your containers. And you can also configure the traffic too. Right now, the latest revision gets all the traffic, but you can change it as well. Unfortunately, I don't have that much time to explain that here. But if you go to my Knative tutorial, there's a section where I show much more on traffic splitting and all that kind of stuff. And once we are done with our service, we can just say kubectl delete service and pass in our service name. And this will delete the service. It will delete all the configuration. It will delete all the pods. And we are back to where we were before. All right. So that's Knative serving in a nutshell. Now, we are talking about event-driven services. So that's why we should look into Knative eventing. And that's the second part of Knative. In Knative eventing, all we are trying to do is connect our Knative services to different event sources, right? So Knative eventing gives you this building blocks to connect different kinds of event sources to your event consumers. And also it gives you kind of a different delivery methods to do that. So there's a number of different ways to where you can connect event sources to your event consumers. Now, the building blocks of Knative eventing looks like this. So first, you have your event sources. These event sources, they can be two different kinds of event sources. The first one is the event source within your broker, within your cluster. So you can have a pod, for example, and this pod can generate events within your cluster. These events, they're CLUD events. It's an open source CNCF eventing definition. You can read more about it on cloudevents.io. But any pod that generates those events and sends to the broker can send events, basically. And the broker, by the way, has a URL that you can send messages to. So that's one event source type. The other event source is the event source that you install in your cluster and that reads external events. For example, in Google Cloud, if you want to listen Google Cloud PubSub messages, you can install Cloud PubSub source, and this source will read the PubSub events in Google Cloud. It will pull it into the cluster. It will convert these events into Cloud events, because that's the format in Knative, and it will pass it to the broker, right? So you get to choose what kind of sources you can install. And I should mention that there's a lot of event sources that you can install. I'm not talking about them here in detail, but you can see the full list in Knative documentation. Once the events get to the broker, they are Cloud events. The broker is the entry point of events in the namespace. You know, in Kubernetes, there's this notion of namespaces for applications. So broker will be the first thing that will receive the events. The broker gets injected into the namespace. So you don't have to actually create the broker yourself. You just label your namespace and say, you know, can you create this broker? And then Knative creates this broker and listens for the events. Then once the broker receives the events, then the services, and these are Knative or Kubernetes services, they can be both, they will register interest for different kinds of events. And this interest is registered through what's called triggers. So you create a trigger and you say, and then in the trigger, you mention what kind of messages you're interested in. So you have a filter function. And in this filter, you say, okay, this is the type of messages I'm interested in. And this service will get only those messages. And then this other service will get other types of messages depending on the trigger. And lastly, there's also the notion of event replies. So when a service receives an event, it can reply to an event too. So let's say service 1 receives this message. It can reply with another message, and that will go to the broker, and then broker will resend it to everyone who are interested. So that's also a useful feature to keep in mind. So that's Knative eventing in a nutshell. So what I want to do now, first of all, let me show you my tutorial. So there's a lot of information here that I'm just not mentioning because we don't have time. But if you go to my tutorial in Knative eventing section, I show different ways of delivering events. For example, there's simple way of delivering events where you connect a source to the service. Then there's the broker trigger delivery that I told you about, where you inject a broker with the services. But then there's also what I call complex delivery that you can set up as well, where you create channels and subscriptions. So there's all sorts of different ways of getting events, but I'm just showing you one way, the broker and trigger delivery way. I just want to point out that these exist. And then what I want to show you is this big query processing pipeline that I built back in March and April that hopefully will bring it together and show you how to build event-driven architectures with Knative. So this big query processing pipeline, just to give you a little background on that, this was back in March and April. And as you know, if you live in UK, that was a time where we started having COVID cases like everywhere else. And then what I was doing is that every day, in UK at least around 4 or 5 p.m., they published the new case numbers for COVID. So what I would do is that every day around 4 or 5, I would go to this website, get the data for the day about the number of cases, and then I would combine that data with the existing data from the last month or so, and then I would create a chart and look at the chart and see how the chart was progressing, whether the number of cases were increasing too fast or not, right? So I did this for like a week or two, and then I realized that what I'm doing is very much an event-driven kind of thing, right? Well, what I'm doing is basically on a given schedule, I'm going to a website, getting the data, and then extracting the data that I need. Then I'm combining it with the existing data. Then once I have all the data I need from the last month or so, I create a chart. And then once I have the chart, I look at it, right? So I decided that, why don't I build an event-driven system to do this automatically for me? And instead of me looking at the data, I can get an email every day telling me what the latest data is and show me the chart. So that's what I built. And the big pieces of this system looks like this. First of all, I use, you might ask, like, so where do you get the data? Thankfully, we have BigQuery in Google Cloud, which is a data warehousing solution. And in BigQuery, there's also public data sets on a number of things like GitHub or Stack Overflow or many other things where you can just use it for free and get useful data. So some of those data sets, they're related to COVID cases. And what I did is that first I wrote a Knative service called Query Runner. And this Query Runner will go and ask BigQuery, can you give me the cases of this country in the last 3 months or so? So it will grab all the cases from the country in the last 3 months or so, and it will save it into a temporary table. So that's all Query Runner does. So I set that up. Then I made Query Runner run on a schedule. So I set up class scheduler to call Query Runner every day at 4 p.m. So every day 4 p.m. Cloud Schedule will run Query Runner. Cloud Schedule will run with the country data, so it will run with United Kingdom or other countries. Then Query Runner will run the query on BigQuery and save it to a table. Then Query Runner will send a custom event. So it will say, okay, I run this BigQuery, and then it will reply back to the broker with this query completed message, right? So it creates a cloud event and sends it to the broker. Then chart creator will read this query completed messages, and it will say, okay, there's new data here that I can read. So it will read this data from the temporary table, and then it will create a chart using matplotlib in Python. So it will read the data, use matplotlib, and create a chart, and it saves this chart into a bucket, into a Google Cloud Storage bucket. And then we can set Knative so that when there's a change in the bucket, when there's a new file in the bucket, it can send a cloud event, right? So this cloud event goes to the broker, and then from the broker it goes to another service called Notifier. And Notifier is another Python service that uses SendGrid, which is an online service, to send an email to me, right? So it will say, okay, there's a new chart, and it will use SendGrid to send me an email to say, there's this new chart, go and check it out, right? So these are the main building blocks of this pipeline. The key thing here is that everything is event-driven, right? The Cloud Scheduler triggers the whole chain, but all the services, they communicate through events. They don't really call each other directly, and they don't really know about each other directly, right? So if I change something in the middle, it doesn't really affect other services. And that's the beauty of event-driven services. They're loosely coupled. Now, let's try to actually run this and see if it works. So what I'm going to do is, I'm in this BigQuery folder. First, we need to create this scheduler, right? This schedule to call our service. And to do that, I'm using scheduler source uk.yaml. And what you will realize is that in this YAML, I'm using an event source called Cloud Scheduler Source. This is an event source from Google Cloud, and it sets up scheduler for us. So in this scheduler, I am saying that, you know, I have this schedule, like 16, which is 4 p.m., and I have this data. This is the data of my cloud event that I'm going to generate. So in the body of the cloud event, I'm going to have United Kingdom as my data. Then every day at 4 p.m., I'll generate this cloud event, and I will send it to the sink, which is the broker, right? The broker will receive this in my namespace. So that's Cloud Scheduler Source. And then I also want to read events from the bucket where the charts will be saved. And to do that, I have another source called Cloud Storage Source. This is another event source from Google Cloud that will look at this bucket that I created. And whenever there's a new file that gets uploaded to the bucket, it will send another message to the broker, right? So I send everything to the broker. Now let's create these. So schedule source UK, and let's create the schedule storage source charts. So this creates the event sources. So that's how we are pulling events into our cluster. Now we want to deploy our services. So we have query runner, chart creator, and notifier. Let's look at the query runner. So first, the service definition of query runner is very simple. So I built my image and pushed it, and then I'm just passing in my project ID. So nothing special here. But the trigger is more interesting. So in the trigger of query runner, we are filtering all these event types. I mean, when you look at this event type, it's a Cloud Scheduler event, right? So when the Cloud Scheduler sends a message to the broker, from the broker, it will be filtered and sent to this service, which is query runner. So that's how we route messages. So let's create this. And then we'll do the same for chart creator. And then we'll do the same for notifier. And let me just show you the notifier quickly. If you look at the trigger of the notifier, it's a different trigger, right? The notifier, the service that sends me emails, only looks at storage events. Only if there's a new file, it will be called, and it will send me messages. So that's good. And then to look at the code quickly, I mean, we don't have that much time to go through the code, but I just want to show you one of them, maybe just to give you an idea. So if we go eventing and processing pipelines, BigQuery, and let's look at query runner. So the query runner is the thing that gets called initially. So this is C# code, but just to give you an idea, basically this code receives a HTTP post request. Then it creates a BigQuery client when it receives a request. Then it reads the cloud event. So we are receiving cloud events, right? So it reads the cloud event, which is from Cloud Scheduler Source. Then from the body, it extracts the country, United Kingdom. Then it runs the query with that country. And then once it's done, it sends a reply back with this reply that says dataset ID, table ID, and country. So it says, okay, I finished this query, and here's the data with this message. So that's the kind of code that you need to write. Now, everything should be set up now. So if we do Knative services, you can see that we have services. If we do triggers, you can see that the triggers are pointing to the broker, and they are pointing to the services. And I already have a broker injected into my namespace. That's good as well. Now we can wait till 4 p.m. for this to trigger, but we can also trigger it ourselves manually. So if I do G Cloud Scheduler jobs list, I can see that there's a job that's scheduled for 4 p.m. And then I can run this scheduler jobs run. And then this is another one, but let's just run and then copy this. Now I am triggering the scheduler manually, and this will trigger the whole chain. So if you actually look at the pods, you will see that the query runner pod is running, and then pretty soon we should see the notifier and chart creator also running. But let's just look at the query runner for now. So if you look at the logs of this query runner, kubectl logs, query runner, user container, you can see that this pod it received a cloud event, right? And the cloud event is from scheduler, cloud scheduler, and this is the data that it has, which is United Kingdom base 64 encoded. And then it extracted the country from that, and then it ran this BigQuery, and then once it's done, it replied back with this cloud event, and this will go to the worker, and then it will be handled by the next service in the chain. So it looks like things are working, and actually, let's look at the pods again. You can see that the notifier is running as well, the check creator is running as well. So if everything worked, let me check my email. Let me go back to my, I need to find my personal email, 1 second. So it looks like I received something. Yes, so let me pull this in. Hopefully you can see this. We received a new email, and this says, a new chart is available for you to view. It points to the Google Cloud Storage, and then you can see the chart I have. I didn't spend too much time to make this chart nice, as you can tell, but you can see that at the beginning we were doing pretty well in the UK, then it picked up around March, April, then it slowed down in the summer, and now it's picking up again, unfortunately. So maybe the lockdown is happening sometime soon. But at least I don't have to check the data every day. I can rely on Knative eventing and event-driven systems to do this for me every day and get the data that I need. So this is just one example of many things that you can do with Knative. All right, so that's that, and let's go back. Yeah, I think that's it for me. So as I mentioned, the presentation is on Speaker Deck. The Knative tutorial, what I show you, all the code and everything is open source and much more there. Feel free to check it out. And if you have any suggestions for the tutorial, feel free to open issues and let me know. As I mentioned, if you're running Knative, it's probably much easier to run Cloud Run instead, so you don't have to set things up yourself. So that I also have a tutorial for that, Cloud Run tutorial. Feel free to check that out as well. Thanks very much for listening. Have a good rest of the conference. I will quickly check if there's any questions in the comments before I finish. Okay, I don't think there's any questions. Someone said it's a good presentation. Thank you. I'm glad you like it. Yeah, thanks very much.
Yeah, thanks a lot, Pete. This was really very good. You know, people say that talk it cheap, show me the code, and you showed the code as well. So it was very good. And I have just one comment or maybe a question I would say. So yeah. Is the event-driven thing, is specific to the Google Cloud, or it's an independent concept? I believe it is in other architectures. So irrespective of the cloud provider you use.
Yeah, I mean, the concept of event-driven, it's independent of anything really. It's independent of any cloud provider. It's more like a design pattern really, because when you design services, you can do it two ways, right? If let's say you have two services, service A and service B. Service A can call service B directly. You can make a synchronous call from service A to service B, which is usually easier because all you need to do is just create an HTTP client from service A, make the call, receive the response, and that's it. It's easier, but it's not flexible, because if something is wrong with service B, then service A doesn't work either. So the whole chain kind of doesn't work when something is wrong in the chain. Whereas in the event-driven systems, what you usually do is you separate your services out a little bit, and then you put some kind of eventing in the middle. This eventing could be Knative eventing, but it can be something separate like Kafka or Google Cloud PubSub or something else. And then the services, instead of calling each other directly, they go through this eventing system. So service A says, I finished my task, send an event to this PubSub topic, for example, and then whoever is interested in handling that will pull that message and handle it. but services, they don't talk to each other directly. And the good thing about this is that everything is loosely coupled. So if service B goes down, no one cares. Like service A still can send messages and can still function. But at the same time, it introduces more complexity, because now you can't just make a simple call from service A to service B. You have to go through this, intermediary in the middle, and then when the service B has to pull the messages and process them. So it's a little bit more complicated, but you get more flexibility, basically.
Yeah, thanks a lot. Okay. So I'm just going to bring the third speaker into on stage, and Ashnita, over to you. Sorry, Ashnita, looks like you're on mute. So yeah, it's perfect now, looks like.
Okay, let me start again. So our next speaker is Raju Dawadi, who will talk to us about effective microservice architecture with Istio, Service Mesh, and Kubernetes. Raju is a Google developer expert in cloud platform. He is a DevOps enthusiast and is involved with the cloud native community in Kathmandu and Nepal. So welcome, Raju.
Me. So yeah, I'm Raju, all the way from Kathmandu, Nepal, and a Google developer expert in cloud, and engaged with Oyster, a Mexico-based fintech startup, as a site reliability engineer. So let me start my talk. So today we will talk about a brief overview on when we are migrating our monolith service to microservice, or building the microservices from the ground up, and then what we are going to expect from the microservices, and what Kubernetes, what challenges of the microservices architecture does Kubernetes solve, and a brief overview on service mesh, and then what is Istio, and what are the use cases we can use, what are the features it provides for managing those services more effectively, and then dig into a brief demo. I hope we will have more of time for that. So okay, so diving into that, so when we talk about migrating from the monolith to microservices, there are like lots of challenges even while creating the number of services. Even like when we were starting like breaking down the services to the microservices architecture, we are confused, like what are the, how much do you break it down? So and also like with the growing number of the services, the challenges amplifies, and there are lots of infrastructure as well as the development challenges, and in terms of the monitoring and all of those things. But basically, like we expect these things most specifically while migrating to microservices. We expect them to be more resilient, so that if one of the services fail, then another will be available, and we will not face like too much of the outage, and it will be more, we will be getting more of the independence while building as well as the deployment, and that will create a more speed in terms of delivering the application. We want to make it more scalable, and the team wants more flexibility also for deploying the services and getting it running, and that like means overall efficiency that we want to improve. And with that observability, we want that, because with the number of the services, like maybe 5 to 50 or like thousands of the services, we need a more effective observability way. And during that cases, so we face lots of challenges also while migrating to the more microservices architecture. So one is the like operational overhead, because when there is lots of things to be managed, that becomes more of the operational works, and we need more of the maybe DevOps or some kind of the cloud skills and the managerial skills also. And the service discovery also, because when we go to microservices, we cannot run like single instance of a service at once and just give some kind of a URL or IP address, which will be static, but we will need more resilient service discovery mechanism and the resource management also. So we need to allocate some kind of a resource which the application wants, or we plan some resource in the cap, like maybe max or min, somewhere around there, so that we won't be spending too much of the cost in the cloud, and get a full-fledged a benefit of the auto scalability also in the public clouds. And observability, of course, because when there are lots of services, we need more resilient monitoring mechanism. We want more alerting things, so that if there is any kind of a problem, we want to be notified too early, or like even we want like less impact to the live users. And from the security point also, because when there are lots of connecting dots between those services, the chance of the security compromise also increases. So we want that to be more secured. And also, like when we are going with the microservices, we don't want to delete like the monoliths, and we want more like effective routing policies, like this service wants to connect to this service, I want to allow multiple versions of a service to be deployed, and stuff like that. So for that, so Kubernetes solves some of the challenges in terms of the service discovery. Kubernetes has a very good service discovery mechanism. We don't need to worry about like IP addresses and all of those things, but the layer of abstraction the Kubernetes provides gives us that, and the health checking mechanism is inbuilt in the Kubernetes. And also the in terms of scalability, we can say it like I want to give this much of the resource, and if this much of the resource is being consumed, then just scale the application or scale the compute resource itself. So that overall gives some more resiliency to the application even by the Kubernetes. But why do we need the service mesh? So talking about that, so just a brief definition I would like to share, and I like it mostly. So service mesh is lies in the networking infrastructure, like between all of those services, but operates in the application layer. So that's a kind of very good thing about the service mesh, because this is well aware of the application layer or the L7 layer. So it is aware of all of the errors and all of those things which operates inside the L7 layer. So that gives us more freedom in terms of the routing policies, the securities, and all of that. So for that, while talking about the service mesh, Istio up to now, I would say, I proudly say that Istio comes on one of the top projects for the service mesh. And it is the like 10 of the fastest growing open source project in GitHub, and all of those things like the community supports and acting like connecting all of those dots between those services in terms of the traffic flow, in terms of the securities. And one thing is like when we go into the service mesh, that could be like any of the service mesh or the Istio, of course, then all of the traffic flows between any of those services is intercepted or handled by the Istio service mesh. So that means like if we consider a mesh as a home, then all of those services can be considered as a room, so that when we enter the door, we enter the service mesh, and there should be some kind of a locking mechanism in the door, so that that will be more secure and anyone cannot enter, or someone need to have the key for entering those service mesh or inside those service, or we can have like key for each of the doors, so that even main door or the main gate is compromised, then even in that way all of those services won't be compromised. And also Envoy is the heart of the Istio service mesh. Envoy is a very good proxy built on C++, and it is widely used by many of the other service mesh also, and it has like way more features as well as very low resource consumption. So digging into brief of the Istio architecture, it has a we can divide it as a control plane and the data plane. I would consider like control plane as a brain, which has like all of those logics from managing those configuration and the like service discovery, or like managing those certificates and stuff like that. But the data plane is actual where our like we can consider is at our body. So that means like the data plane is mostly related with the application. So if we see in the data plane part, so we have the pod for the service A, and there is the envoy proxy. So that means like when we enter into the service mesh of the Istio, then each of the pod or each of those container or each of those instance of the application will have the envoy proxy attached. So that means we will have 2 containers for each of the pod which are running inside the service mesh, and that operates, and every call between any of those service, between service A to service B, or that could be like service A one of the pod to service A one of the pod. So then all of those traffic flows between those envoy proxy, and the envoy proxy will be as a localhost for the pod. So that's how the proxy of the envoy works, and this is like kind of architecture. And there is like few components like galley, which is basically for managing all of those configuration for validating whether they are good or not, and the pilot is for all of those like traffic management, where we want to route our traffic to in which service, in which version. And for the security part, there is Citadel, which is for the managing all of those certificates and the keys for managing those TLS communication between those services. And when there are like lots of services, all of those policies which we apply, that needs to be sent to all of those services. So that is the things that the mixer does. So talking about the major facilities or the major benefits that the Istio provides is it has like very good intelligent connectivity. We can say like based on any of those L7 application layer like headers or the cookie, we can route the traffic to any of those versions, or we can like maybe add some delays over there, or we can like pass those, like if one of the service fail, then we can maybe add like a fallback service, or we want to provide like one version or another version of the service to one set of the users. So all of those like routing things is provided by the Istio. And talking about security, of course, because when there are lots of the services, we need to be more aware on the security. So for that, within the Istio service mesh, it has a very good facilities of providing the MTLS, so that all of those communication between any of those pods or any of those services is fully encrypted. And also there can be like a plain text or the MTLS, but MTLS provides very good security between any of those service calls. And when you need to like, and that also comes by default. We don't need to like any kind of generate the new certificates, or like any kind of like more overheads for managing those certificates, but it has a very good mechanism in that. Okay, and in terms of the policy,
I think we may have lost Raju. So we'll give him a couple of minutes, see if he can reconnect. Okay, so yeah, it looks like we've lost our speaker, I'm afraid. Such is the nature of doing these things virtually. I'm going to add you back in, Ashnita, I'm afraid, so I'm not the only one here. I think Raju is reconnecting. I hope he can reconnect, because Istio is really interesting, and
absolutely, yeah,
it's another one of those big topics that I think seem quite daunting and have quite a steep learning curve, but there's so many benefits to them.
Yeah, I think it's worth waiting just a little bit longer. We had similar in the web track this morning and waited for a little bit, and the speaker was able to resume. So fingers crossed.
I think he's just trying to join now. Not sure where he's connecting from?
I think he's from Nepal, if that's what you mean, his location. So yeah,
Fair enough.
Yeah, it's very connection dependent, isn't it? So let's just give a few more minutes.
Hi, Raju. Are you back with us?
Shit.
I think Raju's having audio issues. Give him another minute. Okay, Raju, you good to carry on? Share your screen again.
Yeah, just a second. So I'm really sorry for that.
Yeah, no problem. It happens. Okay, I'm going to put your screen back in, and I'll let you carry on. Cool.
Yeah, sure. So, sorry for the internet issues. Talking about the policy management, because when there are lots of the services, we need to enforce all of those policies across the services. And all of those configuration for the policy management is through a simple YAML file, so we don't have to learn about any kind of more languages for enforcing those policies or managing all of those securities. And so because when there are lots of the services, we need a better visibility for that. So for that, Istio provides us a good observability mechanism. It is inbuilt into the Istio mesh. So that includes Jaeger for the tracing, and for the Prometheus and the Grafana, as well as the Kiali dashboard, which gives us more visibility over what is happening over the service. And also for the security part, there is the MPLS, which gives us more secure communication between all of those services. And let's go over pretty quickly for the use cases. These are I talk about interesting use cases. There are lots of those, but for in terms of the canary release, we can by enforcing these simple rules. So with that, we can see if we want to route the traffic of the card service to 90% of the card service to the version 1, and then 10% of the traffic to version 2. Then by applying these rules, the simple YAML, then it can really route the traffic to these versions real quick. And for the fault injection, this also is useful for kind of simulation for whether if our application is not performing very well or taking long time, then we can dig that I need to get alerted when my application is not serving so quickly, or we can separate the performance in terms of the user experience also. In this case, we can see if the request has headers of the user track premium, then that will get delayed by the 5 seconds for the shipping service. So by applying these lots of tree-like rules over that, then we can applying just by the simple YAML files, we can achieve that. And for the traffic metering, this is way helpful when we want to release a new version of a service, or there is some kind of a breaking change, and if you want to see that gives some error or not. So for the traffic metering also, the Istio provides the inbuilt mechanism for that. So in this example, we can see any of the requests that is coming to the subset is table will be mirrored to the test version of that. So for the chaos mechanism also, or the chaos engineering, so that is for this, especially for the simulation of the failures, so adding like the fixed delay, or if we want to inject the random errors in our service and we want to get alerted if there is some kind of the error, or we can follow some kind of a process like the chaos monkey. That is like all of those, like most of the few of the bigger companies are doing that for applying the chaos mechanism, so that we will be prepared when there is error in the production or when there is anything wrong in the production. And also security out of the box, it provides like the denial of the IP addresses based on the request. And if you want to block the request, let's say if there is a request from one of the IP address which is coming at a certain rate, like I just want to allow only 50 requests from one IP in certain seconds. So these are the kind of denial or the allowed list that also Istio provides. And it gives us like a beautiful dashboard of the Kiali. So we'll dig into a brief demo on that. Like the Grafana dashboard, it acts as an add-on. And for getting there, because it is it might take some time for getting into there, but I would suggest to get started with a few of the service and then choose one of the few of the services which has some with impact which can see more often. Then that will also make it more interesting, or that gives a more reason for applying those services. And the Google Kubernetes engine as an inbuilt mechanism for the Istio, so that we don't have to install the Istio service mesh, but all of those like upgrading of the service mesh and handling all of those pilot components are there handled by the ZKE. So that also eases the process, but still it's not a free launch. There is a lots of iteration we want to achieve, because even while applying the Istio service mesh for Oyster, for the current company which I am involved on, so we had a lots of iteration from the day one. We did a lots more of research and applied that, and we had lots of changes in that, like in terms of the traffic routing. And also it's a kind of a evolving thing, so lots of things get changed more often. So for that we need to keep track on what is changing, what are the new features, or if there is any kind of the security patch going on. So that's also thing we need to consider. And also as we are running one of the second container for each of the pod, so that is also kind of bit of resource consuming and bit of, I would say, latency, but that should be like as a takeaway or the trade-off for that. And the next big thing is there will be like too many configuration of the YAML files, but that has to be organized if by the Helm, because we use mostly Helm, and Helm make it more easier for managing all of those Kubernetes manifest as well as those Istio configuration. So let's go into a brief demo. So let me share my full screen. Okay. Let me share my full screen on this one. Okay. Okay, so I have created a new ZKE cluster inside the Google, of course, and I have installed and for the installation process also, it's like way easier. I just installed it by using the Istio CTL. I just released, I just pulled up the 1.6.9 version, and it has a the CLI file Istio CTL just as the kubectl. And even by not changing any of those things and by applying the default configuration, but I changed one of the custom file for that, because I want to enable the add-on of the Prometheus, Kiali, and Grafana for all of those monitoring and the tracing stuffs. So just by using or just running this command, it will install the Istio components. So let it get installed, but I have already installed. So coming into a demo, so for that demo I pulled up a microservice repo, which is on the Google Cloud platform. You can see from here. So this is basically a shopping cart, and I just applied this Kubernetes manifest file, which has lots of the services in there, like the add service, cart service, checkout. So all of these services manifest file, like the deployment and the service file, are in there, and the Istio manifest basically for getting the front end ready. So I just applied 2 of these files. So for that, and if I need to browse that service, I just get into kubectl, get service, dash-n, Istio system. So all of the Istio components will be inside the Istio system namespace. So if I go into the service, so I will have this load balancer IP address, and if I go into this URL, let me go into, I think it's open. This is a nice shopping cart. We can go into like pick any of those items and add to cart, and we can keep on browsing, or we can place the orders or do anything like that. So for monitoring this service, we can enable. So if I want to access the monitoring portal for that, including the Grafana or the Kiali, so I will just go in here and I will go bin istioctl dashboard Kiali. So this would open a nice dashboard of the Kiali, from where we can see all of those services, all of those like routing between those services, which service is calling which service, and what is the error rate, and all of those things. So waiting for that. Okay. So we have 12 application runnings. So that means all of those services, and we have all of like these services running in there. All of those are healthy, and from the graph portion also, we can see all of like with all of those communication between those services in a nice graph. So we can see like without doing any most of the work, we can see like which service is calling what service and what is the error rate in there. So all of these things we can see from the Kiali dashboards, and also including the traces. So if we want to see the traces between those services, so we have a Jaeger platform. So this gives all of the service call between any of those services, and from this we can see like if any of our application or any of our services loading way slow, we can see the traces, and we can see like which service is taking more of the time, if the application is spending more time on connecting to the database. So we can see all of those traces, like if you go into the card service and find the traces. So all of these traces we can see from the Jaeger, and we don't need to implement like all of those tracing services to any of those services, but Istio intercept all of those traffic between the services, so that will be more easier in terms of the tracing also. So considering like saving bits of the time, so I just want to show a brief demo on doing a kind of canary deployment, and also brief of the demo on selecting the headers platform. So like if any of the user is sending the header user track premium, so then I just want to show the second version to that users. So for that I just did a quick change in there. So yeah, so by default there was like free shipping for the $75 purchase, but I just want to give some users with the $50 free shipping with the $50 purchase. So for that I have already there is a manifest, so I'll just apply that kubectl-f custom.yaml, and also the Istio platform or the Istio file applied as f, this one. If I reload this service, sorry, this is being created. Okay. Okay, so I am seeing $50 of the purchase because, or if I reload this one, so let me go to the home page. Okay, so I'm like starting to see the $50 of the purchase because I think I've injected the header in there. Yeah, so I've injected the header of the user premium, user track the premium, and if I unclick that one, so that could be or even the browser cookies could be used for that. So I would see $75 off the purchase. So based on that, we can even test our application to the internal users and serve it to the live users, so that we'll be more confident while deploying our application. So that's a kind of like interesting use case which we are currently doing on, because we don't want to roll out all of the version to all of the users at once, but we just want to be confirmed by doing the internal test to the live environment and then releasing the users. So after also for applying the MTLS, by just applying this simple YAML file, we would not be allowing any of the connection to the front-end service without the MTLS or without the certificate and the key. So that will give us more security inside the premise of our application inside the Istio cluster. And also like for the authorization, so this also expects like the headers when any of our users want to connect to our application. So simple use case is, so if I do apply this F and then just like do authorization policies over there. And if I want to browse my application, so I will be access denied because I have applied the rule that only the users which has the headers hello world will be able to browse the service. So if I inject the header hello world in there, so let me add one of the header. So if I inject the hello world, then I will be able to browse the service. So that's a kind of a brief demo for today. I think we're right on time.
That was great, Raju. Thank you for that. I was saying to Ashnita before, I think Istio is one of those things that people think it has a really steep learning curve because it's quite complex, but it solves a lot of problems, gives you lots of wins, doesn't it?
That was a great talk.
Yes.
Cool. So that's all of the talks for this morning. Thank you again, Raju. Thank you to all the other speakers we've had this morning. And thank you to my co-hosts, Ashnita Shadab and Goran earlier. So I'm just going to quickly show you some information about what's coming up later. I'll just share my screen. So yeah, we're going to have a lunch break now for an hour. We'll be back at 2:45 p.m. And the agenda for this afternoon, we've got 3 talks to start off with. How to run smarter in production, getting started with SRE by one of the authors of the Google SRE book. Then what makes a good DevOps standard, followed by cloud native Telegraf to level up your monitoring. Then there'll be a coffee break and 3 more exciting talks after that. And I have to remind everyone that if you tweet about the event using the hashtags, there are prizes. You can win a JetBrains license for any of their amazing IDEs. So that's really cool. But yeah, that's it for this morning. Thanks for watching so far, and we will be back in an hour. Okay, welcome back. Hope everyone's had a nice lunch and a nice break. We're now going to start the program for the afternoon on the Cloud Track, and I'm pleased to introduce the hosts for the next few talks, Henna and David.
Hello. Hey, Tim.
Hello.
Hello, everyone. Hello, David. Hello, Tim.
How you both doing?
Fantastic. Delighted to be here.
Absolutely. One of a kind virtual platform today.
And to be honest, our first guest, Jennifer Petoff, has been she's been an inspiration for the last couple of years for me. And I know, Tim, you were saying that you have her book behind you.
That's right.
Is that right?
Yep.
So, guys, you're in for a big treat here today. Jennifer's a fantastic speaker. We can't wait to get her in here. I mean, we have a few questions. I have a few questions here for Jennifer before we kick off before we start. I'm not going to do the best man speech on it and have the list drop down, but it's not very often we get to speak to the head of SRE training at Google. So
Absolutely. So to introduce myself, my name is Henna. I am co-organizer for GDG Dublin and Women Tech Makers Dublin chapter, and I'm happy to be here.
Tim, everybody knows who you are already. Are we ready?
I introduced myself this morning. Yeah. Do you want to introduce yourself, David?
Yes, I'm David Renton, co-lead of GDG Galway and Genesis employee, as you can see right here. Got to pay the bills, guys. That's how it is.
You mentioned the post this morning, and I thought you meant the band, but
no,
that
would be cool, though.
And I'm from GDG Bristol. Do you both want to take us quickly through the agenda for the next few talks, and then we'll bring Jennifer in?
Sure. First, as we've mentioned, we have Jennifer Petoff, how to run smarter in production. Henna?
The second one, we have Ruth, who will talk about what makes a good DevOps standard.
Last, we have David McKay on Cloud Native Telegraf, level up your monitoring. Can we bring Jennifer in now? We're like excited children. Hey, hi, Jennifer.
Hey, how's it going, guys?
Hi, Jennifer.
Hello.
Jennifer.
It's great. It's an honor to be hosting you here today. Jennifer, there's something I've been meaning to ask you. There's a rumor going around that you have a nickname of Dr. J. Would you like to expand upon that?
Sure, that is actually true. So I'm Jennifer Petoff, aka Dr. J. And the reason for that is before I started working in site reliability engineering ages and ages ago, I completed a PhD in chemistry. And I actually also like sports quite a bit. So those two things just led to that sort of nickname.
That's awesome. So your book, the one that's sitting beside Tim, our anchor today, that's so you edited that book, right? 70 Googlers, 500 years of experience in one book.
Exactly. So that I would say that's the coolest project that I've had the opportunity to work on at Google. And it's not my book, it's our book. Like you say, it represents contributions from over 70 contributors with 500 years of Google production experience. So we published that back in 2016. And I put a few items of flair behind me, so you're not just looking at my office. So I've got the book and a couple other fun things back there. In case you get bored with my talk, you can
inspect your background. That
Exactly.
book is still being published by O'Reilly, right? And it's become quite the Bible for anybody moving into large organization, isn't that right?
It is still quite popular, still for sale, and you can also find it for free on google.com/SRE if you'd like to look at the online version and not shell out the cost of a hard copy.
There's nothing quite like the feel of a real book, though, Jennifer.
Very true.
And speaking of those tangible kind of objects, I know you're a very avid photographer. One of your groups of photographs, I don't know what they're referred to as, of doors in Dublin is doing quite well, I hear.
Yeah, so as I guess, like, I normally love to travel quite a bit, but that really hasn't been possible lately with the pandemic. So definitely getting reacquainted with Dublin and all the beautiful places there are to see around here and elsewhere in Ireland. And I love taking pictures of the beautiful and colorful Georgian doors. So I tend to go a little crazy on Instagram.
That's right. Everybody want to check that out? Do you want to drop your shameless plug there for your page on Instagram?
Yeah, I'm Dr. J _ Sidewalk Safari. So thanks for that. Feel free to go check it out if you like doors. That's pretty much what you're going to get these days.
That's fantastic. Just one more thing I want to touch on before I let you move into your talk. Your work with the women tech makers and diversity in our industry has been taken off, and you've done quite a lot of work. Is there anything you'd like to mention to the viewers about that?
I would say, like, I've done a lot of work with universities in Ireland. I think that's how we met, David, before you graduated. So really just trying to encourage students who are studying computer science and allied fields to consider technical internships and full-time jobs. If you follow #GoogleTechIE, I tweet a lot about opportunities for students, and check it out. I've got a bunch of tweets coming out in the next week or so about various programs that we're running.
And just to note, that's not just for women to do. That's not this isn't a women's problem. This is an everybody problem. We all should be retweeting this and getting more diversity into our industry, and it is ours, all of ours. With that said, Jennifer, would you like to launch your talk? We will back off into the backstage, and if you need us, we'll be here.
Sounds great. Ready to kick it off here. So thanks, everyone. It's a pleasure to be here today, and I'm just gonna crack on with the presentation. So as David mentioned, I'll be discussing getting started with site reliability engineering today, or how to run smarter in production. We've already gone over a bit of the intros, just to recap for those who are just joining. So who am I? What do I do? I am a senior program manager on the site reliability engineering team at Google, and I've been doing that particular job for about 6 years. I work at Google in Ireland, so in the Dublin office normally, but work from home currently. And I lead Google's SRE education program. And again, one of my other claims to fame is I'm also one of the co-editors of the original SRE book that we published back in 2016. Coolest project that I've worked on at Google. David already covered one of my fun facts. For these virtual conferences, I like to do this. If we were meeting in real life, these are things I might tell you about over a coffee, or if I sat down next to you at the conference in real life. So I have a PhD in synthetic chemistry, which is how I came to be called Dr. J. And in my spare time, I'm also a part-time travel blogger at Sidewalk Safari. So that tends to be a bit of fun and keeps me busy. All right, so now that we've been properly introduced, let's begin the talk proper, and let's begin by talking specifically about the operational cost of software. So if you think about software engineering as a discipline, it's typically focused on designing and building, but not necessarily on operating software once it's been built and deployed. But really, running the software post-launch is the more expensive part of the equation. In fact, it can be 10x as expensive as building the thing. Organizations often really focus on hiring great software developers, but don't necessarily focus in as much on the operational considerations. It's perhaps seen as someone else's problem. And frankly, this in itself is a problem. So let's consider for a moment the traditional software development model. So you've got developers building new features, throwing things over the proverbial wall to the operations team, and then moving on to the next new and shiny thing. Meanwhile, you've got operators who are juggling everything that's being thrown at them, while being responsible for scalability, reliability, and maintenance of that software. So the reality is the incentives for developers and operators are not aligned. Developers want to go as fast as they can. Operators want to slow things down to reduce the risks and reduce the load. And this is a system that's not designed for harmony. It's brittle, and it really doesn't scale well. Now let's talk for a minute about DevOps and SRE. How do DevOps and SRE relate? We see DevOps as a set of practices, guidelines, and culture designed to break down silos in IT development, operations, architecture, networking, and security. SRE, on the other hand, is a set of practices that we found to work at Google, some beliefs that animate those practices, and a job role. So the reality is these two things are related but slightly different approaches for addressing friction in the software development lifecycle. We often talk about SRE as being an opinionated implementation of DevOps, or alternatively, class SRE implements DevOps. So let's consider the product life cycle. So from concept, vetting by the business, development and launch, onto operations, through to realizing the market potential of that particular product. There's a couple of points of friction in the process. So you've got friction between business and the business and development, which Agile in theory addresses. And then you've got friction potentially between developers and operations, and DevOps is meant to address that. So let's talk a little bit more about what SRE is and how it actually fits in. So SRE was developed at Google back in 2003, and it's a framework to operate and scale systems reliably without overwhelming the humans, basically. Our VP of SRE, Ben Traynor-Sloss, founder of SRE, quipped, SRE is what happens when you ask a software engineer to design an operations function. So the emphasis really is on engineering solutions. SRE focuses on running software in production, and it's, you know, we can talk a little bit about the philosophy for how SRE works. We think of it as a versatile model for mission critical systems, and we think the concepts can apply to small and large businesses, whether you're small, large, huge, growing quickly. We think there's stuff that you can take away. Of course, this talk is not about selling you SRE. It's giving you a sense of instead about how you might get started once you decide that SRE might be a good solution for you. And we'll talk a little bit about how it might be different from other models of operating your systems in production. So for the talk today, we're going to focus in on 4 key site reliability engineering principles. So number 1, SRE needs service level objectives with consequences. Number 2, site reliability engineers must have the time to make tomorrow better than today through software and systems engineering driven improvements. Site reliability engineering teams need to have the ability to regulate their workload through automation or pushing back on developers when the ops load gets too high. And finally, SREs see failure as an opportunity to improve. In reality, site reliability engineers and the organization's leaders really need to remove the word blame from their vocabulary. Things are going to go wrong. We'll talk about that. And blame really incentivizes people to cover up incidents and system faults. And if you address those situations, you'd end up making your systems more robust, more reliable. You can't run an effective organization on the basis of fear of being blamed, fear of losing your job. Okay, back to our product lifecycle. So how does SRE fit into the product lifecycle? So SRE is meant to be a bridge between the business, development, and operations. It sets up a common language, it sets up shared goals, and by sort of agreeing this framework in advance, it essentially takes any negative emotion out of decision making when things go wrong. All right, so idealized principles, all well and good, but the reality is that getting started with SRE or DevOps for that matter can actually feel quite daunting. So for the rest of the talk, we'll go through the 4 key principles that I just mentioned and how to introduce them to an organization. All right, first up, service level objectives or SLOs. SLOs are foundational to SRE. We're going to talk in this section about how to define them and how to use them to understand how reliable your systems actually are. So what is a service level objective? An SLO is really a goal for reliability, that meets the needs of your users. So how well should your system operate? And ideally, your SLO should track the customer experience. So for example, when you've met the SLO that you've set, that should be an indication that your customers are happy. And if you haven't met your SLO, perhaps you end up with sad, angry, or frustrated customers. So you want to set that service level objective at that point of customer hadness. Maddie Stratton, formerly of PagerDuty and now of Red Hat, actually invented that term hadness to describe the happy, sad point at which you'd like to put your SLO. So here's a few examples of SLOs. So the simplest one you can think of would be an uptime SLO. So your site is up enough. So, perhaps you're running a 3.9 system, 99.9% uptime, 3 nines of uptime. But the reality is, like, that's not often nuanced enough. So some of the things you might want to look at, does your HTTP server respond with success often enough or fast enough? Does your logs processor process enough log entries fast enough? If your customers care about stale data. If they don't, that's not a great SLO. A good SLO means picking goals for measures that track your customers' actual experience. So you don't want to measure things because they're easy or avoid measuring things because they're hard. You want to set the goals based on things that your customers actually care about. SLOs can actually get quite complex, especially when you start to involve these user expectations. And to put this into context, the customer reliability engineering team at Google actually runs SLO workshops that range from 4 hours to 5 days. So it can be quite a process, quite a complicated process to do this well. But what about SLAs? There's oftentimes SLAs, SLOs, these things are used interchangeably, and I'd like to spend a moment to just disambiguate the terms. SLAs, or service level agreements, are legal agreements between organizations with penalties for not meeting those agreements. SLOs, on the other hand, are defined around thresholds of customer happiness, as we've already talked about. So meeting SLAs doesn't mean customers are happy. It's just the point where they're unhappy and actually eligible to get their money back. So if you think about the definition of an SLO, or at least a good SLO, it's that if my application is not meeting it, my customers are starting to get unhappy, and this is a point well before the SLA where they're actually eligible to get penalties or what have you, where they're eligible to get their money back. Another useful rule of thumb, SLOs are typically set and observed within a company, whereas SLAs are often that handshake between companies with that contractual obligation. So what's next? SLOs are a foundation, but without consequence, they really lack useful impact. And you need consequences, which is what I'm going to actually talk about next. So let's talk about error budgets, or the consequences of violating a service level objective. And error budgets are not financial. They're really focused on improved reliability. So consequences of violating a service level objective is your error budget policy. So an important question to ask is, how reliable do you want to be? If you ask the powers that be in your organization, like, what do you think they're actually going to say? More, 100%, give me all the reliability. And oftentimes organizations that are new to these practices, they'll start at 100%, like, we demand perfection. The thing is, if you do that, if you start at 100% reliability and demand perfection, you need to treat any failure, no matter how small, as an emergency. But the truth is, we know that the only truly reliable system is one that does nothing at all and can never change or have anything change around it, or basically exist in a vacuum hermetically sealed from the world, which is impossible or near impossible to achieve. And to drive this home further, like, we should really consider Murphy's Law. So anything that can go wrong will go wrong, right? So true, so true. And even worse, we can look at Finagel's law of dynamic negatives. So anything that can go wrong will, at the worst possible moments. So again, you're just going to stress yourself out and trying to achieve the impossible dream here if you're aiming for 100% reliability. So a key realization that Ben Traynor-Sloss, the founder of SRE at Google, made was 100% is basically the wrong reliability target for basically everything. Will your users even notice if you're not 100% reliable? Do you have to hit 100% reliability to achieve customer happiness? Probably not. So SRE is really about balance and achieving balance between competing concerns. Site reliability engineering focuses on establishing what an acceptable level of failure is and balancing that need against other aspects of your business. So this lets you move fast when things are good and respond to failure appropriately when it happens. So you're balancing things like reliability, engineering time, development velocity, and cost. Okay, so because of this, we introduce a budget. If 100% is not the right target, we're effectively introducing a budget for failure, a so-called error budget. And the error budget is the difference between 100% reliability and the SLO for our application. And while we remain within our budget, we're more reliable than our goals. And when we run out of this budget, we need to invoke the agreed upon consequences. So, for a simple example, if we have an uptime SLO of 99.9%, that means that being down for 0.1% of the month is okay. 0.1% of the month is 43 minutes. So if you have a 20-minute outage, you have another 23 minutes of downtime to spend. An error budget is meant to be spent to go faster with innovation and feature development. But this, of course, doesn't mean you don't respond to incidents. You don't want to waste that budget. It just allows you to act with an appropriate level of urgency based on what's happening. So what happens when you actually spend that whole budget? That basically means that you didn't meet your reliability objectives and something needs to change. And that error budget policy are the consequences. And once again, it's not financial. It's something that's going to visibly help you remove your reliability, improve your reliability. So there's several examples we can invoke on error budget policies. You want to make sure you're doing something that suits your business and is specific to what's materially going to help your application improve its reliability. Error budget is a policy. It needs to be supported from the highest levels of your organization. Here's a few examples. So until the application is again meeting its SLO and has some error budget, no new feature launches are allowed. Sprint planning may only pull action items from the backlog, or the software development team must meet with the SRE team to outline their improvements. So to summarize all that we've discussed, this culminates in our first SRE principle. SRE needs service level objectives with consequences. Delving further, here are the key takeaways. Even without hiring a single SRE, you can have an error budget policy. This principle can be applied to any team, organization, or company, no matter what your structure. If the application you care about has good SLOs and an appropriate error budget policy, you can drive improvements. And again, as we go through this, you don't need to implement all the principles at once. This is about getting started. And principle one and doing this is really about how you might inspire interest in taking the next steps towards the site reliability engineering team, for example. So now let's move on to the second point, which is making tomorrow better than today. So this is where we're talking about what, if you hire a site reliability engineer, like what are they actually going to do? And how you can how can you basically set people up for success if you follow this SRE model? And ideally, again, you don't want to just be running systems under a new team name. Things are actually changing. The culture's changing. So this is all about making tomorrow better than today. SLOs and error budgets are the first step. The next step could be staffing an SRE role, and that role needs to be endowed with real responsibility. And the role needs to be engaged in operating the system, but also empowered to do something when things go wrong. So if you've hired your first SRE, what are they going to work on? First and foremost, defining and refining your service level objectives. That's getting the business and all the key stakeholders aligned on where you're going. The SRE is really can be considered as sort of the conscience of production. So they're possibly the best placed person to see that the error budget policy is enacted when necessary. They need to make sure that the application meets the reliability expectations of its users and are responsible directly to those users. And a good point here, it's important to think about reliability as a product's most important feature. So if the product's down, it doesn't matter how cool and shiny the other features are, your users aren't going to get to see them. When talking about making tomorrow better than today, we really need to discuss toil. So what is toil? It's any work that's manual, repetitive, automatable, reactive, lacking enduring value, or growing at least as fast as its source. And we recognize that toil is a major part of operating systems in production, and it must be part of the role. However, we see it as a bounded part of the role. Recommend putting a cap on toil. At Google, the toil cap is 50%, because if your SRE team or your SRE or team doesn't have time for anything else, your SRE is just doing ops. All right, so project work is also super important. So if you got a max cap on 50% of toil, like what else should folks be working on? And that's project work. And this is the most engineering project work is the most important piece of the job. So it's things like consulting on system architecture and design, authoring and iterating on monitoring, automating repetitive work, or coordinating implementation of post-mortem action items. So by giving the SRE teams time for project work, we find that it makes them happier in the short term. They're empowered to dig themselves out of whatever, toil or operational hole they may be in. And longer term, this makes the systems more robust to minimize future toil and ops load. So SREs tend to live in constant fear of operational overload because work will only compound until you're fighting fires and doing nothing other than ops. So project work is critical. So in summary, here is our second principle. SREs have time to make tomorrow better than today. And we can see how they do that by capping effort on ops and providing the space to do project work. So summarizing further, an SRE's job is not to suffer under operational load, but to make each day brighter. Brighter is open to interpretation, can mean different things, and it depends on what your SREs actually find most useful to do. They need to be empowered. Less toil means more meaningful system improvements. All right, now let's talk about regulating workload. So we're talking about getting started with SRE, and this is our third principle. We need to focus on shared ownership and shared responsibility. And SREs need to be able to regulate their workload. And a typical way of implementing this is by having an SRE team be part of a different organization. You've got a team responsible for running mission critical software in production, keeping it reliable. This might not be the right model for you. So this is just an exemplar, not a prescriptive approach. Okay, so first and foremost, dumping all production services on your newfound SRE team cannot work. And getting started with SRE will work better if you start with SLOs, build up some principled approaches to engineering to those SLOs, and then prioritizing giving your most mission critical systems to the SRE team to own. It doesn't make sense for SRE to own everything. And in fact, at Google, SREs are a scarce resource by design and are seen as a force multiplier, not as a gatekeeper. And they frankly shouldn't have the only keys to production. Another point, an overloaded team doesn't have time to make tomorrow better than today. So if your team takes on everything in production, from the most critical to the teeny tiny services, you're not setting your team up for success. So overload is actually a very real problem and can create a vicious cycle. So an overloaded team doesn't have that time to make tomorrow better than today. So do a good job of dealing with the most important pieces first, and then the team can take on a responsibility for more and more over time. Implementing a mechanism to give back pressure to dev partners can provide balance. So you want to set up this shared fate, this shared responsibility of running applications and productions, with some products being partially or entirely owned by dev or your DevOps organization. And devs will better appreciate the wisdom of operations if they're on call for a service or partially responsible for operations. Sharing the load with devs, even handing back the pager is another way to sort of build this mechanism to release the back pressure. At Google, there's actually two circumstances where SRE might hand back the pager if the service is super noisy, toil intensive, or difficult to support, or the service is running very smoothly and there's nothing for SRE to do. Regulating workload. So in order for the team to be able to continue to do a good job, to make tomorrow better than today, and engineer to the SLO, there really have to be ways for the team to push back when their workload becomes too much to handle. So here are some ideas, giving some of the operational work to devs, tracking projects. If the team's not completing projects, something's wrong. And then it's a good idea to analyze and onboard new systems only if they can be operated safely. It's much easier to push back on taking on something new than to hand back the keys, so to speak, once it's been onboarded to SRE. And it's always good to ask, if every problem has to be escalated to its developer, why is SRE carrying the pager? I'm just going to crank through because I'm running out of time. All right, leadership buy-in. So this is a key point. Without leadership buy-in, SRE cannot work. Leadership buy-in is required for every aspect of SRE, from the error budget policy to the cap on toil, and especially for the sense of shared responsibility. So if your leadership doesn't have your back and back you up on that error budget policy, you need to go all the way back to principle 1 and fix that. And because when applications miss their SLOs and run out of error budget, it puts extra load on the team. So leadership needs to either devote more resources to addressing reliability concerns or loosen that SLO, not continue to put the pressure on the team. It's a warning sign if the pager is going off too often and leadership asks, can't you just hire more people to answer the pager? That's not an SRE mindset or not an SRE approach. Throwing people at the problem, feeding the machines with human toil is not an SRE-minded solution. We talked about this a little bit. Fixing a product after launch is always more expensive. SRE teams, as much as possible, can and should consult on upfront designs, architecting resilient systems, and maintaining consistency. If you maintain consistency, it means fewer SREs can support more products. Automation is key. So use automation to eliminate toil, to do capacity planning, and to fix issues automatically. So if you can write the fix in a playbook, why not make a computer do it? So to finish off principle 3, SRE teams have the ability to regulate their workload. Teams need to be able to prioritize and do the work. Each new system to maintain has a human cost that should be recognized. And the team must be able to push back on unreliable practices and systems. All right, I'm going to very quickly talk about a culture of blamelessness, the 4th area of focus for SRE. So let's start by thinking about anti-patterns we may have all seen and think and understand why blame is dangerous. So I think the nuclear alert false alarm that triggered panic throughout the US state of Hawaii back in 2018 is an interesting case study. So for those that don't remember what happened, human error caused a statewide emergency to go out about an inbound nuclear missile attack. And I was reviewing, it turned out to be a false alarm, but I was reviewing this Wired article and saw this quote: "I'm extremely angry right now. People should lose their job if this was an error." And this was stated by a US state representative, Matt Lopresti. So this is actually an SRE anti-pattern. Like, blaming does not help. Instead, what we really need is to, like, SREs embrace failure by setting SLOs less than 100%, by modeling blamelessness at all levels and stamping out blame wherever it's found, by actually celebrating cases of, hey, I made a mistake that led to outages being resolved faster. And learning from failure, so important. You've already paid the price in an outage, so write a blameless postmortem, learn. You've made this sort of unplanned investment. John Allspaw is famous for saying that. So write a blameless postmortem and make that widely available so others can learn too. Recognize, of course, human errors are really system problems. You can't fix people, but you can fix systems and processes to better support people in making the right choices. Keep asking why. The root cause of an outage should never be a person. So finally, failure is an opportunity to improve. That's foundational to SRE. So celebrate failure. Don't use it as an excuse to brandish pitchforks. Failure happens. There's no way around it. So stop pointing those fingers. If you embrace failure, you will improve your mean time to detect and your mean time to resolve. And proactively addressing failure really leads to more robust systems. Great, and I am about done. I see our hosts are back on again, so perfect timing. I just wanted to leave you with this. You can find our the SRE book, workbook, and SRE book and workbook on google.com/SRE and Seeking SRE for an industry perspective. And thank you.
No, thank you, Jennifer. That was wonderful. I get the feeling that could be an hour and a half, 2-hour talk if time allowed. It's a wonderful subject, and we hope to hear more from you in the future. Will you be giving more talks, or have you any more time in your budget for the year to engage in community affairs?
Oh, so quite a bit. I'm giving a talk at All Day DevOps in November, and I think there's a few other bits and pieces that'll be coming. And SRE Con as well. I'm doing a talk there on some of our SRE education work.
Fantastic. We look forward to it, and we'll certainly share and like any of the posts you put out.
Great. Thanks very much,
Jennifer.
Cheers.
Bye-bye.
Thank you. Bye.
Bye-bye. Okay. Next, we have on stage Ruth Lennon, who will be talking about what makes a DevOps standard. Okay. Hi, Ruth. I feel it's a privilege to talk to you. I only recently came to know that you are chair of the ACM Europe. Would you
That's right, yeah.
throw some insight on that? Could you give some insight on that, please?
So the ACM are a professional body for people in computing or computing engineering related type jobs. And the ACMW are a aspect of it where we try to support more women in computing, because as you know, there's anywhere between 10 and 15% of women in the industry, which is quite a tragedy, really, because we talk about diversity all the time, but we don't get enough diversity in our companies. We don't see how that can help. So that's what I aim to do.
Wow, that's wonderful. I myself am a co-organizer for Women Tech Makers community in Dublin. And because I also kind of struggled a lot finding myself a platform, a job for myself. So I'm hoping I can also give back to the community the same way the community has given to me.
Oh, absolutely. And I think a lot of women who manage to progress in their career do that. They do give back to their community, and it's a good thing. And that's not to say that men don't do the same, but it's something we strongly encourage. Yeah.
Yeah. Thank you so much. So I also came to know that you are publishing a book on IEEE standards, DevOps Standard.
Okay, so there is a book coming out. The standard first. The standard has been in development for about 2 years, thereabouts, and it's due out very shortly. We've gone to ballot, and the first ballot had a few minor comments, which was really small, and we've addressed those comments, so it's out in its second ballot. So I expect it to come out in the next month or so, hopefully not too long. And a number of the authors are involved in writing a book about the standard and about how to apply it. Much more important, how to apply the standard.
Thank you so much. Looking forward to it.
Mm-hmm.
So I leave it to you. I leave the stage to you. I think we are already ahead of time.
Okay, that's perfect. So I am sharing my screen. And we should be fairly good to go, I think. Okay. All right, so my name is Ruth Lennon. And as you know, I've said that the title of this talk is what makes a good standard, or what makes a good DevOps standard. I am the director of Crave Technology Consulting, and I do a lot of other things besides. So let's have a look. Oops, and there we go, a bit slow. So what I do is I get involved in standards and standards writing. I'm involved in ISO bodies, the ISO, IEC, JTC, Open Source Working Group. I'm in the Cloud Computing and Distributed Platforms Working Group. I'm a liaison for the Software and Systems Working Group. I'm in the Software and Systems Working Group. I'm in the Agile and DevOps Working Group. And I'm in the Software Engineering Working Group, which seems like a lot, but it's not really, in that I've got two clear sides. I've got the more solidly cloud and tech side, but I've also got the software side. And you can see why, after years in industry, that I finally found my real niche, and that's in DevOps, because it's a merge of two solid bodies. So I do a lot with the standards bodies, and I have my own company. But aside from all of that, I also teach for Letterkenny IT, but that's something I kind of treat as being my spare time. The others are my passion. Okay, so we're here today to talk about standards. So tell me about standards, or why we have standards. Let's face it, we all hate standards. We all hate the fact that we have standards in the first place. There are too many standards to choose from. There's sometimes, I think, they contradict each other, and they're often out of date by the time we get them. And let's face it, standards can be expensive. And these are all very good points, but let's look at it another way. We shouldn't really hate standards. We, in fact, need these standards to be in place. The argument that there are too many to choose from, well, stop trying to do everything at once. You don't have to do them all at once. In fact, I'd say take them one at a time, understand the purpose of that standard, and let's work our way through which pieces of the standard we need to look at. And then we'll move on. Standards do tend to work together, particularly if you go with a single group like the ISO group. And you can see that ISO, IEC, IEEE tend to work together quite a bit. So they're written in such a way to purposely make sure that they do contribute to each other, and that they do not contradict each other. So the argument that they contradict each other is probably that you're looking at something that's quite out of date, and maybe it isn't even a standard. Maybe it's more of a best practice that's being purported as a standard. So look at where your information is coming from, and is there a newer version? And I think that standards are changing in how they're being written. They're a lot better than they used to be, and I think that's a good thing. Now we're beginning to see how these things should work. Okay, so they're often out of date. Standards are often out of date by the time you get them. Not if they're well written. If a standard is well written, it should be written in such a way that it's still relevant. It's not mentioning such narrow specifics that by the time you do get them, they'll be out of date. I've already mentioned that the standard that I'm working on with others has taken us 2 years so far, and we're not finished. There's a large section that I want to get put into that standard, and it's been drafted for, or it's been pushed off to the second draft. And we know we're going to write a second draft, but we also know we need to get that standard out there now, not wait any longer. So that was a decision we made, put the standard out. So are they out of date by the time they're written? They shouldn't be if they're well written. And I think that's something that's been fixed quite a bit. Standards should cover the what and not the how. Again, this is about the details. If the standard is well written, it'll talk in general terms about what you should do, about the processes, rather than the very narrow specifics of click this button. That shouldn't be there at all. Standards are expensive. Well, okay, I'll give you that one. Standards are expensive. The last time I looked, they were about $180 there or thereabouts per standard. And part of this problem is that you're going to have multiple standards that you use. But once you buy that standard, you're going to use it for a long time, and you're going to use it across multiple employees, and it's going to improve your processes in such a way that it's going to have a huge return on investment. So is it worth purchasing the standards? I would say yes, but I would also say that if I was in charge of standards, I would probably make them free, or as close to free as I possibly could. But I'm not in charge of standards, so I'm going to leave that argument aside. But we do need these standards, and it doesn't matter what the size of the company is. If you're a single person working on creating software, or if you're a conglomerate, you're still going to need to set out processes, good processes, in order to make your systems work. And I know that from Jennifer's talk earlier on, that she spent a lot of time talking about throwing money at the problem. Just trying to employ new staff isn't going to fix the problem. We need to really think about how this is a problem and why it's a problem, and then work on fixing that process. So the books that she had mentioned, I think they're probably already on everybody's bookshelf, but if they're not, they should be. Those describe processes to make your systems better. In their own way, they're standards, internal standards that you may choose to use yourself. There are internal standards, your own best practices, what you require as a company from all your employees or from everybody who's in development process. But then there are the external standards, and those are the ones we're going to talk about today. Now we're here at Google's DevFest. So Google uses standards and Google creates standards. They have created their own best practices or standards for website accessibility. And it's something that everybody follows because they show how to do the job and do it well. You don't have to spend the time trying to figure out what are the best practices in this area, because Google's already done it for you. And they've laid it out in a very clear and concise manner. They also follow standards. They follow a lot of standards. And I'm going to give one example, being the ISO 27001. They follow a lot of standards because they know that there are standards that have been written elsewhere by groups of people, including themselves. Everybody's entitled to join up for the standards authoring. And then they use those standards within the company. Okay, so let's look at some sample standards that we've got out there. We've got the ISO IEC 12207, and that's our systems and software engineering standard. It's a software life cycle process. So it's the SDLC to you and me, if we were to put this into simple English. Because standards tend to use, or at least traditional standards, tend to use long, convoluted names. And we need to simplify it into something that makes a bit more sense. So it's the SDLC. Another standard that we might commonly apply to software development is our 25,000 set of standards. And they're the systems and software engineering, again, systems and software quality requirements and evaluation. And you'll normally see this as a square box written down, and inside in that square box, you'll refer to those standards as your square standards. So that's an umbrella set of standards. So those standards are ones that we will use to try and improve our general quality. They work with the 12207 because they're in a different area. They work together. Let's look at the next one. And remember that these are only samples. The 29119. These are our software and systems engineering, again, software testing. So now we're focusing on the area of software testing. And it talks about strategies for software testing and the various testing levels and how we apply that. That does not contradict anything. In fact, it augments what's already there in the 25,000 square standards. So they are testing standards. And then just taking one more example, I'll cover the 27034 part 1. Now I'm only covering part 1 or mentioning part 1 because it refers specifically to information technology, the subsection on security techniques, but more specifically, the area that I'm mentioning here is application security. Now, when we look at application security, we look at security throughout our life cycle. We look at all our dependencies and on and on and on. There's a lot more to it, but this is looking at one small section. So from my slide, you can see that I've got the standards naming, and then we've got what we would actually call it. All of these standards, our SDLC, our Square, our testing, and our AppSec, all work together to improve the quality of our piece of software. There are more standards. In fact, we probably apply a lot more, but pick one and start with that one and see how you can use it to improve your processes, and then move through it piece by piece. We do that for each of our standards, and we get better and we get better. Continuous improvement, because everything we're trying to do here is continuous improvement. Okay, so I'm going to look at the 12207 as being rather similar to the standard that I really want to talk about today. So the 12207 covers the software life cycle, and it begins with our task planning because we have to plan out before we begin. It goes into the project assessment, the various controls we have for the project, how we make our decisions and how those decisions are recorded, our risk management, configuration management, because again, when we have made our decision, once we've made our change to our software, then we need to note how that has happened and keep a record of it. Because our teams change. People move into our teams who are new, and people leave the teams as they get promoted. Measurement, information management and measurement. So we're measuring how we're doing. Now, we could pick something nice and simple and say, okay, we're measuring the velocity of the team, or we could go into very detailed stuff and start looking at the number of defects per 1,000 lines of code and start getting into the tiny metrics. Start simple. Did you do a good job? How are you going to measure if you did a good job? Is the customer happy? How do you measure is the customer happy? What is it you want to measure, and why do you want to measure? What is the business reason for doing that measurement? So you can improve. Okay, but more specifically, and we drill down. We keep asking our 5 whys. If you ask why 5 times, you're more likely to get down the real nitty-gritty as to what's going on. Okay, so what do we need in a standard? When we create a standard, no matter what that standard is about, we want that standard to be clear. We need a solid objective so that we can focus on the key area that we want. And that should match very tightly with modern software development. I should be able to see when I pick up that standard how I can apply it in my day-to-day job. If I can't clearly see that, then I'll probably not apply the standard at all. I might nod and say yes to whoever my boss is, but I'm probably not going to do it. So it has to be clear. We need it to be adaptable because DevOps wasn't around a long time ago. Microservices weren't around a long time ago. Function as a service wasn't around a long. And as we go on, there's always something new. And we said that the standards become out of date by the time you get them. Not if they're well written. They should allow for the fact that you're developing code. It doesn't matter if that piece of code is for a traditional legacy style system or if it's for something more specific like a function as a service. They should be easy to read. If you can't read something, you're never going to apply it, which kind of goes back to the clear objective, but then taking that down a level and saying that for each step, each activity that we carry out, can we read that standard and understand what is expected of us? Because we are going to try to comply to that standard. So an easy way of making sure that that's clear to read is to have some use cases in the standard. And I find that a lot of the standards that are taken up and properly applied are those that have use case scenarios at the back. So those use case scenarios give an example for a specific user in this domain, this business domain. It'll say how this can be applied. Now, really, there are such a broad range of companies out there. And it's all well and good saying this massive company, yes, we're going to apply that standard from now on. But if you're in a small company and this company has 1 to 10, 10 to 50, 50 to 100 employees, how do you take on board this new standard and apply it? Should it happen big bang? Preferably not. Okay, then how are you going to apply it? You need to be able to take on a standard in stages. What can I do for now and say I can comply with this part of the standard or this level within the standard? So taking a standard in small pieces will help us get to a point where we can say, yes, we're happy with this. Okay, so one standard that I want to talk about today is the DevOps P2675. This is, in its full title, the draft standard for DevOps, as its draft at the minute hasn't been released, for building reliable and secure systems, including application build, package, and deployment. So it's got a long title at the minute in its draft phase. I'm hoping that that's going to be short as just DevOps standard. Keep it nice and simple. So what does this standard do? This one specifically focuses on establishing effective compliance and IT controls. Because when we develop software now, it's no longer a case of we start the job, we have our team, we carry out our coding, and then we come to a nice and tidy stop where we hand over our software in whatever format. It doesn't matter whether it's a disk or whether it's handed over online. It somehow gets handed over and that's it, we're done. That hasn't happened in a very long time. The software evolves, it changes. I like to say it's a living thing because it has a birth. It has this idea, the conception of the idea. It has a birth, it continues on, it grows, it changes. And then at some point it retires and dies off the system. So let's look at the principles of DevOps. So we've got our mission first. We need to focus on the customer. We need to talk about left shift, which is where we focus on quality and quality aspects from the very beginning. Continuous what? Well, continuous everything. Continuous development, continuous deployment, continuous quality is what we're really looking at. And for us to really be able to develop good quality software, when we develop our small piece, our small function that we're working on, we have to truly understand how that function is going to be used within the entire system. We need systems view thinking. So we're looking at DevOps systems, their interfacing systems. We're looking at their constituent systems, any enabling systems, and then our human participants, our customers, our stakeholders. And with systems development thinking, then we're talking about integrating a wide variety of perspectives. And again, this is something that in the last talk, Jennifer had talked about, and she had mentioned how it's really important to understand, to value those people. Okay, so if I take an aspect of it, what should the standard do? There are the project enabling processes, there are the technical management processes, and then there are the technical processes themselves. So I'm looking at it from three broad aspects. Okay, so now let's look at project enabling processes. So we might talk about infrastructure management or portfolio management. But then there are the ones that maybe we don't often think about. What about HR management? What about the human resources? What about the knowledge management so that when those new staff members come on board, how do we onboard them? And for those people who are already part of the team, how do we make sure that they have all of the skill sets that they need? When it comes to project planning, we need project control processes. We need to consider our decision management and our risk management. Are we willing and able to take on that risk? What about the configuration, the information and measurement? All of these tasks need to be considered, or activities need to be considered. We have our mission analysis to make sure that we stay on track in a more broad sense. That involves a lot of stakeholder inputs. So they define their needs. But there are other needs we need to consider. The system's requirements definition, our architecture definition, or design, and on and on. So we look at each of these stages to see how they are going to implement or how they're going to interact with us in order to create a quality product. So again, let's have a look. Oops, I have a typo. Dang it. So that should be part 1, not part 2, but moving on. So with DevOps, we hope to have greater visibility across the whole organization. So we want to see how technical management of the system applies across multiple domains. We don't want silos. We want our technical processes, and we want them to be used in such a way to provide an efficient product. But we also want that product to be safe and secure, and we want it to be reliable. Again, reliability, as Jennifer had already spoken. So we include our stakeholders, and we include them more frequently so that we can get their input. And when we create our processes, once we have our structure in place, we can get feedback from them. This feedback loop is a large part of what improves our quality. But who are our stakeholders again? Just to bring in a couple more. What about our legal department? So we want to make sure that we comply with whatever our documents are. We may comply with laws, regulations, internal policies, external policies, and on and on. Well, that will involve also reviewing the risk and to make sure how much time, how much effort is applied, and how much return that's going to give us. So we may have a certain level or appetite for risk, and that will vary from company domain to company domain. If I'm in my Facebook side of things, I might decide, well, you know what, it's not as big a risk as maybe if I was dealing with a piece of software to transfer x-rays from one hospital to another. So we decide on what that risk is. So we set across a process for establishing and maintaining these requirements. So those artifacts are then carefully logged. We have a repository of them, and that repository is version controlled. As much as possible, we want to automate these tasks because we're going to get bored in our job. I certainly got bored in my job, and I don't want to be bored in my job. If I do, I move on to something new. So if you have to repeat a task more than twice, if you start hitting that third time, write the script for it, automate it. But never automate until you have fixed your processes. Get your processes correct first, and then write the automation. Otherwise, a broken process is still broken, even if you automate it. So we design for cross-functional subject matter expertise, because we need to know where everybody sits and what they're going to do. And if we move on through the process, we're then looking at incremental development, continuous integration. And of course, as I've already mentioned, we're talking about auditing and regulatory sub-processes. We need to define our policies and standards so that we can track as we move from our, say, for example, from our baseline to our branched code, our merged code, how all of this happens. Where is our metadata stored? So our standard has to document the processes that are involved here. The processes for integration, for verification, for validation, for operations, for maintenance, and indeed the processes for retirement. Because again, as you know, there's an example of where a company didn't retire their software properly. It bought stocks. The new version of software bought stocks. They couldn't settle up their accounts at the end of the day. It meant that by not properly retiring their software, the company went bankrupt. Standards of tracking would tell us that that should not happen. So if they followed a standard, we wouldn't be in the state that that company had got itself into. So we're looking at continuous everything. Quality is not a single activity. This brings us back to our left shift. We have a lot of stakeholders. They describe their needs, and by us understanding their needs, we can improve quality overall. Each improvement that we make highlights another improvement area that we need to look at, because maybe the previous broken element was so large, we deprioritized the second area, or maybe we just weren't aware of it at all. So every time we make a fix, there's always room for new improvement. Of course, this brings us back to there are not enough hours in the day, which is why we want to automate. And our standard should give us guidelines on how to automate. So let's look at our left shift example. Well, some of the things we can do to help us, and this standard guides us with, are the creation of discussion forums so that that information can be passed on, what our internal policies might be and how to apply those policies, how we do our code reviews, disaster recovery, and so on. All of these policies need to be in place. How do we continuously integrate our code? What is a best practice for integrating our code? Doing the actual task, implementing that integration. And then again, following that example just through to the end, it's not enough to do the task. We then need to monitor and evaluate. And a lot of that can be automated. How do we do this? Again, our standard is going to help us with understanding what we need to do. So let's take it to our final slide, and let's talk about the takeaways from this particular presentation. If we have a good standard, it shouldn't need a team of experts to figure out how to apply that standard. A good standard can be used by small companies just as easily as it can be by multinational companies. Just take it in small steps. A good standard, in the end, it'll save you time and it'll save you money. But for me, most importantly, it saves me heartache in trying to get my processes right from the beginning. So if there's any queries or if anything breaks in the future, I know where to find the information, how to find the information, and I can say hand on heart that we followed our best practices. And so that's the end of my presentation. And thank you for coming to the presentation today.
Thanks very much, Ruth. That was enlightening. I mean, we all use standards every day of our lives as professional developers. We just probably don't realize that we're doing it. Like REST is a standard. You know, there's a web standard there because different components have to speak to each other, and it's interesting to see how you put it together. And also writing your tests first. If you have a standard which you know has to be passed, when you do your test-driven development, you're writing down your tests to pass that standard, and then you develop it to that standard. Thank you very much again. Thank you very much for your talk today. It was enlightening. Sorry, Henna, I didn't mean to talk over you there. I think you're on mute.
Sorry about that. Thank you so much, Ruth. This was very informative for me, for a person who does not know a lot about standards. So yeah, I hope the viewers found it informative as well. Thank you so much.
No problem.
Next up, we have David McKay, also known as Raw Code. I think some of you guys may have come across some of his instructional videos or his live streams from his website, Cloud Native Telegraf, Level Up Your Monitoring. Now, you prefer to be called David or Raw Code? Which is, Raw Code sounds slightly cooler, Dave, if I don't mind saying.
Let's go with David. I think it's going to keep things simpler. But if you want to go with Raw Code, I'll take it anyway.
Well, there's no harm in putting out those plugs. You know, get a few more viewers on your streams. You can level up a few more people on Golang, and all the rest of the interesting stuff you do over there.
I'll take every viewer you give me. Definitely keep them coming.
No problem. We'll try and hit it up on the official channels. So, David, during a chat we had, you know, you're really proud of the advocate work that you do. Would you like to tell us a little bit about that before you start into your presentation?
Yeah, sure, no problem. So I've been a developer advocate for a few years now, although I started doing public speaking maybe 5 or 6 years ago. And I just found a lot of joy out of it. I prefer going to events, meeting people and talking about their problems and actually solving my own. So I just got into this really nice flow of where I would, you know, write a talk, learn a technology, and then try and share that with as many people as possible. And that got me into developer advocacy, where I've been working with Influx Data for the last 2 years, and now I'm at Packet/Equinix Metal, where I've been for like 4 months now. And it's just a wonderful opportunity to go and play with as many technologies as I can find, and then share that with other people. So I really enjoy it.
I have heard someone say before that the easiest way or the quickest way to learn a new technology is to agree to give a talk on it.
Exactly. Conference-driven development. That's how I learn everything.
Oh, fantastic. It's some achievement. You did 42 in-person talks last year. That's quite amazing. But the bit I want to speak to you about is what sort of circuits have you been getting onto? You did a talk in a warehouse in Amsterdam and an underground nightclub in Berlin. That sounds amazing.
Yes, I mean, most of the venues in the US tend to be hotels or, very standard conferencey venues near airports. But in Europe, we just got so many old buildings that aren't being used much anymore that they're just cheap space, ripe for events, in-person conferences. Nightclubs specifically, the acoustics are already made for sound and speech and other things like that. So I've been really impressed with some of the venues around Europe, definitely.
That's fantastic. I know you love to do some soft play climbing with your daughter, which is fantastic. But you think we're blowing you up way too much here. I don't want you to get a big ego, so I've got to bring it up. I'm sorry, David. I'm sorry, but there's a rumor that you had a certain costume on while DJing around Halloween time. Is that right?
Yeah. Well, I mean, I grew up with Mr. Blobby in Noel's, what was it called? Noel's house party. And I got an opportunity at Halloween to DJ in a nightclub in Glasgow, like 1,000 people. And I thought, you know what, I'm just going to get the stupidest costume I could. And it was a Mr. Blobby one. I was so happy with it. There are photos online. Feel free. You probably need to guess the DJ name, but good luck.
Thank you very much, David. Listen, I don't want to take away from the time you have allotted for your talk. So without further ado, we will slide off backstage and let you continue.
All right. Thank you very much. All right, there we go. So today I want to spend a little bit of time introducing you all to a product called Telegraf. Now, about me, I am a developer advocate. I work at a company called Equinix Metal. It's a very recent rebrand. You may be more familiar with the company Packet. Same team, same product, different name. I really enjoy writing Rust. It's my new obsession. I fight with Kubernetes and have been for many years. And I'm really enjoying working with people and helping them build out more opinionated and specific and problem-solving observability pipelines. And some of what I'm going to share today is hopefully going to help you along that path too. There is a disclaimer. I've already said it just a few minutes ago, but I did used to work for Influx Data. The product that I'm talking about today, Telegraf, is open source by Influx. And I think that's a testament to how good this product is that I don't even get paid to talk about it anymore, and I'm still wanting to talk about it. So Telegraf, very, very cool. So what is it? It's written in Go. It's available at github.com/influxdata Telegraf. It is a metric and log collection agent. It's a single static binary. There are container images. It has plugins for everything. By the end of this talk, you should have a pretty good idea of what it is and why you want to use it. What I really love about Telegraf is that it doesn't really mind or care where you want to write those metrics or logs to. Even though it's by a company that produces a time series database, the number of outputs in Telegraf is continually growing, even with their competitors' products. So it doesn't matter if you're using Prometheus or a SaaS product like Datadog or New Relic, you can still use Telegraf to collect all of your metrics and write them to the location or multiple locations of your choice. And this is just a sample of the couple that it supports. There are over 220 plugins, and it's always growing. There are new contributions by companies around the world that just want to have Telegraf support because it's such a widely used metric plugin. So it doesn't matter what software you're using. I'm hoping you're going to see that there are plugins that make it work for you. Now, if you're monitoring Linux, which I'm going to assume a great deal of you are, then Telegraf is fantastic here. Some of the core plugins that you're going to use for monitoring Linux will include CPU, memory, disk, and network. It's pretty good on Windows too. And because it's written in Go, it can be compiled across multiple architectures and systems. There are a few specific Windows plugins, and I just put in Procstat as an example at the bottom here, but it actually works across these different operating systems. And there are a number of plugins within Telegraf that do have multi-OS support. So it's not just the ones prefixed with Win_. You can usually get a lot more information from others too. And it really does love your software. It doesn't matter what you've got running in your stack. This allows you to monitor MongoDB, NAS, and Redis that are listed here. It also supports Kafka. There's Prometheus integrations. Any database that you're working with, whether it be MariaDB, MySQL, Postgres, Couchbase, etc. And even TeamSpeak. I'm not sure why people are monitoring our TeamSpeak, but it's definitely an option. And I always say that Telegraf is going to allow you to get more sleep. All that stuff that we don't necessarily monitor first, or sometimes we forget to monitor at all, is available as well. So, how many outages have you read about online where people aren't monitoring the expiration on their X509 certificates? What about the smart status on your drives? What about networks with SNMP and SLO, right? Telegraf really does provide a very powerful system for collecting metrics from almost anything. And of course, it also allows you to monitor things that haven't previously been monitored. There are some really nice hooks or extensions within Telegraf that allow you to get metrics from just HTTP. You can also use Unix domain sockets and datagram sockets, or use the exec or execd plugins, which allow you to execute arbitrary code or binaries on the host that's running or the container with your own proprietary code to also collect metrics. So nothing is unmonitorable anymore. And that includes Kubernetes. There are a whole host of Kubernetes plugins for getting metrics from the API server, from the underlying machines, VMs, everything. And it has really good support for Prometheus and service discovery within Kubernetes. So it is a drop-in replacement for a variety of solutions. And I'm going to say that it's easy with Kubernetes, but I do have a level of bias here, and that I maintain the Helm charts. One of the principles I have with the Helm charts is I want it to be really opinionated. So you'll find that our charts that cannot be configured that much, because they are just the opinionated way that I feel, or we as the maintainers feel, some aspects of Kubernetes should be monitored. We also do provide flexible hooks, though. So if you want to drop in your own configuration and just blow away the opinionated stuff, that is definitely possible. And this is the best way to deploy Telegraf for any of the Influx data stack on Kubernetes. All right, so that's the pitch done. I'm hoping some of you have got your interest piqued now. So what I want to just say is here are a few really simple things that Telegraf offers that just make the whole thing much better for your metric pipeline. First, it removes the cohesion of intervals and flush intervals. You can actually specify with 2 flags on the TOML how often you wish to collect pool-based metrics from some system. You can also specify a different flush interval, which opens up a whole load of new pipelines to the way that we buffer and cache the metrics in memory before flushing them down the host. This just means that we can perform and optimize for the write path as well as read path. So you got that kind of flexibility there. It also allows you to set the round interval. Now, this is a common problem with metrics pipelines, especially when you want to perform aggregations within the database layer. But if you run 2 telegraphs or 20 telegraphs or 100 telegraphs across a horizontally scaled infrastructure, and they each start at separate times and they're on a 10-second interval, you really need the collection agent to be responsible for rounding the metrics up so that when they hit the server, they all have the same interval or window period. However, that can lead to a really challenging problem, and that you then, depending on the size of your infrastructure, could be sending dozens to hundreds to thousands of requests to your database at the same time. Telegraf also allows us to make that configurable through something called jitter, which just means offset the write from this machine, node, container, etc. by a random number of seconds or milliseconds to kind of spread that load across so you're not hammering your database too much. Now, for container-based environments or Kubernetes-based environments, some people may wish to contain the container ID, which is also the host name, as part of their metrics, but this can lead to really severe cardinality problems depending on the backend database. Telegraf with a very simple flag allows us just to terminate that and remove the flag or remove the host name from all the metrics that we write to the database. It also supports interpolation, which means that you can provide your configuration for Telegraf using bash syntax style variables to pass in your secrets. This works, again, really well in a Kubernetes environment where we can just mount the secret as environment variables and have them injected into our configuration. Great for keeping those pesky tokens and API keys out of our Telegraf configuration. And the magic sauce here, Telegraf has an internal plugin. Telegraf provides a way for it to expose metrics about how it is performing itself. And we're going to be taking a quick look at that during the demo as well. The Telegraf does have some superpowers that really push it beyond those simple things that I've covered there. Now, one of them is it supports the ability to push and pull metrics. You don't have to make a decision. You can use a variety of listener-style plugins within Telegraf, which expose HTTP, TCP, UDP, etc., servers within the binary, so that your applications can push metrics to it. And of course, at the same time, it supports pull. Now, I'm not going to say that pull is considered harmful, even though that's the title of my slide, but I just want you to be aware that whenever you see a pull-based metric system, the first thing that should really pop into your head is that I have aggregated metrics. I have aggregated information. I am no longer working with raw absolute values. And most of the time, that might be okay, but you should be aware of it. Of course, push is also considered harmful. And that if you want to work with raw and absolute metrics and logs, then the quantity is vast. And maybe just storing that amount of data and even the expense of storing, of transporting that information over the network can be very, very expensive too. So it's not that you have to pick one or the other. And what's really the superpower of Telegraf here is it allows us to pick and choose and use the ones that make sense, given the resolution or the specificity that we need for each metric and log. So it depends. Understand what you need and why you're collecting your information, and then use the appropriate plugins where required. Now, another really great use case for using Telegraf as your metric collection is that we get redundancy, resiliency, and performance improvements by injecting this little binary into your application stack somewhere. How do we get that? Well, first and foremost, we can write our metrics that we collect from a Telegraf to one or more output locations. This means I can write my metrics to Prometheus, I can write them to InfluxDB, I can write them to Datadog, New Relic, CouchDB, MongoDB, Kafka, whatever. As many of them as I want, as long as I've got the hardware to support the workflow, of course. But it just means that we can always do cross-verification that our metric pipeline is actually accurate. Maybe once an hour, once every 15 minutes, just check that we're getting the numbers we expect across more than one location. Something else that Telegraf really offers us is the ability to change the batch size for those write operations. Again, trying to make sure that we don't overload the database. And sometimes overloading your database can just mean that you're sending too many small requests. By changing the batch size, we can actually just do, a lesser amount of larger batches and keep our database a little bit more happy. Generally, I just throw out a number like 10,000 and say, go with that and see how far you get. But the ability to match a batch by holding these metrics in memory and flushing them at the same time will get you serious performance improvements. And we also have something called a buffer in Telegraf. Again, depends how big your machine is and how big you can set this buffer. But what if your database is down? Your Telegrafs are collecting your metrics, but there's nowhere for it to write them. Well, it's not just going to discard them. Telegraf will store as much as you want by allocating the memory based on the buffer size per output, which is always really important to understand. And it will keep those metrics there, and it will continually retry until that database comes back online, and then it will batch them all the way down the pipe again. So in theory, you can have slightly more flexible guarantees on the uptime of your database and perform maintenance windows as long as you plan accordingly by telling Telegraf that you maybe need a bigger buffer during those periods. And Telegraf does proxying too. Now, what do I mean by that? Well, it's very standard that our architectures sometimes look like this, and that we have our application directly write to our metrics to, InfluxDB or some other metric store. We have our Telegraf agents, which is consuming metrics from our network, from our virtual machines, containers, any third-party software, things like that. But our application we do treat differently because we can instrument it. We can hook in OpenTelemetry and OpenCensus and other things like that. So our applications are now just doing distributed tracing and metrics and logging directly to some database. And that can mean that if we lose access to that database, we're back in this position that we are losing our metrics or log data. But the stuff going through our Telegraf is actually fine because we have the buffers and the batches, and Telegraf is going to hold that information for as long as possible. So we can actually change the path so that our application will write to Telegraf 2 without modifying any code. And the way that it does this is by supporting a few listener-style plugins which act as proxies. We can have Telegraf pretend that it's an InfluxDB, version 1 or 2. We can have it pretend that it's just, well, not pretend, it is an HTTP server. which can accept any arbitrary payload over JSON, CSV, a few other different formats that are supported, as long as you provide a little bit of configuration to tell it how to decode those messages. And Telegraf can even just run as a socket listener. You can expose sockets across Linux systems and have your applications just echo or cat information into it. It's really easy to get metrics out of anything and proxy them through Telegraf to just absorb all of those benefits and superpowers for the resiliency and redundancy that you may need, and even for those performance improvements too. So Telegraf does kind of allow us to modify the architecture and the way that we build our metric pipeline. It now becomes more infinitely scalable and horizontally scalable and redundant, all these things that we want and we need, because if we're going to run our applications in production, we need to be able to observe them. And observing them means not losing metrics because any one part of our system is down. That is not very robust. So what we end up with is an architecture that actually looks more like this. So we just moved one line. Our application also goes through a Telegraf. Now, the wise ones amongst you might be going, but now our Telegraf is a single point of failure. Yes, you are right. Now, before I solve that problem, I would also just throw in there as another superpower, a very new addition to Telegraf. I think it was released at some point this year. But you can run it in a serverless fashion too. So rather than running a long-running Telegraf in a container on Kubernetes or on the bare metal or whatever, you can just pass the once flag and have it collect the metrics, write them to the database or a queue, and then exit. And you can schedule that on, things like Cloud Run or OpenFAS, etc. So lots and lots of potential for the way that we consume and use Telegraf in our metric pipeline. Another thing that's really cool and another superpower is that Telegraf allows us to do introspection of our metrics in memory to just expose some of that information to the outside. Now, as developers, if you are a developer, you might be looking at this going, yeah, I've written this health check before. And I see it all the time. And that is, application developers often feel that if an HTTP request can hit their service, can be satisfied, and a response is spat out, that is enough to tell them their service is healthy. But it doesn't actually tell you anything about the service other than it's responding to HTTP. It doesn't tell you that it's actually healthy. This is not a health check. However, using Telegraf, we have the ability to say, okay, we're going to expose an HTTP endpoint on this port. We're going to use a measurement in InfluxDB or Prometheus or whatever called web metrics. And we're going to analyze some of the fields or the numbers that it emits that tells us about that service. Now here, this is a really simple, contrived example. I'm just going to monitor the response time of all HTTP requests to the application. And as long as they're less than 300 milliseconds, I'm going to consider my application healthy. Now, of course, this is still not a great health check, but you can add more of those comparisons, and there are a few other operators that just allow you to analyze those metrics. You can look at distributions across your metrics. You can look at our slow endpoints. You can look for failures on payment-specific endpoints, things that you decide, this is when I need to page somebody. This is when I want to restart this pod. This is when I want to do something. So Telegraf, having that ability to do that is really, really important and definitely a superpower. All right, now that's really good. But Telegraf, again, very recently, and this was only a month, maybe 2 months ago, I think, added a new support that takes that to the next level. And it's actually the ability to embed a subset of Python called Starlac. You may be familiar with it from the Babel project, inside of our Telegraf configuration to do even more advanced stuff with our metrics. Here, I just have an example where we are just going to do a quick filter. So if our metric name isn't this, so we're just saying, okay, return the metric and do no modifications. But what I'm saying here is, and this is analyzing the internal metrics from Telegraf, is if my buffer size, monitor my buffer size and limit, and just spit out a percentage variable, something that's easier for me to query on the server side, rather than me having to do this all the time. This can just save you more computation on your database, which might not be prepared for it under heavy load, and pushing it to the edge, essentially, where Telegraf lives. So it's quite a simple example. I'm going to show you this working as well. But the ability to inject Starlac scripts into our metric collection opens up a whole new world of enrichment and calculations and other stuff that we can do with those metrics. All right, so covered the simple stuff. I've covered a few of the superpowers, and now I want to try and give you a bit more of a contrived, yeah, very contrived, but more of a wider scope, bigger picture. This is what it can do when you join all those dots together. And I have a demonstration, a demo that I'm going to try and show you, depending on how much time we have left in a few minutes. So sidecars are obviously all over rage in Kubernetes land, right? One of the challenges we had was my Telegraf was now a single point of failure. My application was right into it. All of my infrastructure was right into it. All my third-party software dependencies were being consumed by Telegraf. And if Telegraf goes away, not only do I lose my my metrics for everything, well, in fact, that's the biggest problem, right? I lose all my metrics for everything. The sidecars are a thing. So what if we change this architecture again? Right. And this is what I always try and encourage people to do that are using Telegraf, is don't just run one of them or don't run 4 of them. Run dozens to hundreds to thousands. Run as many Telegrafs as you need to be able to define the quality of service that you need for each specific use case of metrics. Here, I've got my bare metal and VM, my host-based monitoring has its own Telegraf with its own configuration, its own batch and buffer semantics. It decides how important that information is. Very same for the network. How important is the network information? I may want to reduce the cardinality or the resolution of that data because it's much more vast than just monitoring the CPU or the memory of a host. Software dependencies the same, application the same. Just put Telegrafs everywhere. Everyone gets a Telegraf. Now, of course, we're still in a situation where our TSDB is potentially a single point of failure. How long what if it goes down, right? We've got our buffer and all of our Telegrafs, but how big are those buffers? When do we start dropping metrics? Now, another pattern that I see time and time again, the more companies I speak to, is that they actually want to have Telegraf, right, to some sort of queue system. Kafka is an example here, also supports NATS, there's a few others, ActiveMQ. Then my Telegraf's just right to that, which I probably, hopefully, got the operational experience to keep that up and running substantially, or 99, whatever, how many nines you want. And then we just have Telegrafs on the other side. Telegraf already has plugins to consume NATS and Kafka. It wrote the metrics in. It can definitely read the metrics back out and then just write them to a database. That also allows us to horizontally scale and control the ingest of our metrics to a TSDB. So I can scale that out as much as I want, as little as I want, control that flow of information to make sure that I control the database. I control the right performance of the database. I understand what it can handle based on the hardware that it's got, and I make sure that I don't overload it too much. So we can just use Telegrafs on top of Telegrafs on top of Telegrafs to get the kind of system, the redundancy, resiliency that we need to have a metrics platform that we trust. So let me show you that in action. So the first thing, this is not on Kubernetes because I really want this to be easy for people to spin up. So I'm using Docker Compose. I think that we're now in a day and age where people can run Docker Compose up and it just works. I've got a whole bunch of stuff going on here, but all you really need to know about is the fact that I have InfluxDB 1 and 2 running, so I'm using multiple outputs. I have a chronograph for visualizing InfluxDB 1, InfluxDB 2 ships with its own UI. I have a Python application, which is injected with an arbitrary failure scenario, which I'll go over in a second. I have 2 Telegrafs, an edge Telegraf, and then a consumer Telegraf. They're sitting on each side of Kafka. And what does that mean? Let's go here. So let's take a look at our metrics written. So this has been running for a few hours, and we can just see that nothing has gone wrong since I've had this running. We have a linear growth in the metrics that we're writing to the TSDB, which is good. So let's turn that off. Let's look instead at our web metrics. So I'm going to take a look at the response time of the application. In fact, that's maybe a little bit too much. If we drop it down to 15 minutes, we can actually see an oscillation, right? Something is going wrong here. And lo and behold, it's because I am a terrible Python developer. And if we take a look at the code, we'll actually see that we have an arbitrary sleep, which is the number of requests. So if I hit the server once, I get a 1 second delay. If I hit it twice, I get a 2 second delay, continually increasing. Now, this kind of bug might not slip into your code, but this is contrived. And what's actually happened is after roughly 5 to 6 seconds, is that it drops back down to 0 and claims, and then it drops and claims and drops and claims. And this is just because the health check being exposed by Telegraf here, same one from the slides, is emitting something that tells us the application isn't healthy. And if we want to see that, I can just refresh this page. Currently the Python service is unhealthy. I'm not going to refresh it too many times. If I'd wait a few seconds, we'd eventually see that turn to OK. All right, next. Let's take a look at the internal metrics. This is what Telegraf is doing itself. So you can see there's not really much deviation going on right now. This is just me streaming. So I think we're seeing a little bit of performance set on my machine, but that's OK. What I want to do is just test a failure scenario. And I'm going to stop Kafka, which means that we have our edge Telegraf consuming our metrics, but it has nowhere to write them. And if I turn on auto refresh here, I'll just hit submit. Yeah. We're now starting to see there's nothing being written to the database. And we could just give that a few more seconds. We'll see a couple more windows coming in. Nothing, right? So, but we do have a very modest batch size configured on this system of only 50 metrics. So we will see metrics dropped, but that's OK. But we will see the buffer size increase. And I've done that as a small buffer just so we can see that ceiling on the metrics. Now that Kafka is going to come back up, hopefully it will take less than 5 seconds, and we'll see this metrics all be backfilled, well, at least as much as it could before it began to drop any metrics. Any moment now. And well, that's just taken a second. There's one other thing that we have going on here. So we are also using Starlark. And this is the same example from the slides. What I'm doing here is using a little bit of code to filter the metrics to the one that I'm interested in. And I'm actually calculating the percentage of the buffer used. And we should see that inside of our output as well. Good. Kafka came back online. We can see we went to 100%. And I know this is not great to see on a screen, but this pink line just means we hit 100% of our utilization. So that's the buffer percent that we're writing with Starlark. This is not exposed by the native plugins. We then have the orange line, which is just us filling up the buffer. And then everything drops back down as Kafka comes back online, and everything comes back to everything again becomes happy. If we add one more metric, we can add metrics dropped. Did we get any? I don't think so. I didn't leave it down long enough. But we would also be able to monitor metrics dropped. That's a really good metric just to keep an eye on anyway within your metrics pipeline to have some sort of alerting system on. So to finalize and sum up here, running Telegraf in this cloud native way by scaling them out as much as we need allows us to control what data we are willing to lose in the event that certain failure scenarios happen. We're able to define a quality of service by using the batch and buffer size for each application that has its own Telegraf. We control the ingestion speed and rate to our TSDB. And we can handle losing most components of this stack, provided we have enough RAM to distribute to each of the Telegrafs where we want that resiliency to take place. I'm happy to take questions. If you're interested, like it was mentioned at the start, I do have a live stream where I go through all cloud native technologies. It's available at rockcode.live. Thank you very much. I hope you found that useful.
That was fantastic, David. Thank you so much. That's invaluable information. I was jotting down some stuff there as we were running through. While I've moved a little bit away from Kubernetes, we're purely serverless now. So I'm thinking, I wonder if this, especially with the sidecar, I'm thinking, okay, what can I do with this? How can I play with this? It's all open source, you were saying, is that right?
It's all open source. It's written in Go, and because of its plugin design, it's a really great project to contribute to as well as someone that's new to it, because everything is confined to its own little directory. All the files are relatively small, so it's win-win all around.
So running Telegraf in the cloud, what sort of overhead financially are you looking at, or is it size based?
Running Telegraf is pretty cheap. It doesn't consume a lot of memory. It depends on how you configure the buffer size. So you control all of the variables there. You can run it on edge locations. You can run it in microprocessors where there's only megabytes of RAM available, and it's usually quite happy, to be honest. So it doesn't take a lot of commitment financially or even an engineering effort. So it's just plug and go.
For the peace of mind as well, and the metrics, they're always good things to have, Don't just be good, prove you can be good.
Yeah, and the serverless functionality there, being able to run it on tools like OpenFaz or Knative or anything like that, respond to cron or serving requests, and just spin it up and shut it down right away, means that even if you've got an interval of 10 seconds, 30 seconds, or a minute, it's not sitting there idle for that time. So the serverless model is a really good approach too.
Fantastic. I don't have any more questions, and I've already poked fun of your Mr. Blobby outfit, so I'm kind of... Henna, have you anything you'd like to ask, or should we just promote the Raw Code channel for anybody who wants to learn more about Kubernetes, Docker, Telegraf?
Absolutely. I would love to know about Kubernetes. So it's just recently that I've started exploring the cloud side. So everything Kubernetes, nodes, and pods, everything is new to me. So I'm trying my best to gain that knowledge at work.
Well, there's a nice little link on the screen called rawcode.live there that has an introduction guide to Kubernetes. There's a hands-on session for about an hour and a half where we go through just consuming and using Kubernetes from a beginner's perspective. So I definitely recommend checking that out.
Thank you so much. That's amazing. I really like your setup. I see you take a lot of webinars.
I spend a lot of my time in front of this camera talking to myself. Yep, definitely.
Thank you so much.
No, my pleasure. Thank you for having me.
So what topics do you cover on Raw Code Live? What have you got coming up?
So we cover mostly cloud native technologies. So that's anything in the Kubernetes space, microservices, and container technologies. Monday, this is Saturday. On Monday, I'm meeting with a developer advocate for the Cloud Native Foundation, where we're going to talk about the path to becoming cloud native. On Tuesday, we're doing a hands-on session with OpenEBS, which is a CSI storage interface plugin for Kubernetes. And then I'm sure I've got something on Wednesday, and I feel bad for forgetting about it now. But WebAssembly. We're talking about WebAssembly on Wednesday. There we go.
So are these paid tutorials? Is there a membership, or is it? Are you free to air?
No, this is all free. I don't charge for anything. I just love sharing knowledge, and I find this is a really good way to do it in 2020 because I can't be out at events meeting people like yourself and having these conversations. So I find streaming is a really good outlet for me, and I really enjoy doing it.
How very benevolent of you. We really appreciate your efforts. It's not easy to come up with content and then give it away, but I suppose as long as you get that good feeling and educating people, I can see where the payoff is. If there's anything we can do to help.
Thank you very much. I'll definitely be in touch. And again, thank you for having me. It's been a pleasure.
I think, Tim, are you going to give us the rollout for this section?
Yes. So thanks again to Jennifer and Ruth and David. And thanks to you both, David and Henna, for hosting this session, these last few sessions. So we're going to take a quick coffee break now. When we come back in about 25 minutes, we're going to have some really exciting stuff. Some more Kubernetes. We're going to look at live Kubernetes debugging with the Elastic Stack. Then how to kickstart your own SRE culture. And we're going to finish up with talk from someone from Google on growing your cloud application. So we'll see you. And I should say before we go, because I keep forgetting, remember to tweet, use the hashtags. We have JetBrains licenses to give away. So definitely do that.
Yeah,
and
JetBrains.
We'll be back in about 25 minutes. See you then.
Tim, see you, Hannah. Thank you.
See you.
Hello and welcome back to the Cloud Track. And I'm pleased to introduce me to my co-host for the rest of the afternoon, Shalky. Hi, Shalky. How are you?
Hey, Tim. I'm good. How are you?
I'm very well, thanks. So I'll quickly take us over the remaining talks we've got for today. So we're going to start in a second with live Kubernetes debugging with the Elastic Stack. It's always good to see a live demo in a talk of something like debugging. What could go wrong? Following that, we'll be looking at how to kickstart your own SRE culture. And then we'll be rounding off with a talk from Google on growing your cloud application. Just before we start, again, don't forget to tweet. Use the hashtag DevFest, DevFestUKI for a chance to win a JetBrains license. And I'll hand over to you, Shalky, to introduce our first speaker.
Yep. So first talk of is on live Kubernetes debugging with the Elastic Stack, as Tim mentioned, and Emanuil will give the talk. He's a community engineer with Elastic, the company based behind the open source Elastic Stack, and he's based in London. And he used to be a freelance web developer and DevOps lead who ran small open science projects as well. I'll leave it up to you, Emanuil, to introduce yourself and give a summary of your talk and continue to talk.
Welcome,
Awesome.
Emanuil.
Thank you, folks. Thank you for hosting today. And hello, everybody from London, where the weather is likely the same as over in Ireland. Steel skies. So, yeah, today we'll be talking about, well, Kubernetes debugging and how you can diagnose a particular problem. I will, in fact, share my screen and just so dive right in. We have a limited time. I'm on screen 2. Okay. So you should be able to see some slides. Is that right?
Yep.
Yep. Take it away.
Awesome. Perfect. Okay. So today, because it's quite a limited time, what I'll do is I've prepared a particular problem, and we'll go through it and we'll see it from different angles, from like what the logs might show, what metrics might show, and finally what code tracing will tell us. But so without further ado, let's dig right in. My name is Emanuil, as mentioned. I'm a community advocate. I actually went to Elastic because I quite liked the technology, and I like that it's a bunch of open source projects that are packaged together. And I had a lot of difficulty earlier on in my career trying to diagnose problems, and I've had the 3 a.m. wake-up calls and only having logs to rely on, which is partly my own fault because I was also responsible for the monitoring setup. But since then, I've discovered that, in fact, not only Elastic, there's a whole host of vendors that make wonderful tools that can make our lives a lot easier. So today we'll be talking specifically about an app running on Kubernetes, and we'll see some specific tips that might be of use to you when you're running on Kubernetes and using the Elastic Stack for monitoring. So what we will be looking at is this application. It's the standard Spring Boot application. It's a sort of a sample app to demonstrate the Spring Framework web framework in Java. It's a veterinary clinic, so imagine yourself as the maybe senior software engineer who's also on call, very DevOps, of managing perhaps a number of projects at a small consultancy, and one of them is this local vet clinic. So the app is pretty simple. What we can do is we can find pets owners, and we have some personal information about them. Of course, all of it's made up. And we have a list of doctors, and like any self-respecting demo, we're also able to generate an error. So let's have a quick look then at the architecture for this little app. And so we have, of course, it's over-engineered because, in the real world, unfortunately, almost nobody seems to just build a backend website anymore with one data store. but useful for a lot of applications that have multiple services. Okay, so what we have here is we have React running, and then that is talking to two backends. The main backend is written in Java, the Spring framework, and that's talking to a MySQL data store. And here on the right-hand side, I also have a small service written in Flask, and that's talking to Elasticsearch, which I hear is a pretty reasonable data store. In front of all of that, we have Nginx, just handling like any static files that need to be served, and in general handling access. So, and we're monitoring all this with the Elastic Stack. If you haven't heard of the Elastic Stack, at the core of it is Elasticsearch, which is an open source analytics and full text search engine. Essentially, you can throw both numbers and text in it, and then you can get responses very quickly. So with Elasticsearch comes Kibana. It's a graphical user interface. And Elasticsearch and Kibana together have quite good support for time series data, which is where they come into in observability. Then we have beats, which are small daemons, like lightweight shipper programs that will take things like your logs, metrics such as CPU and RAM, and a number of other things. And we'll send those to Elasticsearch, where we then look at them historically using Kibana, and we plot them on pretty graphs. Then we also have Logstash, which we won't be dealing with today, but that's essentially if you have logs which are not in some standard format like Nginx or Apache logs or MySQL logs, basically not well known, you need to parse those logs. Logstash is an incredibly powerful tool for doing that. And we will also add code tracing or application performance monitoring to the mix today. And you can download all of this stuff yourself, including like the server-side components, the data store, Kibana, and run it commercially for free, no limits, like no time trials or stuff like that. You can also have us host it. This is, we are a company that outputs a lot of open source tools, but we of course also need to make some money, and we offer our expertise in hosting all of this stuff. So if you don't want to bother with hosting Elasticsearch and Kibana yourselves and then having to monitor them, kind of a who watches the watcher situation, then you can go and use Elastic Cloud to set up a fault-tolerant cluster that we look after. Right, so let's dig in to the app itself. Right, so basically, at the moment, everything is fine. I mean, the application is working, we're getting responses pretty quickly. But your boss comes over to you and says that they received a number of emails from users of this clinic saying that the app was slow about an hour ago, or like just over an hour ago. This is all the information you have. And so we have the perfect storm, an intermittent problem. That's no longer occurring, right? So hence intermittent. All right, so what do we do? Well, so personally, if the boss comes to you and says that in the morning and you haven't had your coffee yet, and especially if you work with multi-tenanted projects, like you're hosting multiple apps, you're responsible for multiple apps, whether that be in an agency background or IT department, you might not quite remember what is actually running. So in Kibana, here, this the graphical user interface, on the left-hand side, we have metrics, we have logs, and we have application performance monitoring. And we'll look at it in that order. And I'll also show you how to set this up, of course, with some choice config files. And there will be links to everything in the slides, no worries. So this is the inventory tab in Kibana. This is where we start out. And here we have an overview of all of the Kubernetes hosts, like where our pods are running. And okay, like there is a spike in the CPU in some of them, although some of them are doing nothing. But hosts is perhaps not that interesting. It's reasonably useful. Now, if we look at Kubernetes pods specifically, okay, the maximum here that one pod is using is about 33% CPU, which is, again, not that bad. Also, this is a pretty useless interface at the moment. So how about we group things a little bit better? So if we do, in fact, do this the other way around, if we do service type and then namespace, Okay, so this is a little bit better. The point of this step is to just give you an idea of what is actually running on your infrastructure, especially when you have multiple things running, as you are very likely to, even if you have one product, like you're a SaaS company or something, then it's very likely that you'll have multiple services running. And if you're using Kubernetes, probably a lot of the stuff is running, it can be logically grouped in similar ways, like MySQL containers, Nginx containers. So what we have here is we have one MySQL container, we have a number of HTTP, or this is just web application servers, and we have 9 Nginx instances, and then we have a bunch of other stuff. So this immediately allows us to see that even though the hosts are indeed experiencing some kind of CPU spike, our specific ones are not experiencing anything terrible in particular, and we can even select like here, we can look at a specific moment in the metrics. So let's select an hour ago.
Emanuil, I'm so sorry to interrupt, but I'm not sure your screen sharing is working properly.
No?
We're just seeing I think it's a page of the Spring application that says find owners. I can see your mouse pointer is doing stuff, and every now and again you get a flash of something else, but it seems to be fixed on that page. Maybe you could unshare your screen and try resharing it.
Yeah, sure, yeah. That's all. I've used this platform before for another conference at work. Okay, let's see.
You just try resharing it, and hopefully it'll work.
Yeah. There you go. Yeah, so that's displaying as I expect. All right.
Yeah, we couldn't see that.
Thanks. I'll keep an eye on that then. Cheers. Okay. Well, so what I did was I opened the from here. There were these 3 little things on the sidebar. There was metrics, logs, and code tracing, application performance monitoring. So I opened metrics, and the first thing that you see is like 7 computers where where all your Kubernetes pods are running. Standard setup. You have a bunch of large computers, and then you have Kubernetes pods. And then here we saw that it's like, okay, it's somewhat useful, and you can click into those and get more detailed metrics, but that's not super useful. So if we go by service type first, and then my namespace, basically what I'm doing is I'm getting a more accurate map of what's actually running on the infrastructure. The screen sharing seems to be keeping up now. Okay. So the idea here is that we have, we can see that the CPU, even though I set it about an hour ago, CPU is it's at 1 or 0% in the interesting containers where our app is running. And this is overall a pretty nice inventory UI for when you do need to just get a bird's eye overview. Okay, so actually let's click into one of them, metrics. So just to show you like what you actually get. Like basically so far, it doesn't appear to be a resources issue, right? And even though we looked at historic information, which you can get, still didn't really show us something that useful. So, come on. Okay, let me show you how you get this information into Kibana, because like showing you a pretty graph. I'll show you what the detailed view looks like in a second. Well, it just seems to be slow. Okay, so how does all that work though, right? Okay, so we have, in order to get this kind of information, you need to run metric beat. Metric beat collects things like CPU, RAM, disk I/O use. Usually you just run it on like your virtual machine and it collects information about the virtual machine. But now we're running in Kubernetes, so how do you run it? You need to run it as a daemon set. It is a daemon, so that makes sense. So from here specifically, like all these files, by the way, are linked. There's only a couple of configs, a daemon set and a config map. So essentially in Kubernetes speak, a way to run it as a background process and then its own configuration. Right, so this is the bit where you run it as a background process, and there's dozens of lines, so we're not going to go through all of this. I recommend just basically getting the sample file that I linked in the slides if you want to set this up for yourself and then running it. But I will show you more interesting things. So specifically, the way you run metric grid is when you run it as a daemon set, you're basically running it as a container alongside all the other containers that you want to monitor. So previously it used to be called a sidecar container in other Docker setups. But it needs information about both the host and each individual Kubernetes pod and Docker container. So the way it gets that is you actually run it in, you mount the information from the host into the metric beat container. And this is how you do it into the pod. You mount proc, and then in the volume mount itself, you give it specific paths where it expects that data to be. Again, you can just get this from the sample file. Then the other important bit is the way it gets the Docker stats is it needs access to the Docker socket through which Docker engine and the individual containers are going to be communicating. So that's it. Once you expose that, you're pretty much good to go. So that's on the daemon set part. That's how you run metric beat. Okay, you run it alongside your other containers. Then to configure it, the most important thing is this. metricbeat.autodiscover providers Kubernetes. Once you set that up, it will go away and it will look at each container that's running and it will siphon information from there. You can also make it look at specific containers. So here, for example, I'm saying look at Nginx containers that have this particular custom label that I've put on the pod when I was setting it up. And so for those, use this specific configuration. Right? So in addition to the getting the host computers OS metrics and so on, I want you to collect Nginx metrics from Nginx's actual own local statistics. So you need auto-discover type providers type Kubernetes to gather the overall information, and then you can do whatever you want for a specific container. All right, so that's how we did that part, and because we have very limited time, I'll move on to logs. Basically, we didn't really get any useful information out of the metrics. It's not a resource issue, which is usually about as far as metrics get us. You get historical data points, and you can plot them. And let's see if this is okay. Well, you would get a nice pretty graph of CPU and metrics there for each individual pod. Now, if we're looking at logs, we were told that it would be within the last, just over an hour ago, so I've told it in the last 5 hours. Okay, well, so this is too much information. One cool thing about Kibana is that it allows you to navigate very complex data structures relatively easily. So I know that HTTP status codes are called status, codes. So if I just type this, I'll get some idea from the field autofill of what the value of what the possible field names are. And I don't have to remember everything exactly, which is a small feature, but surprisingly useful. So let's say I want everything that's over 400, so everything that's an error, not a redirect or a 200K. Okay, that's a lot better. Okay, so we have centralized our log collection, and now we're down to 3,000 from nearly 700,000. So let's see what this one is in particular. Container name. Okay. That's a 404. They are probably not that useful to have. So what I can do is I can also say what I don't want. So in this case, I don't want the status code to be equal to 404. Because we don't care about that. Okay, that is a little better. Let's see what this first one is. Okay, so it's an Nginx container. Nginx access log. Okay. And this is where we retrieved it from. And I'll show you in a bit like how to set this up. So that file beat gathers all of the logs from all of your Kubernetes containers. Nginx access logs, probably not that useful. So here we can see one example of a field. Like we can slice this data any way we like, but here we can see that event.module is Nginx. So I'm gonna also say and not, and this should autocomplete, and not event module. And here is also quite a cool thing. Not only does it autocomplete field names, it actually autocompletes the top 10 values as well by popularity, like by how many there are in all of the records. So I don't have to know that the string is exactly Nginx. I can just click around. Okay, that is a lot better. We're now down to 4 hits, which are errors, which are not found and are not coming from Nginx. All right, so what do we have here then? Let's have a look. Notice we're getting some interesting information here, by the way, like cloud instance, machine type, cloud provider. This is running on Google Cloud, GCP. We're getting container metadata. We're getting host metadata as well. Here we go, the operating system. So we'll see in a bit how to get this. We're also getting Kubernetes metadata. Okay, so what do we have? What's the actual log message here? It's a put, and the status code, which you can also see extracted separately over here, is a 400. It was a bad request. But even more importantly, the duration was 33 seconds. So this is a problem, right? If you're running in the usual way with just synchronous web workers, then having one of them tied up for 30 seconds is quite a big problem, because they usually, they reply within, 50 milliseconds, 100, 200, 500, and then they move on to the next request. Having it tied up for 30 milliseconds means that you, especially this repeats, you could run out of web workers really, really quickly. So this is a good clue, but that's kind of really as far as we can go with containers. Now, of course, we could go and dig into that endpoint in the code and so on. And this is what I used to do, but I'll show you a somewhat easier way today. So before we move on to that easier way with code tracing, let's see how do you set yourself up so that you also can gather all of that information from your own cluster. Again, we have a daemon set, which will run, in this case, file beat, not metric beat. So file beat is responsible for getting files, usually off disk. In this case, it's responsible for taking the Docker standard out and standard error streams and putting them into Elasticsearch. So this is the basic setup. Again, in here, like you can tell it what to run, what version of FileBeat, and so on, and you will see this in between. Oh, sorry, and you will see this in the sample files, which I'll share. So I'm not gonna sit around too much on this part, which is okay. You run FileBeat in a sidecar container alongside all of the other containers on every Kubernetes node that you have. Okay, so what is the interesting part here? Again, just like with metric beat, we need to give it access to the other containers' data. And here it needs two things. First is it needs var lib docker containers, because after that it's going to go into /logs under there, and it's going to spider all of the logs for all running containers, and it's going to put them all into Elasticsearch, unless we tell it not to for a specific one. So this is a crucial bit. So you need to enable it to do that. And you also need to enable it access to the Docker socket so it can get all that Docker metadata. All right, so then config map. How are we doing for time? We do not have a lot of time. The config map for FileBeat is right here. We have, again, auto-discover, and this is the thing that allows it to go out and spider into varlib Docker containers once it has access to that directory. Again, we can configure it per specific container. But the most important thing is set auto-discover and set the provider type Kubernetes. That's it. Okay, so then if you remember, there was some stuff around like which cloud provider that was, some operating system stuff from the host, from the Kubernetes node, and even Kubernetes metadata from the cluster. And also if you wanted Docker metadata, although we didn't really focus on that today. So here, this processors is how you add it to each log message that you submit to Elasticsearch. That is all you need to do. And if you use this daemon set that I showed you with the 2 volume mounts with this configuration, then you get this information in, which is pretty sweet. Because we're running it as a sidecar container, you need to also say in cluster true. That's important. And that's it. That's how you get this stuff right here. Okay, so, but as I said, we are not getting any further from here because it's a log, it ends here. So we could look at the related logs around it, but easier way is to just look at APM. Remember on the side I showed you we were going to look at metrics, at logs, and we did. And now we're going to look at APM. So that log related to the client side. So I'm going to click into React. And indeed, if you're looking at the last 4 hours in this case, then we'll see there's quite a big spike there. If you haven't seen a code tracing system before, this is what it looks like. Here we have an overview of all transactions for that time period and how many there were per minute, and also like how long they're taking, basically. Now, if I zoom into the really obvious spike, what happens is they get rejigged, resorted. So update owner is now the top one. On average, they're still not taking very long. So basically, they're still really fast. But because we do some sampling to say, okay, what would be the experience for 95% of your users, not just the average. So we look for outliers and we give them bigger weight. So if we do that, then it's huge. It's 30 seconds rather than the average, which would be 3 seconds, even within these like 10 minutes I've selected. All right, so obviously we would click into this transaction, right, and see what's going on. And so that's what I have here. And this is a super useful part of APM. You have normal transactions, in this case, taking less than 1 second. And here we have the abnormal ones, which are taking like super long. Okay, this is distributed tracing here. So the request is coming into React, and you can see it weaving its way through different services or microservices, depending on how you structure your system. You can even see queries that are being issued and the exact line in the service that issued them. And to do this, you just have to instrument every service with APM. And now we're going to look at the abnormal transactions. So we have an error indeed. And if we click on the error, okay, it says invalid zip code. So there is an obvious problem here, right? As you could see from the normal transactions, each of them is taking some time, but it's in the milliseconds. So when I click on here, we can see that this function update owner is taking like 1 millisecond, and this function is taking 31 seconds. And we're getting exact lines from there. So if I look at the source code, which I have prepared here, this is basically the culprit. So we're getting, it's a regex, to no one's surprise. And so in this case, with APM, we can track that down much more quickly. Since I run out of time, I'll show you how that was set up. You would have to set it up for every service. But for the one I clicked into, the React service, it's simple as importing it. So you add it as a dependency in your package JSON, and you import it up here. You require it like this. And then you call init APM. You give it a service name that will appear in the Kibana UI, and you give it the URL where the APM server is running. So you have Elasticsearch running, Kibana, which we've talked about. We have the beats running. And on the server side, you also have an APM server running, collecting all of this information. On the client side, inside the app itself, you just have the APM clients. So that's the setup for this. And it's me almost done. So the idea here is that, like with this kind of stack, and with other stacks as well, actually, we're not the only vendor that can provide this, but I think we provide a really good integration between the three, and from the different angles, you can go from seeing just individual problems and individual services like an island to seeing an entire map. I mean, even for something like metrics, which is just a number, the CPU was that at that moment in time, it's much better to be able to see an overview for what your entire infrastructure looks like. If you want to try it at home, there are some links here, which I will make sure I get to you in the slides. And if you have any questions, you can find me on LinkedIn, Twitter, and by email. Thank you for listening, and stay safe and stay healthy.
Thank you, Emanuil. That was really interesting. It's always a really tricky thing, isn't it, getting observability right? But it's really, really important. So thank you for that. That was really good. We're slightly behind schedule, so we'll move swiftly along. And I'm going to add another co-host. Say hi to Jason, everyone.
Hi, everyone.
Hi, Jason. So, do you want to quickly tell us which GDG you're from?
Yes, so I'm from GDG Milton Keynes. I'm also a GDE for Firebase and Cloud.
Fantastic. And yeah, we are a couple of minutes behind. So Shalky, who've got up next?
Next is Jay Campbell. He'll be presenting on how to kickstart your own SRE culture. Jay is an architect, mentor, and has experience in DevOps, SRE, specifically around the GCP, Kubernetes, and cloud native ecosystems of technologies and processes. So I'll hand over to you, Jay.
Oh. Hello.
Hi, Jay. Can you hear us?
Hi. Can you hear me?
How's it going?
Yeah, it's going
yeah,
really
we can
well.
hear you fine.
Awesome. Nice to see some friendly faces from the last GDG. Okay, so I'm ready to kick off then. Thank you, everybody, for waiting for my session. I'm just going to share my screen. Cool. Can you all see the presentation?
Yep, we can see your screen. We'll leave you to it.
Awesome. Thank you. Hi, everybody. So thank you for coming to this session today. How to kickstart your own SRE culture. So let's kick it off. A little bit about me first. So I'm Jai. Going to be talking you through some tips and tricks that I've learned over the last 3 years while trying to implement SRE, specifically around GCP. But it's not all the things that I've learned. You can use them on other cloud platforms as well. So let's move swiftly across. So quick introduction. I'm Jai Campbell. Been working in tech for around 20 years across all the major vendors, AWS, GCP, IBM. Started off originally on Windows systems. Outside of tech, I have a beautiful daughter. She's 17, so she pushes me to kind of push myself as she's studying as well. And then outside of GCP, I like spending time with friends and family and AR and VR tech. So let's move across. I also run a meetup called London SRE Meetup. So if you're interested in SRE, please pop down and join us. Excuse me. So SRE in 60 seconds. Let's have a quick walkthrough of what we're going to talk about. Generally, SRE, for those that are not quite familiar, we provide services internally, but also externally to our customers. From a very high level, we support the engineering team so that they can do fast releases of their products, and we also support our customers outside. So imagine we're running a website similar to Google.com or Spotify. Our customers are both the engineers deploying the applications and also our customers that are listening to the music. So there's two different kind of viewpoints, and we focus on the reliability of the services. And as you see through the talk, it's going to go across quite a few vectors. So let's have a look at our example corporation. We've got many teams. We've got devs, we've got ops, we've got marketing, we've got front-end designers, QA, security. The list could go on and on and on. And essentially, excuse the typo, they're looking after our Night City application. And for an SRE or for anyone in operations, you can imagine that keeping the reliability of a service with so many teams is going to be quite hard to manage. There's going to be a lot of stress. And especially for those in operations, you go home and you're having to support these systems outside of hours. Quickly moving on is a talk wouldn't be a talk without the necessary cats. So I don't know if Pokemon are cats, but here they are. From an SRE perspective, it was quite interesting. Pokemon Go uses the Envoy service mesh, which is pretty interesting. I've included a link because what it shows you from a real world example is that if you was managing a service such as Pokemon Go that's being used globally, there's going to be a lot of stress. And managing that stress internally in terms of the engineering culture and the SRE team is going to be very important. So what does that look like in practicality? So site reliability engineering, the following graphic here, if we was to base that on the Pokemon Go or again on Spotify, there's many different layers to an application and an environment. If we focus down, let me get the pointer, down here on the monitoring, where it's a banking application, a music system, a gaming application, any kind of application on your phone or system that you use for your computer, observability and monitoring is the cornerstone and the foundation that keeps everything up and running. It's what informs the teams if they can make changes. Excuse me. And if I walk up through this pyramid, so the SRE, they're not just going to be looking after monitoring. They might be working with the incident manager team. They might even form part of the incident manager team. They'll be helping in postmortems, root cause analysis. So if something goes wrong, they'll be there to kind of go in and jump in that meeting and kind of provide feedback. They'll be working with the testing and release procedures. So when we're talking about pipelines, the SREs are going to be working to ensure that the pipelines and the procedures that kind of supplement these are kind of up to date and they work. Capacity planning, we're the Google Cloud event, so we're using services in the public cloud. The SRE team will be building systems and tools to ensure that your application is going to be resources available for you and it's not going to cost too much. Forming part of all that process is the development, and that all feeds back into the product. And there's an iteration loop and a feedback cycle in all of this. But the main thing is that monitoring this environment and embedding and working with all these teams, it gives you a lot of stress, or it can give you a lot of stress under the wrong circumstances. And part of this talk, hopefully, will be how to mitigate that. Okay, so SRE culture, where do I start? More importantly, where would you start if you're new, or if you're thinking about looking at the way that you're implementing SRE kind of differently? So I've got a quote here. There's going to be a couple from this book. So the source is Apprenticeship Patterns. Can't quite see it, but it's a guide for someone stepping into software engineering. If you've been in software engineering for some time, it's an exceptional book to kind of make you rethink the kind of software languages and the processes that you use. So let's read the quote together. How long will it take for a master Aikido? How long will it take to master Aikido? A prospective student asks. How long do you expect to live? Is the only response. And kind of what that means with the culture, with SRE, is that there's not a one-size-fits-all blanket for any organization or any team. The way how you're going to approach kind of planting the seed for good culture and this kind of blameless kind of environment for your engineers and staff, it's going to take time. There's going to be hurdles that you're going to have to work through, and you're going to have to question yourself and look at things from different people's point of view. So it's very much a journey of a lifetime. So a few things to keep on your radar, and I'll flash this up because I'm a bit cautious of time, but we're going to walk through these. The kind of some of these are cornerstones, and some of these are a few things from my point of view as well, especially on the community side. But a few of the key things are accept failure as normal, blamelessness, psychological safety, and community. So let's have a walk through some of these, shall we? One of my favorite GIFs on the internet. Don't worry, I'm a professional. When it comes to production systems in the cloud, I doubt your engineers are going to get their hands on the logic boards. However, mistakes are going to happen, things are going to break. So accept failure as normal. Things break, observability, and document. So learn to accept failure. Nothing lasts forever. Nothing. We're working with numbers. We're working with algorithms. It's all science. Things break. There's inevitability about it. So we need to kind of come together as a team and accept the things we change and kind of the new versions or new features we introduce to our platforms and applications. There's a possibility that something's going to go wrong. To kind of augment that, if we instrument our apps with observability and then we document the procedures that we're changing, we're going to make it easier and it's going to be less stressful for the team. Think of a new joiner joining your team, or if you just joined a new organization, you're coming into a new organization, a new application you don't understand. If there's solid processes and documentation around it and collaboration within the engineering department, you're going to feel more comfortable to pick things up. And if things do break, there's an iteration loop again, there's a feedback loop that you can actually work on these things and fix them. And there's a nice article down here that you can check out about run books, about how they're critical and will make your life easier, say 3 o'clock in the morning. Blamelessness. So this one's going to be a hard one for everybody, depending on the kind of organization that you step into. Again, culture is such a hard thing to change or influence, and it does take time, but this is something that I think everybody can kind of attest to, that they've seen the blame, pointing fingers when something goes wrong. So how do we address that? So we have an open forum to discuss issues. Everyone has a voice. If you're working in an SRE or an operational kind of environment, things are going to constantly be breaking. So you need to have that kind of confidence and the assurances from your team and from the management above you that if things do break, everyone has a voice to kind of make sure that they don't happen again. You don't want to be in a situation where you're firefighting or you're putting plasters on things every day. It's not the way to go. A big part of the blamelessness is root cause analysis. And that might be, you have a P1 incident, you have like a war room, you bring everybody in and you have a discussion about how do we identify the issue? What was the root cause? And sometimes for some organizations, that's very hard to actually change and influence. You might be working in an environment where, excuse me, where an hour of downtime a day is not acceptable, or even an hour of downtime a year. So in these kind of environments, it's going to be a bit more harder for you to kind of influence those. However, it's not impossible. And the reason why root cause analysis is so important is that if you document these issues and you get the people in the room that have some kind of idea of why or how to solve these things, in the future, you've got a template of how to fix future issues. And again, if this issue was to hopefully not reoccur, you'll have lessons learned from the previous time and you'll be able to fix it faster. The blamelessness, when you kind of wrap it up in a bubble, it gives people in the organization a sense of ownership of the application that they're a part of. And it makes them feel more, less pressure to come to work, especially when you're on call. Okay, psychological safety, high fives, or who remembers this TV show, Saved by the Bell? Psychological safety, why is it important? So this backs onto the blamelessness. Again, we're in an engineering environment, we're pushing these quick releases. We need to have an open forum again so that people can speak up, talk about change, have their ideas heard. If they have a solution, then they can contribute to the actual overall fixing. Focus on processes and systems. Again, we don't want to be pointing fingers at people. We don't want to be saying, John made the change to the pipeline. John made the code change and he was the one that made the last commit. We need to identify, can we put more guardrails in place to protect our engineers? So if they're making changes, they're doing all these cool things, they're not scared to push the PR button and then everything goes down and all the blame's put on them. There needs to be some kind of comfort and we need to build that into the systems. And I believe that SRE can help to do that. Another one is to confront hindsight bias. So this is pretty new to me in terms of how it's the wording, but basically hindsight bias and natural instinct to blame a person. I think most of us would have that, where if something goes wrong, we generally think there must be a cause, and it's generally somebody. And those are the kind of things that we need to change about ourselves. And by doing that, we can hopefully change the team around us. So, community. Why is community so important in SRE culture? Because in SRE, again, your customers and your engineers are your customers. There's a large footprint of people that you care about, and also internally in terms of the teams and the applications and DevOps in general. You want to break down silos. You don't want to have a team or one person that fixes everything. You want to spread the knowledge. You want to make it so everybody feels that they're part of the big picture, that they're part of the company. Again, for junior engineers or for people new to the team or just moving around within the organization, it gives them a sense of they can meet people and they're not left by themselves. And again, it breaks down the silos. Guilds and championing SRE best practices. So working with teams or shadowing other engineers. And when you're working with them, cool things that you can suggest is putting monitors or observability into their applications. And then the last one is gamify SRE and DevOps. So make it a bit fun. Again, whilst you're championing best practice, maybe if you have Slack or some kind of forum in your company, you can have like a hackathon on we're all working at home at the moment, so it might be a bit easier for you to do. Or just engage and find out what kind of certifications, training people are doing, and kind of build an internal community where you can share knowledge and have that transfer, and that will filter into the applications that you're working on. So, a few practical steps. Look for the quick wins. So this is, and again, this is to kind of really kickstart your journey. And this kind of is for everybody in any kind of operational team. I'm going to start on the left-hand side. So these are kind of examples that you can identify within the work that you do and say, hey, what either individually, but preferably it'll be with your team, and you'll say, hey, these are some of the issues that I've identified that are happening concurrently or quite a lot of the time. And examples could be the same errors reoccurring all the time. In Slack, you're seeing a notification, or on your phone or something like this. You're constantly firefighting the application or the environment. You're not monitoring a key service that keeps on going down and is causing your team or the business problems. Or automate a manual task. We all know of those. There's quite a few that could save everybody a lot of time, and just that headache, that kind of sense of feeling that, oh no, I'm not having to do this job again. And I have a clear example here. Actually, sorry, I shouldn't skip. Once you've identified one, you want to solutionize it and document the work that you've been doing. And this feeds into collaboration, embedding with other teams. You're documenting what you've done. It provides that feedback loop. And again, if you defined another service, you've got a template ready to kind of apply that to, and it saves you a lot of the work. Once you've done your solution and you prove it works and you've documented, share the report with your team and your senior managers. You want to celebrate the success that the SRE or the operations team have done. Let people know that you're saving time and making the business more money, right? Once you've done that, discuss building on the success. We've identified a problem. We've got this kind of template. The team's on board. Everybody's happy. While there's a positive mood. So yeah, let's do it again. I found this other system that we could apply the same things to, and it's a win-win for everybody. And that again feeds back into knowledge sharing. Your team, they know that the steps that you're doing together are actually being acknowledged, and they're actually producing a benefit and some value. And then that again is a feedback loop feeding into each other. So a clear example of this quick win in an everyday cycle could be you work in any environment. It's either on-prem or cloud hosted. You've got a login server. It crashes at 9:30 every day. Nobody can log in till like 10:30, and it just keeps on reoccurring. We all know the fix. You restart the server and everything's good. However, the long-term solution to that would be to document the issue, automate the solution, and have the server restart at an acceptable time so that people can log in. It might seem simple, but I've seen plenty of examples where really simple things like this could be done. but there isn't the kind of drive or passion to want to make it happen. But these are things that you can do. And again, once you've done these fixes, provide a report, and you want to circulate that throughout the team, the engineering department, and let people know the things that you're doing. You want to build a bit of excitement about the work that you're doing, get people really engaged. Again, it's that feedback loop. So here's an example of a CI/CD quick win for SRE. It's kind of a high-level view, but if you look at this example on Google Cloud, we've got the developers, they're committing to cloud source repositories, we've got Cloud Build pushing the image, and then we've got Spinnaker managing the deployment. So I'll actually lose the trigger. So we've got the developers here committing their code. We've got the build stage. We've got the image being pulled by Spinnaker. We'll probably have a team managing Spinnaker that's doing the deployment. The deployment of the app could go into Kubernetes engine, or it could go into Compute engine. Regardless, we'll have an application here that's being fronted by a load balancer, and then we've got our users. As an SRE, we've got two sets of customers. We've got our developers up here, and we've got our users down here. In terms of this whole pipeline and this environment, there's many areas that we could interject and say, hey, maybe we could automate a bit more of the actual CI/CD over here. Maybe Spinnaker builds are taking too long. We need to save money and resources on our deployment. Or maybe at the load balancer, maybe we're having a lot of hackers or bots hitting our API or front end. So again, you want to sit down as a team and think, where can we draw value and show these other teams and possibly work with them to say, hey, we've noticed this on our dashboards. Let's work with you and make the services better. And that comes with an open culture where you're able to collaborate, where you're able to work with other teams, and there's that kind of cross-pollination of knowledge. In my experience, more so with the older organizations, I'm not going to say who, it's quite a long time ago now, but I was working as a network engineer. We was like level 4, and we had the operations guys sitting about a desk away from us, but the actual office policy was you was not allowed to talk or move to talk to engineers that were not in your team. So it made it was very siloed. So it made working and doing any kind of SRE really impossible. But moving forward, you can change that. And there's a link down here that's got these images, and it's got also other examples of ways that you could think about applying some of these principles. All right, so SRE, a big part of it is make tomorrow better than today. We've discussed some of the ways how you can do that. It's not all about code. There's a lot of it is about culture, getting the buy-in from your peers, buy-in from senior members of staff, from the decision makers of the company. Quick personal example of a quick win that I was involved in. So I was working as an SRE at Condé Nast. The image here you see is just a snapshot of we was running a Kubernetes cluster running on AWS. The SRE team was responsible for the uptime, making sure that the APIs were secure, different variations, and quite a lot of tasks actually. But here's a glimpse of the footprint. We was managing all these brands, and our customers was in Russia, China, India, Europe, and South America. One of the issues that we had was when we had to issue a redirect. It was quite complex because we was going through a stage of onboarding different brands into the environment. But essentially, we needed to change the URL. That process was, even though we was quite good at DevOps, it was quite a clunky process where we'd been tool chaining and building processes on top of other processes. What we decided to do was reimagine the actual process and make it simpler for our junior engineers on the SRE team that was doing night support, that wasn't quite good with Terraform and some Fastly configuration. So what we did in Bash, me and another engineer, we built a sample application, and what that did was allowed the engineers to just simply put in the old URL, the new URL, and it would make the changes in the background. By writing that script, and essentially became an application. Per page URL update, we saved on average 6 hours for that change to go through. And what a large part of that, and the reason why I kind of brought that up, is not just the actual technical change that we made and the technical debt that we saved, but by going through the process, we embedded with about 4 other teams. So there was a lot of bridges was kind of being broken. We increased engagement with the SRE team. And we enabled the junior engineers to kind of shadow us and see the kind of changes they could make to the environment. So there was a lot of collaboration. There was a lot of positive culture that was happening to make this happen. It was a very positive change. Part of this, and the previous talk, regex was brought up. Not all these things that we're going to try to implement are going to be very simple and hard and easy to implement. Part of the solution that we had to introduce was a lot of regex and jumping around with bash scripts. I had a problem, so I used regular expressions. Now I have 2 problems. That was our life for about 2 weeks. But again, make today better so that tomorrow is a lot better, you know? There's a lot of things that you really do have to invest in. Okay, so what does SRE look like in the real world? I'm going to go back to the aspiring apprenticeship, so the apprenticeship patterns. I'd highly recommend you have a look at this book. It's very inspiring. But essentially, draw your own map. There are times when your needs, goals, and aspirations contradict the career path your employee provides. Moving into an organization that offers career paths congruent with your own can protect your passion. And the reason why I've chosen this quote as part of this cultural talk is that as an SRE, there's going to be some really good times and there's going to be some really challenging times. And we're all in a Google Cloud kind of DevFest at the moment. So we're all pretty lucky in that we're surrounded by cloud technologies. A lot of engineers or engineers just stepping out of university, they might not have the opportunity to jump straight into an organization that is practicing SRE or has a culture that feels safe for them and nurtures talent. It might be a more kind of legacy environment that they're going into where it's passing it over the fence. So for the younger engineers, it's very important, or for anybody actually, when you're thinking about your career path, to actually think about, is this going to work out for me in the way that I think it will? And an example of this is Ubisoft. Excuse the pun, gamifying SRE. One of the ways that you can do that, and again for your own organization, is have a look at job postings, job advertisements. I've chosen a gaming because I like AR. I like the Snowjet engine by Ubisoft. But again, as an SRE, it gives me an indication of the kind of responsibilities large companies are going to look for when they're recruiting for SREs. Cloud is constantly changing, constant at the time. Cloud is constantly changing. So you need to maintain. I'm constantly trying to change myself, improve myself, training constantly. And a real cool part of this gives you an indication of what SRE is like in the real world. I actually have quite a lot of respect for Ubisoft. And here's what they're looking for in the qualification side of the actual job posting. So the mindset, here's what you do when something breaks, something or find something very difficult to debug. You say, thank you. Thank you for finding this edge case. Thank you for highlighting this overcomplicated part of our system. Thank you for pointing out the gaps in our docs. And then you go make it so nobody can break it the same again. And that's the cool thing about SRE. If you like challenges, you like problem solving, it's a cool role. But again, to kind of do that in a safe way, you need to have the support and cultural backing from your seniors and from your team. So a quick recap. When starting on your SRE journey, remember these key points. Shared ownership and collaboration. It's not a siloed journey. It's not a single journey. There's no I in team. You want to bring the whole organization on board because that's when it's going to make the most impact. The SRE can start to work with different sides of the organization and add value. And the cool thing is that warm and the positive vibes that happen in the SRE will filter through and hopefully they'll infiltrate different parts of the organization as well. Psychological safety and blamelessness. This is important for everybody, especially now that we're all working at home. If you're supporting a system, again, such as Spotify or any kind of large organization where millions of people are using that every day, if you have the pager, you're going to be worried if that environment goes down. So you need to have a safe space kind of at work where you can speak to people and where nobody's going to be pointing fingers and blaming you. And then again, focus on tomorrow. You want to be working today, but you want to be making tomorrow a lot better. So automate away any task that you can. And then the operations perspective, what is the right level of reliability for the system you support? You can find information on that here. It's a guide on how to shape SLOs, but if you look on it with a cultural viewpoint, it will give you ideas in terms of how not to kind of overpromise when you're kind of building teams and building your services. There needs to be a right balance for these things. Another link, GitHub, for anybody that's interested in SRE education. This is an awesome repo, training, study material, everything here. And thank you. I think I hit right on the head. Hello. Oops. Hello.
Brilliant. Thanks, Jay. That was really good. Fantastic. Good to see. And remember, this is your last chance to tweet about the event for your chance to win a JetBrains license. So remember the hashtag #DevFest or hashtag #DevFestUKI. Shauki, do you want to say anything about our previous speaker?
Thanks, Jay. That was very interesting, and I first learned a lot from today's talk. I think that's it, Jason.
Right. Okay. So here's a man who's definitely not who's definitely trying to keep engineers away from logic boards. He is the host of serverless expeditions on YouTube. I can't talk today. It's been a long day. So joining us live from Mountain View, California, the home of Google, it is Martin. Martin, good afternoon or good morning for you.
Yes, thank you, Jason. Good to be here. Yeah, I say it's about time to open up the beers over there in the UK now, huh?
Yes, indeed. We've got you're the last speaker of the day, and then we've got the party. So you'll be welcome to join the party. We'll crack the beers open then.
Maybe I'll have a breakfast beer with you at the party.
Indeed, excellent. Good. Okay, so Martin, you've got your session on scaling up cloud applications. We'll hand it over to you.
Thank you, Jason. Hi there. We'll talk about scaling up your cloud application. But first, I just want to say hats off to Jay and thank you for that SRE presentation. I'm always impressed by SREs and what they do to keep things running. As being on the developer side, I'm an application developer. That's what I do. It is very easy to sort of forget about what it takes to keep these things running and keep the applications going, because really, you know, if SREs do their job and do their job in an amazing, great way, things just work. Sometimes it's hard to even notice if they do a great job, but tons of SREs are there to make our applications run all the time. Thank you, Jay, for that great presentation. So here, I will talk about scaling up your cloud applications. Who am I, right? So this is what I look like when I wear a denim jacket. My name is Martin Omander. I was born and raised in Sweden. I lived in Silicon Valley these last 20 years. I'm calling in from Mountain View. It's 9:45 in the morning over here. I worked at 3 startups as a software engineer. I worked at Google for these last 14 years. I'm a cloud developer advocate now. That means that I talk to developers about how to make awesome things happen in the cloud and in the Google Cloud, and how to write your apps for the Google Cloud. And I've worked on and off in cloud or serverless cloud since 2007. So what is this talk about? Scaling up your cloud application could mean many things. Well, I think that we are still trying to figure out this cloud computing thing. As business people, as engineers building it, as application engineers like I am, as SREs like we heard from Jay, a lot of this is still unknown, and we sort of put things together in a lab, and sometimes it blows up in our faces, and heaven knows it's blown up plenty of time in my face when I try different things. And this is still a pretty new discipline, so we still need to learn from each other here. So truth in advertising, I'll tell you what this talk is about, and then what this talk is not about. And if it sounds good, stay here. Otherwise, I hear there are 2 other excellent tracks on the DevFest maybe you can switch over to. So I'll talk about how to cope with your cloud application as it grows in size and complexity. And typically a cloud application, at least from my point of view, it's like a web app backend or a mobile app backend. And I've talked about hard-earned lessons made from mistakes with real applications. what this really means is I could have written like a list of Martin's mistakes. I'll talk through a lot of those and what I learned, so you don't have to make those mistakes in the cloud. This talk is not about how to tune app performance. There will be no code, nothing like that. There will be nothing about those actual web apps and the mobile apps. I'll only talk about the cloud and the backend. If green looks good to you, stay. If you wanted to hear about red, maybe you're in the wrong talk. Maybe you want to dial into another, to one of the other tracks. I'll see you for beers later. You are still here. Excellent. That means we can go on. So first off, there's an excellent quote by a very smart man who lived who was active in the 50s and 60s. His name is Marshall McLuhan. People say that he's the prophet of the information age. I think that's the best title. He basically predicted all the things we were doing on the internet, but in the 50s and 60s, before there even was an internet. So he said that social and educational patterns latent in automation are those of self-employment and artistic autonomy. So aside from this being sort of overcomplicated language, he says automation leads to self-employment and artistic autonomy. Maybe you're interested in self-employment, or maybe you're happy working at a big company. I work at a big company, I'm happy here. But artistic autonomy is something that as engineers, we really want. And we can do that. And that is through automation. So here's a sneak peek at the agenda. We'll talk about automate your way to artistic autonomy. We'll talk about 3 other sections here. We'll get to them. But let's talk about automation first. I've noticed, so automation is obviously good, but I've noticed actually 2 ways you should do automations and ways you should not. You need to automate your monitoring, but in the right way. You need to automate your testing, but in the right way. Let's talk about what that actually means and how you can automate these things. This actually helps. Automate monitoring in the right way. Okay, so here's what I did in a recent app I built. I built a beautiful dashboard. So I could see all the revenue, and I could see expenses, number of users, everything. I could see like various data in various databases. It was amazing. I thought I was done. But then the app started breaking, and my dashboard didn't tell me it was breaking. Also, after creating this beautiful dashboard, I looked at it, once a day for a while, then once a week, then once a month. So I didn't, even if my dashboard had told me about this thing happening in production, I wouldn't have noticed. So what happened? Yeah, the app broke, and the response times went up by 10x. Which incidentally meant that my cost went up by 10x for this application. So I had clearly not automated monitoring in the right way. This dashboard was useless in this particular context. So monitoring is nice, but you're not really monitoring unless you have automated alerts. So because, yeah, you think you will check those beautiful reports you built, but if you have to go in and check them manually, you forget after a while. So what you need is automated alerts. 2 simple steps for you to do if you run on the Google Cloud. Install the Google Cloud mobile app on your phone. It doesn't do a lot, this mobile app, but one thing it does that is super useful is that when it sees new errors in your log that haven't appeared before, it gives you a notification on your phone. Very useful. I wish actually the web the web version of this would do it, but the mobile app does it. Super useful. And then read up on Google Cloud Monitoring. It has all these alerts you can set up. It is amazing. Just read up on that works. But start out with installing this app if you run stuff in the Google Cloud. All right. Next up was testing. So automate testing, but in the right way. So there's a lot of talk about test-driven development, and I've made my share of mistakes here. So one big mistake I still haven't fixed in my latest app is actually I don't have end-to-end tests. So that means that several times I've shipped breaking changes because I had unit tests, but they didn't address the things that broke. Typically in a larger web application, non-trivial web application, it's not a single piece of code that breaks. It's somehow these various components talking to each other that break. Like you connect to the wrong database, or an API, a caller and an API don't talk to each other in the way you expect. Those higher level things, they are the things that break. We are smart developers, and we should have unit tests, but unit tests don't tell you that much. They're useful for when developing, but not for actually testing if your app is breaking. So testing is a rabbit hole of infinite depth. So there's so much written about unit testing, integration testing, end-to-end testing, so many testing tools. They're actually not that great, I think. We still, as an industry, we still have a long way to go here. The way I do it now, after learning from my mistakes, is I add tests to risky code as I write it, lean on those tests as I'm writing the code, but I have no illusions that those tests are going to catch errors in user land. And then add end-to-end tests for critical user journeys through the website. So what we need here, and I'm actually still looking, and if anybody has any suggestions, I would love to hear them. I think the end goal here should be a robust, that is not brittle. If you change your website, your testing suite shouldn't break. It needs to be end-to-end test, so it tests your web application, your cloud application as an end user. And it should be no code, because no code means that your business people can set up tests and understand the tests. It means also that if engineers set up the tests, they will do it far quicker than if they have to write code. And it's less brittle. So I'm looking, there are some good candidates out there, but we really need this. If you're running a web or web application, mobile app backend, if you're serious about running a good app, you need a robust end-to-end no-code web testing tool. All right, that was that about automation. There is another concept that is close to automation, and that is productivity. And a man far smarter than me, Franz Kafka, he said, productivity is able to do things that you were never able to do before. Think about that. This is not automating some little thing so that you save 10% here and 5% there, and it enters your semicolons for you. This is making that leap in productivity so that you can do completely different things that you weren't able to do before, different things. So here, through hard experience, I've learned two big lessons. Busy isn't always the same as productive, and you need to understand and love I am. Let's dig into those. So first off, busy isn't always the same as productive. I recently read about this very cool technology that's built into the Google Cloud that's called VPC, Virtual Private Cloud. This is amazing. It's like you set up your network environment, so you set up your servers in it, so it looks kind of like your own data center because it's completely, the outside world can't see it. You define exactly how the outside world, if you want them to look into it, how they do that. I read up about it. I wanted to implement it in my latest app, cloud app. And then I realized it wouldn't add any value to the app. It was cool technology, and that would certainly keep me busy for months. So I gave up. That was a good thing. The root cause here is that as engineers, we're used to solving the problems we know how to solve. So for some of us, that might be, we're used to setting up virtual machines. Great. Let's start a new project. Okay, let's go set up the virtual machines. Let's start a new project. Okay, let's go and figure out the network, configure that. We all have those. If you're a database administrator, somebody says, let's up a new project. You start thinking, okay, how do I set up the database? I'm here to tell you that that may not be your comparative advantage. Your company, your organization is probably not the best in the world at setting up virtual machines or configuring networks or setting up database indexes. You know how to do it and you feel busy and productive when you do it, but you're busy, you're not productive. You have to figure out what your comparative advantage is. And in 9 cases out of 10, I would say your advantage is that your organization understands your users, your customers. Focus on that. Technology, use the minimum amount of technology you can get away with. And here's one way to do that. I really like serverless computing, because with serverless computing, you can just network virtual machines, all of that. You don't have to do that. You may feel less productive, but you're actually more productive if you just let a company, a cloud company, handle all of that stuff for you. So if you're building a new application, I would say, first check out Cloud Functions, then check out Cloud Run, then check out App Engine, in that order. If you can get away with building your backend in Cloud Functions, you're golden. Things are great, and you will get so much more done in a shorter amount of time. All right, so next one was learn to love IAM. So IAM, this is such a hard word to say. Why did they put this acronym on it? I don't even know what the acronym means. Something with internet access management? I don't know. This is about users and roles and so on in your project. So quite recently, I deleted thousands of live accounts from our live database, thinking that it was the test database. So I'm a fairly smart guy, but I made this mistake. I picked the wrong database. This mistake should not be even possible to make. I mean, I could certainly accidentally pick the wrong database, but if I had gone in, I'm a developer on this project, and start deleting, I shouldn't be allowed to delete accounts in production environments. That's ridiculous. Why was it even set up like that? So what you're protecting against with access management is not hackers. Well, hackers too, I guess. But mistakes are far more common than hackers. Think about Hanlon's razor. Never attribute to malice that which is adequately explained by stupidity. You are guarding against this stupidity. You are guarding against the Martins of the world who pick the wrong database and delete all the accounts because they think they're deleting, they're recreating the test database. That's what happened in this case. To really get this right, you have to understand your cloud platform's IAM, the basically users and roles and access privileges. And unfortunately, this is not super easy to understand for most platforms, but you need to study it. You need to get to know it. If you're on the Google Cloud, there's a Coursera course just about that. And I'm halfway through it now, so I'm going to fix this so I can't delete my production accounts anymore. Also, set up your environments very deliberately. So you have one production environment. Developers should not be able to edit anything in it. Developers should or should not be able to read what's in there. It depends on whether you have PII, personal identifiable information. But there's a good, many large companies say developers can't even access anything about production. Then you should have a test environment, one or a few. You can open up a little more for developers in there. So they can read, they can't change the configuration, but maybe they can edit the data in it. And then you have developer environments, and you have one per developer, and developers can change, read, change configuration, do all of that. These environments map to projects in Google Cloud. So you have one production project, one test project, or a few test projects. And you have one developer project per developer that they can play around in. And there they can delete all the accounts. Okay, that was on IAM. Next is listening. A very wise man once said, we have 2 ears and 1 tongue so that we would listen more and talk less. Very good sentiment. What does it actually mean when it comes to cloud computing? I think it means 3 things. These are 3 lessons I've drawn. Provide a way for users to send feedback to you with 0 friction, track all user actions, and you may not need PII. Let's talk about what those mean. 0 friction for users to send feedback to you. So it turns out that in a recent web application I wrote, there was one feature was broken, but I didn't notice because I was using a developer account. And it turns out that that particular feature works for developer accounts, but I hadn't gone through the right process for turning it on for everybody else. So again, stupid mistakes, but we're human, we make stupid mistakes. I would not have known about this. if I hadn't had a feedback form on there. There's a feedback button, you click it, you fill it out. Thankfully, my users, at least one user filled that out and said, this feature doesn't work. Otherwise, I would not have known. Because it turns out that no matter how much testing you have, you need to let users send feedback to you, because you can't find all the errors and the weird user behaviors. And also, your testing is full of assumptions. Without you realizing it, users will first click here, then they will log in over here, then they will pick the thing out of the basket here. Maybe, but your automated tests make all these assumptions. Users need to tell you. So by having that super easy way of like a feedback button that leads to a form, something like that in your mobile app or your web app, so that people can tell you about what you're doing wrong in your cloud backend. That's what you need. So here's some really easy actions to do. Set up a feedback form in Google Forms. This will take you all of 2 minutes. Capture the browser's user agent string in the form if you have a web app. If you have a mobile app, you can capture the equivalent for the mobile app in the form. And then you write a Google Apps script to translate those browser strings, because you will get those weird browser strings that say like Mozilla 5.0, Trident, blah, 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 blah. You need to translate those to human readable browser strings. So now when you read what people are sending you, it says like, oh, this login button is broken, says Bob in Texas, and next to it, it says Bob is using Internet Explorer 11. That way you can get really productive. Track all user actions is the next one. So with modern tools like Google Analytics, it is so easy to do this. There's no reason not to. So I have a rule now for myself. Whenever I add a new button in my front end, I add a Google Analytics event for that. So I know who clicks it, how many people click it, what do they do before they click it, what do they do after they click it. For example, I wrote a very cool app that has some Twitter integration in it. I thought it was amazing. I spent a lot of time building that feature. Very few people use it. So if there are feature requests that come in, or if I think of new features to build around that Twitter integration, I may not do it because it's not used very much. Or another thing that happened in January of this year, I had Facebook login in my app. It stopped working at one point in mid-January. I wouldn't have known if I hadn't had like one event. I track one event when the user wants to log in with Facebook, another event when they succeeded logging in. And I saw that that conversion rate just fell off a cliff on January 21st. Oh, right. So inform your developer priorities should be informed by what people are actually using on your website. So what you should do if you're building applications is check out Google Analytics. If you're writing mobile apps, check out Firebase Crashlytics. These are free tools. There is no excuse not to use them for everything that users do in your application. Then if you want to take it to the next level, and I encourage you to do it, there's a whole suite of other tools that you pay for. These aren't free, like LogRocket and others that record everything that the user does. So you can actually replay, you can hit the play button and see what the user does, where they click, exactly what they enter. Super useful. Capture all of that. You are going to need it. Next one is PII. So we mentioned this before. PII means personally identifiable information. This is IP addresses, email addresses, names, phone numbers, that sort of thing. In the past, back in the days when dinosaurs roamed the earth, we really needed this stuff because, for example, your entire authentication login system, sign-in, might be based on the user's email address. But I would say you may not need it anymore. For example, I was running a system that had hundreds of thousands of email addresses in the database. This is really scary stuff. What if there's a data breach? What if maybe one user can see another user's email address because I made a stupid mistake in the code? It also opened me up to all kinds of legal obligations. We have GDPR, of course, is huge. We have, and in California, there's CCPA, and in Brazil, there's LGDPR, or whatever that one is called. These are popping up all over the way. You may need to have a data protection officer. You may need to set up things so that developers can't look in your production database. This is all because you have personally identifiable information. The less PII you have, the less of this junk in the middle here you have to do. And you can still let people log in. Because nowadays, you can use Firebase Login. And I'm sure there are many other products that does this. I bring up Firebase Login because it's offered by Google and it's free. So put this on your website. When a user logs in with their existing Google account, with existing Facebook account, their existing Twitter account, then you could ask for the email address, but do what I do. Just ask for that number, that user ID. You get a long number that's like 15 digits long. There's nothing personal about it. You can't glean any personal data from it, and use that as the key in your database. And now you're safe. It's safe to have your developers look in the production database. If somehow that data gets out, it's not such a big deal as if you had PII in it. All right, next we have, intentions and liability and so on. All right, so it is a well-known fact that, and it is also a great quote, that a computer lets you make more mistakes than any other invention in human history, with the possible exceptions of handguns and tequila. And this is overheard at a party back when we still had parties. You can make a lot of mistakes with a computer far quicker than you can make mistakes in outside computers. So that means you have to plan for failure. The first one here is you need backups instead of good intentions. Because I've done this, I've set up backups, but I didn't try restoring them. So I was able to restore a backup when I needed. I was lucky, but the behavior was different than I thought it would be. So that led to a few scary moments, because when you're restoring backups, you're sort of in trouble already, and you don't want to be hit by unexpected factors. So, one, take backups. But you're really not taking backups anymore if you're doing them, or you're not taking backups yet if you're doing them manually. You need to automate them. And maybe even if you automate them, you're not really taking effective backups yet, because you haven't tested recoverability. So take backups, automate them, test recoverability. So basically say, okay, let's pretend our database blew up. We're recovering from last Friday's backup. Do it to understand what's going on. And now you have backups. And of course, all these products, all these database products like Firestore, Cloud SQL, and so on in the Google Cloud, they all allow you to click, 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 set up a backup, automated backup to cloud storage. In cloud storage, that is in the Google Cloud, that's sort of the file area where you keep files in your GCP account. Get to know the system, get to know your backups. Next, code is liability. This may be a hard pill for some of us to swallow, because as a developer, all I'm doing all day is creating liability for my organization. Yes, you are. For example, I started designing recently, actually started last week, started designing code. I realized if Google Analytics says I have 0 users in my web app, something's broken. I want an alert if that happens. I started designing the code, it was beautiful. Then I realized, so this would be like 200 or 300 lines of code, I figured. Turns out I can just connect Google Analytics with a service called Stats Glitch, and then I can connect that, and they will spot anomalies. Then I can connect that with a service called Phasier that can send a text message to me. Because any code you write will, dear developer, will on average contain 3 bugs per 100 lines. That is a big cost. Also, you now saddle your organization with the cost of testing and maintaining this code forever. So right now, there are many, many startups, cloud startups no less, that have surprisingly good services, like StatsGlitch, Phasier. There are hundreds of these that help you do things you need to do in your cloud. Also, here's a little secret. They are all funded by venture capitalists. So they don't charge a lot of money because they all want to grow their usage right now. Use them. StatsGlitch and Phasier, I have that set up to warn me when I get 0 users in my web app. I didn't pay a cent for this. Probably some venture capitalist is paying for all of that. I don't know, but it works great. I didn't have to write code. Code is liability. Create as little code as you can. Feature flags and the canary deployments. So deployments are scary. In my apps, I've started storing a lot of these config values in the database. Because there will be bugs in production. You can't eliminate all of them. And rolling back is really hard. I mean, imagine you've set up your entire software development process as a factory with conveyor belts and factory workers and machines. And then if you say, let's do a rollback, that is kind of like saying, oh, everybody stop, everybody in the factory stop. Let's reverse the direction of all the conveyor belts. That's really hard. And there will be even more confusion if you do that. So you need to roll forward. If you deployed a bad feature, you want the ability to just go in and change a field in a database and quietly turn it off. And then you keep rolling forward. Maybe you take out that whole feature from the code in the next deployment. Always go forward. Always have canary deployments and feature flags for new features. And here, Cloud Run is an amazing serverless product. This is Google's newest serverless product because it lets you split traffic across versions. So here's my tried and true version that has been running for a week. Here's my new version that I'm deploying today. Okay, let's send 1% of traffic to that new version. And then maybe 2%, 3%, 10%. If everything's still looking good, I can cut over all traffic to the new version. And if it didn't work, I can go back to the old version. Also, if you do create mobile apps or have a backend for cloud backend for mobile, you should use Firebase remote config, because then you can say, like, in my mobile app, the login button should be blue. It should be red. Tick, tick, tick. Change something in on your server, and now the app is changed for all your users. So do experiment. Be glorious, mad scientists like you are. Create great cloud apps for users. I think we can do this together. We're learning. There's never been a better time to be a developer. And here are the things that I think you should do. And these slides, I'm sure I will send them to Jason, and maybe they'll be on an event website or something. And thank you so much for your attention.
That's brilliant. Thanks, Martin. Amazing talk. It's really good to see you talking about testing. As a developer, testing for me always takes much longer to write the test script than it does to actually write the bit I'm developing in the first place. And I want to get on and always do the next bit. And the time I save writing my code now and writing the test scripts now is sort of far outweighs the amount of time I'd save if I didn't bother, and I'd spend hours debugging issues that happen sort of maybe a month down the line.
Yes, indeed.
Okay, right. I'll hand over to the others to talk about the next part of DevFest. And thank you, Martin, for your talk. I guess, will you be joining us for the party?
Yes,
I know you're a beer
will.
connoisseur. What beer will you be bringing to the party?
I will bring California Cream In. It's a vanilla beer that's brewed just a few miles from here.
Awesome. Okay. I shall try that next time I see you.
Yeah.
Awesome. So thank you, Martin. And yeah, that brings us to the end of the Cloud Track and the end of DevFest UK and Ireland 2020. So just want to say again, thank you, Martin. Thank you, Jay, Emanuil, David, Ruth, Jennifer, Raju, Mete, Guillaume, Sourabh, Tiago, and apparently I did a talk as well. And also thank you to all my co-hosts today, Goran, Shadab, Ashnita, Henna, David, Shalki, and Jason. And before you all go away, here is the link for the after party. There is an enormous Google Meet going on that everyone is welcome to join. And hopefully there'll be some of the speakers and other GDG organizers there, and other people as well for you to hang out with and chat with. And there's also a feedback form here. If you can just type that in or scan the QR code there, and we'd love to get everyone's feedback on how you've enjoyed the stream today. Any final words from anyone before we all say goodbye? Resounding silence.
Yeah, I think we're all good.
Yeah.
What I will say is it's been an amazing event. DevFest is going on this whole weekend. So tomorrow, if you need more DevFest, there will be another one going on somewhere on the planet.
Yes.
Just find one and tune in.
Google it. You'll find the community GDG community website where you can search all over the globe for all the DevFests going on.
Indeed. And the other thing is all of this is recorded. It's on YouTube. So if there's anything you missed or you want to watch again or you want to see one of the other tracks, that there is hours and hours of content from today on YouTube. So you can go back and maybe spend the next week watching DevFest.
Awesome. So with that, we'll say goodbye. Thanks, everyone.
Bye. Nice.
Bye.